Hello my friend, today I will tell you what is Java, what is programming language, what is Java Virtual Machine, what is a compiler and many other things like that, okay? These are basics and this lesson is very important in order to understand anything in, well, any language, not only Java. If you want to understand programming, you have to watch this lesson, okay? After this lesson, everything is gonna become clear. Okay, so what is Java? Java is a programming language that we use to talk with our computer somehow, right? Well, you see, our computer is talking in a bit different language than we are talking, right? I'm talking in English, well, language right now, and you understand me pretty well, right? But our computer likes things like that. 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. Why? Because these are electric impulses, okay? And, well, they jump from 0 to 1, and that's how computer is interpreting everything that you see right now, okay? It interprets the sequences of 0 and 1. It would be very hard for us to write programs like that, right? 0, 1, 0, 1, 0, 1, and it would mean, hey, show me the pixel in the color like that, and for example, I don't know, show the button, click on button or something like that. To imagine writing things like that, that would be horrible. That's why we have got something what is called programming languages that are having syntax that is easy to understand for us. It is not as easy as, for example, right now English, right? But it's gonna be easy when we learn the rules, like we learn, for example, for English, right? Or another language. And well, we just gonna be able to talk. So for example, we can write later something like integer b. And it means, hey, I want to save in the random access memory, so in the RAM, a place for the integer. So it means I want to save a number somewhere, right? I want to find a place like that. And this thing would mean I want to reserve something for computer, okay? It will be, well, this thing would not mean anything because it's also only understand by us, right? It needs to be also changed to 0, 1, 0, 1, 0, 1. And the process of changing this into 0, 1, 0, 1 is called compilation, okay? So programming language is something that is understood by us, but it's, a syntax that can be easily changed into 0 and 1s, right? Okay, so this is a programming language. And why did I put so much effort to, tell you what is a programming language? Because, in Java, the process of compilation is a bit different. It's very hard to understand for people new to Java. And some people do not even understand it after, writing with programs in Java for many years. Okay, so what's going on here? Normally, let's, for example, see here a programming language like C++, right? When you write a code, okay, so imagine here we have got some kind of code. So we have got something like that, right? Int b or other things like that, or something like that in Java or whatever. We have got some kind of code here, and this code is gonna be changed by something what is called compilation, right? So we can write here compilation, right? So this thing is gonna be changed into the 0 and 1s, right? 0, 1, 0, 1, 0, 1. Well, this code is called machine code. It's gonna be executed. Everything is okay. There is small problem in the C++ solution because, there is Windows, there is Linux, there is Macintosh, Android, and other things, and other platforms like that. The problem about it is that when you make that compilation, right? So we changed this code into the 0 and 1s. It needs to know the processor that is gonna execute the instructions here written in that code. Okay, and because of it, when we compile it on, for example, Windows, it's gonna, be able to run only on Windows. So you have to later compile it also on, for example, Linux. And the problem is also that on Linux you can have libraries that are not, for example, on Windows, and vice versa. So or you can have on Windows libraries that are not available on Linux, and then you have to write code many times. Wow, this is horrible, right? If you want to support many platforms. The cool thing about Java, and that's why it's one of the most in demand and highest paying programming language, is that the slogan of Java is write once and work everywhere. Why and how did they manage it? Well, Java is doing something like that. When you have got a code, right? So we have got a code like that. We have got a process that is gonna change this code, right, into something what is called bytecode. Here, bytecode. So it is something like between the code that we have got here and that we have got here, 0, 1, 0, 1, right? That bytecode is not gonna be, useful for us humans because, well, we cannot read it, but it is very nicely written code that is gonna be interpreted by something what is called Java Virtual Machine. Okay, this is a program, this is an application that you can install. This is a platform that you can install on any computer, on Android, on Linux. You can find it here. We can type Java Virtual Machine download, and we're gonna download it later. We're gonna install it, like for example also in an editor or other things like that. And this thing is gonna change bytecode into 0 and 1s, okay? And that's cool, right? It's gonna change this thing into bytecode that can be interpreted on any platform. That's why it's so awesome. But you have to also remember that you have to install this Java Virtual Machine. So without the Java Virtual Machine, it's not gonna be, you're not gonna be able to run it, right? Okay, so that's why Java is so cool. So let's remind ourselves. We're gonna install later something like that. That's called NetBeans. It's an editor that allows you to write a code in place like that. And this code is looking like that, like public class Java application. We're gonna talk like what is the public, what is public meaning, what is class, and other things like that, right? And we're gonna click play like here, and it's gonna compile this thing, right? So this code, the programming language, into something what is called a bytecode, and then the bytecode is gonna be run by Java Virtual Machine, like in time, just in time. Because, well, you might be like now, hey, this must be very slow, and you are right, it is slower than the C++ solution. But you have to choose this or this. You want speed or you want to support all platforms. But it's not also very, very slow because, for example, when you have got a code that looks similar, right? You have got a big code and looks similar in some places, then it's gonna create in the bytecode a special, instructions that is gonna make it simpler, right? It's also not gonna compile all your code if some of the instructions are rarely used. If something is gonna be used very often, it's gonna even sometimes run faster than in C++, okay? Because it's gonna create special connections that are gonna make run things that are run very, very often. So it really depends on situation. So Java is most times slower. Sometimes it might be even faster than C++, But the truth is that you shouldn't worry about it because our computers are faster and faster each day. If you want to write applications, desktop applications, or for example, Android applications, things like that do not matter, right? If you have to use write drivers where speed really matters, then C++ and other languages that are like C++ are very important, right? Okay. Remember that even games are written in Java. For example, popular game like Minecraft was created in Java. So you have to know that there is a process that is called a compilation here, right? So the compilation is changing code from one type of code to another code, right? And compilation also, checks if you made some errors. So if I do something like that, as you can see, and when I click play, hey, there are some errors, right? And also it helps you debug your code, so you can find bugs, the problems, the errors in your code. We'll talk about things like that also later. We will install the IDE, integrated development environment, so that this editor that has got lots of useful tools, and we'll talk about all these things. We'll also install the Java runtime environment, which has got the Java virtual machine inside it. We'll talk about all these things later. In this lesson, you right now know what is programming language, right? The programming language is just some kind of set of rules that you have to follow in order to speak with somebody, right? The programming language is used to create programs, so instructions that are gonna be executed after changing it into the machine code by our computers. So we are, requesting computer what to do. It's like forcing him to do. It's commanding him, hey, do something like, hey, go into the system and then out of it and then print a line like, for example, hello world. And when I click play, as you can see, we have got here hello world. We'll talk about why here is a dot, why here is a public, how these rules work with each other in next lessons. Remember that if you have any questions, just ask me. I really love helping other people. That's all in the lesson. Thank you very much. Hello my friend, today I will tell you 5 the most important reasons why you should learn Java. In my humble opinion, the most important fact is that the Java is the most in demand and highest paying programming language. Why do I think so? Because there are indexes, like for example TIOBE, Programming Community Index, and as you can see, it is an indicator of the popularity of programming languages. And as you can see, this index is calculated using the Google, Bing, Yahoo, Wikipedia, Amazon, and other very popular services. And as you can see, Java is the most popular language, okay? So it's worth to learn it because it's gonna be easy to get a job. As you can see, we can check other websites like, for example, Indeed.com. And as you can see, Java is also very high here. Okay, so why it's also worth to learn Java? Because it is gonna work everywhere on every platform. When you write a program in Windows, you can run that same program on, for example, Linux, okay? So it's very cool thing. And there is lots of resources on the internet, okay? As you can see, there are very cool resources with a full documentation of each classes. We'll talk about classes later. It is very, very cool because, well, Java is an old language, right? So you can find lots of useful information in the internet. People will know how to help you, right? If you have any problems. And well, Android uses Java to create applications, right? Android is the most popular on the mobile devices, which means lots of jobs for Java programmers, and it also means lots of cash. And the last reason is that Java, I think, is easier to learn than other languages, like for example C or C++. Why? Because, well, you do not need to worry about things like pointers. All things like that are taken care by Java, okay? You don't need to worry about things like that, which are just hard to understand, at least for beginners. And well, I'm gonna teach you the Java, so I'm sure that you're gonna learn it pretty easy, because I have got a special method for teaching other people. Remember, if you have any questions, feel free to ask.
Hello everybody, in the previous lesson you learned what Java is. You know now that it is a programming language. It's time to start using this language, right? But to do so, you need to write down the code in some kind of place. So you need something what is called an editor. It would be great if that editor would tell you what you did do wrong in your code. It would color or format the code to make it easier to read. It would take care of compiling your code. It would do stuff that you would normally have to do manually, right? So as you can see, this editor has got lots of tools, and together they create environment for developing programs. And that's what we need to download, something what is called IDE, which stands for Integrated Development Environment. I think NetBeans is one of the coolest free editors. Yes, you can use it for free. You can use different IDEs, like for example IntelliJ. The community version is free, Eclipse, Visual Studio Code. It doesn't matter, to be honest, which editor you gonna use in this course. You can finish this course using any IDE you want. The editor should mainly suit you as a future programmer, so it's a good idea to play with different IDEs and find the one that will suit you the most, okay? So let's download NetBeans. Let's go here and click on download. And as you can see, the newest version is here. So we're gonna click download. And here we're gonna click on Windows version. If you have Linux, click here. If you have Mac, click here. So I'm gonna click here. And then here. And it's asking me if I want to download it. So it's being downloaded right now. And if the interface of the page we are on right now has changed, don't worry, I've added the link to this installation as attachment to the resources of this course, okay? So you can download it under this lecture. Before we install it, this NetBeans, we need to download something what is called JDK. As you can see, I've already downloaded it, at least I tried. And why is that so? What is JDK? Well, let's type JDK download. And when we go here, you can see here is Java Platform JDK 13. This is a version. When we go here, you will notice that we have here something like JDK, Java Development Kit, Standard Edition. And this is a kit, as the name suggests. So it consists of compiler, Java virtual machine, libraries that are essential for you to be able to program in NetBeans, for example, right? Without it, you won't be able to even install NetBeans. So you need to download it. It is a crucial thing to do. And in order to do it, you just accept license agreement here and click on, for example, here, because we want Windows version. But we won't use the official version of Java Development Kit. Why is that so? Because as you can see, here is written something like that. The new license permits certain uses, such as personal use and development use at no cost. But other uses authorized under prior or Oracle JDK licenses may be no longer available, which means that you need to, well, if you are getting money from writing programs, you need to pay them the subscription cost, which you can read more about here. Fortunately for us, there is an open version that you can download here, okay? However, I highly recommend downloading it from this website, because installers from these websites are easier to follow, easier to use. You won't need to bother using this open site here, okay? I highly recommend using the Adobe Open JDK. And here we can choose the version. we're gonna choose the newest one. Don't worry if there is version 14 because they have speeded up the version so much lately that even programmers do not care about them. To be honest, they change versions so fast right now. People are really using the version 8 right now, but they create new versions because well, somebody need to pay for it, right? And you are wondering probably now, what's the difference between the free version and the paid one? Well, there are sometimes security breaches, right, in programming, and they will be fixed faster in this edition, okay, in the one that is official. Here they are gonna be fixed too, but a bit later, right? So if you have a big company, probably you want to focus on this. If you are just learning, if you are not doing any big programs, definitely just don't even bother to use the official edition, okay? Because other things are the same. So when you click here on other platforms, you will notice that we can choose also Linux, we can choose the Mac, we're gonna choose Windows. So let's download it. Here we're gonna choose JDK, which includes already Java runtime environment, which includes Java virtual machine. Don't worry if you don't want to remember by heart all these abbreviations that I've presented here. The most important for you right now is to just install it and focus on programming, okay? So we're gonna install JDK, save the file, and let's wait a second. Okay, let's open it. It says that this is executable file. Are you sure that you want to open? Yes, we are sure. Okay, let's run it. Let's now click next, and let's of course read the agreement, accept it, next. Here remember to choose this option and this option, then next, install, and just wait a second. It's time to click finish. And now we need to install NetBeans. So let's do it. The process is easy. Of course, read the agreement, accept next, and here it found the JDK that we have just installed. If you don't have anything here, it means that JDK wasn't installed properly. So try to install it again. Next. You can check for updates. It's a good idea to check for updates, install. And this process will take a while, about 3-5 minutes. It really depends on your computer. Okay, the installation completed successfully, so we can just finish, and that's only the lesson. In the next lecture, I will show you how to create your first project where you will put your code. Hello, today I will show you how to create your first project in NetBeans. In order to do it, you click on File, then New Project, and then from these categories you can choose a template. So how your starting code should look like. It's just gonna help you. You don't need to create, basic files each time again and again. It just does it for you. As you can see, you can program in HTML, in a PHP. It's just up to you. NetBeans is used also for other programming languages, but we're gonna choose Java with AND. What is AND? AND is, this small being. No, just kidding. AND is a build script to build, run, and debug your project, okay? So there is also Gradle, Maven. There are differences. To be honest, it doesn't matter for you for now. What are these differences between these building tools? Just use AND, stick with it. Don't worry about these names here. So focus on Java with AND, and we're gonna choose Java application because we want to create Java applications. And then we click next. And here we type the name of our project. So for example, name of my project, right? And then I click finish. And that's how we've just created our first project that is called name of my project. As you can see, IDE, which is Integrated Development Environment, has got here lots of tools that we need to learn about. For example, here on the left side, we have got something like a project manager where we can see folders with the files that we are currently working on. We have got now only one file that has been automatically created with the template that we used. And this is the entrance to our program. As you can see, it says to us to do code application logic hero. So when we write here something like, for example, this, of course, don't worry what is that, because we're gonna explain it better in the future. Well, I'm going to explain it better in the future. And when you click play button, as you can see, we have just compiled our program, we have built it, and here we have a result. That's cool, right? We didn't need to do anything manually because everything was done by this integrated development environment. Here there is lots of other stuff, like for example history. You can see, oh, so I did it today something like this, so I changed this into this. So as you can see, it can help you follow what you did in the current day or the last day. There are many useful stuff in IDE. We will focus on a few of them in the future lectures step by step, so don't worry. For now, notice that IDE is also colorizing the key words, like for example class, public. Of course, we're gonna talk about things like that in future, what they mean, but notice that because of it, your code looks better, right? You can, instantly say, oh, so here is a class, oh, so here is a public thing, right? Oh, so here is my main thing. You can instantly see where is what, because it's colorizing your code. That's not all. NetBeans can help you also spot errors, like for example, let's remove S here. As you can see, when we move here our cursor, class interface or enum expected. Also, we expect here something what is called class. Okay, now everything works fine. So when you make errors, you're gonna be informed about. Let's remove the colon from here. Expected. Okay, so let's add it back and our program works fine now. This is pretty cool, right? Because, people tend to make mistakes and you're gonna make thousands of them. And this is pretty normal, especially if you are beginner, but even if you're advanced, you're gonna make mistakes while you are programming. This is normal, so do not worry about it if you feel like you are outcast or something like that. No, this is pretty normal at the beginning, so don't worry about it. Okay, that's all the lesson. Thank you very much.
Hello, today I will tell you what are comments and why it's worth to use them. So I have created a new project that I called comments application, and as you can see, I have got here some code, and between this code I have got comments like that. So everything that is colored in gray by that editor is a comment, and it means that it is not gonna be interpreted by compiler. Okay, so this is the place where you can give additional information about your program, because normally if you did something like that, for example, this is a public class. As you can see, the compiler is trying to interpret this thing, all this text here. But if you do it that way, which is one line comment, you can do it pretty easy, right? You can comment your code. So why would you want to comment your code? Why spend your time doing it? Well, because we are people, and people forget things, like, right? We are just humans, so we are not perfect. And because of it, after you write your programs, and when you come back to your programs after even 1 month, not 1 year or 3 years, even after 1 month, when you come back to your program, you're not gonna almost remember anything about it, really. So that's why people are commenting things. And that's not the only reason. The second reason is that you can work in team, right? You can work with many people at once, and they will not understand your code instantly, but with comments, it's gonna speed up the development process of your program, of your perfect application, big application, right? That's why it's really very, very important to comment your code. So there are two types of comments. One line comment, which allows you to comment here, as you can see, but when you click enter, you cannot see any more comment, right? It's not gonna comment this here anymore. If you want to have multi-line comment, well, you can do, of course, something like that. But it would take lots of time if you want to then delete something, right, from middle, for example, like that. You need to do blam. You can use something what is called multi-line comment. You just type slash, then the asterisk sign, and then you can type comment, right? And as you can see, this editor automatically changed that, well, inserted here these signs here, right? So now you can have multi-line comment like that. You have probably noticed that the generated comments that are here have got additional asterisk. Well, you don't need them here. They are just here so it looks better. But there is a small difference between this and this. If you start a comment like that, it's gonna be later used for the Java documentation. Okay? There is a program called JavaDoc, which is generate a documentation. So this is a pretty big difference here. We're gonna have a special lesson where I'm gonna teach you how to create properly comments, but we cannot do it right now because we don't know what is class, what are arguments, how to send them, what are functions, other things like that. I'm gonna show you everything like that in future lessons. For now, you just need to remember that you should create a habit to comment your code. Not everything, but things that are just a bit harder, okay? It's a good idea to comment your code because it's gonna save you lots of time, not only for you, but also for your future team. Okay, that's all in that lesson. Thank you very much. Hello, today we'll talk about basics in programming in Java language. Well, the first thing I would like to tell you is that when we remove comments, we have got here something what is called white spaces. White spaces are enters, tabulators, spaces, and well, they are not interpreted. As you can see, I can play it. Well, I can have everything in one line. Look, wow, we can do it even like that. Bam, bam, and bam. Everything is in one line, right? It doesn't matter for the compiler, it is a computer, right? It's just gonna interpret everything like it's, formatted well. But you should format everything pretty well. And you should do it the way that I will do it in the future lessons, okay? If you follow how I format things, your code will be readable, not only for you, but for other people. And this is very important to understand, right? So for example, instead of writing a plus b, you can write a space plus space b. It's gonna be easier to read. And well, I'm talking about these white spaces because, well, you need to know that we can write everything in one line because of things like, for example, semicolons. You have to remember that after every instruction, you have to end it with the semicolon. Every instruction is a command to your computer. What is a command? Well, a command, an instruction, is just forcing your computer to do something. So when you write something like that, you say, hey, I want to include a package called basics, which is here. If we had more files here, it would mean that you could use all informations from other files like that inside here, right? So that's why we have got the package named basics here. And well, right now you know what is package, right? You can include other packages from other people that were created by other people, and you can use then things from there. And what are these things from there? Well, they are classes. Here is a class created automatically by our NetBeans, right? This is the main class. It is public. What is public? Wait, well, it doesn't matter. It's just a modifier. You just need to know that for now, the main class has to be public the main class, which is the class that has got the name like the file, okay? And well, what is a class, you might be wondering also. A class is just a container for things like properties which are gonna describe something. Like for example, a window, we have got a window here, right? And this window has got what? A width, height, and you can do things with that, like for example close it, and you can for example maximize it, minimize it, right? You can do things with the window, and things like that are gonna be described inside the class. So you could create a class that we will call window, and inside of it we would have properties like width, like height, and we could create a function which is something like that could allow you to close it or open it. And as you can see here is a method, which is a class, which is a function really. So this is similar name, right? Method, function, and it's called main. And the reason this function is here, that it has to execute all instructions that are inside of it after invoking it. The main function is very special because it's gonna automatically be executed after clicking here play. So if we create an instruction here, so for example system, which is a class somewhere, and when we get to something what is out, which means that we want to get out something from the system, right? And we want to print something, for example a text, like for example sample text, this thing after clicking play is gonna be printed here, as you can see. So this function is gonna execute other functions, other instructions. As you can see, we have got here a semicolon because this is an instruction, right? You have also probably noticed that here we have got a curly braces. Curly braces says where, well, you have to say where the class is starting, right? So the basic class start from here and ends here, right? You don't use semicolon for it because, well, if you had semicolon here, still the compiler wouldn't know, well, hey, this semicolon is for what? For this class or maybe something else, right? So that's why we have got curly braces. And method also needs to know where it has to start and where it has to end. So here we invoked, so it means that we use somebody code that is stored inside the print function, and this print function is, as you can see after clicking play, showing something here. And we're gonna create our own functions in future lessons. You're gonna learn lots of functions from libraries that are gonna help you, for example, create a window like that one, or calculate something hard. So this is the reason of creating functions, and that's how you use them. These are the basic functions that we're gonna use in the future lessons. Keep in mind that this is a very, very fast introduction, and you don't need to worry if you don't understand that. Well, what is that string here? What is that thing here like that? What is void? What is static? What is public? Why you didn't tell me about this? It doesn't matter. For now, you just need to know that this code is gonna be invoked first, okay? And later I'm gonna introduce to you something like variables, then arrays, then we're gonna go to the functions, methods, and other things like that. Why do we have modificators like that? What are exactly classes? How to create them? How to connect many classes to each other? Other things like that, right? For now, we need to know that main functions is a special function that is gonna be invoked as a first function, and it's gonna invoke all possible instructions between this curly braces and this curly bracer, okay? And we're gonna learn the syntax of Java in future lessons. That's for it for now. Thank you very much. Hello, welcome in the bonus section where I will show you the most useful shortcut that's gonna save you lots of time when you're gonna develop programs, your own programs. Why? Because, using your mouse is just a bit slow when you have to save things. So for example, 5 and then go to the save here. it just takes time when you need to copy something. So when you do things like that, mouse is just always slower. And you have to remember that you're gonna spend lots of time writing a code as a programmer, which means that knowing all these shortcuts is gonna save you time each day. And when you multiply it by the days that you're gonna program, it's gonna save you lots of days of your very precious life. Okay, so let's start from this first shortcut. Control plus S. From S is from save, and it's just saving the file. You will notice that when I change anything in the program, that you have got here a bolded file, and I'm automatically saving always using the Control plus S. Why? Because, well, when, for example, I would lose the power, right? I would lose all my work, right? Some editors can, get back to the place where you have lost your power, but some doesn't. And this is the universal shortcut you can use in an editor. So it's very important to know it. The next one is used to copy things. Well, it's slow to copy things like that. Bam, and now, oh, here is a copy, and then now enter here and then paste. It takes lots of time. You can just use Ctrl plus C, then Ctrl plus V. And as you can see, you can copy it. And as you can see now, when I didn't want to have a change like that, I can go back using the Ctrl plus Z. This is very cool shortcut because it allows you to go back when you did something to your code that you didn't want to do, right? It's very, very useful. This is that one. But sometimes you might click it a bit too many times, and you can use the Ctrl plus Y. It will redo the action. Okay, so you can go back to the place where you started going back. And well, you can also cut something. So you can, you can copy, but in the same time cut the thing that you want to copy from that place. You can, for example, remove it from here and paste it here, right? Okay, let's go back to the original file, and let's now find out what is the Ctrl plus F shortcut. When I use the Ctrl plus F, as you can see, now I can search for things inside our project. So I can find, for example, main function. I can find, for example, where is the public keyword, where is the package, or other things like that. I can instantly find things, and it really helps you a lot. Almost any editor has got something like that. Even in the web browser, when you are browsing for something, it's very important because you're gonna browse for to learn about libraries for Java, for example, and you want to find something specific about Java, you can just use the Ctrl plus F in the web browser and you can find it faster, okay? So it's very useful shortcut. Ctrl plus A, which stands for all, and you can just select all things from your program. Why something like that is needed? For example, you can just do something like that. Now then Ctrl plus C, and you can paste the code from here to, for example, a place where you want to ask somebody why it doesn't work, right? So we can Ctrl plus A, Ctrl plus C, Ctrl plus V somewhere else. So it's very useful. Ctrl plus backspace. Sometimes it's gonna happen that you want to delete something, like for example a word here, right? The truth is that you want to, for example, remove a variable, but we will talk about variables later. And if the name of variable is long, so you need to do something like backspace, 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 right? But you can also do things like Ctrl plus backspace, and as you can see now, you delete full word at once. So it's also cool. And this thing is also very useful. It is tab and shift plus tab. This one you probably know, but this one, oh, this is very useful, and many people doesn't know that you can go back with your indent, right? What do I mean? Well, let's create a variable int a and let's assign here 4. We'll talk about later things like that, but this is a code and we are checking if a is equal to 4. If yes, then I want to print to the output blah blah blah, something like that. And well, as you can see, we have got here an indent, and sometimes you might have a problem. So for example, you have a code like that. Oh, it's not looking good, right? You can go back using the Shift plus tab. As you can see, you can go back using something like that. And the cool thing is also that you can use the tab to move many, as you can see, things at once, and you can go back also. And well, what else? You have got here also something what is called end and home on your keyboard. When you are, for example, here and you click home, you are at the beginning of the line. When you click end, you are at the end of the line. And when you want to, for example, copy something like that, you can do something like Shift plus home. And as you can see, now we have got selected the line, and now we can use the Ctrl plus C, and now we can click N and then enter. And as you can see, now you can copy it pretty easy. What's more, you can use the Shift and the arrow keys to select more than one line. You can also use the left and right arrow key to select specific, as you can see, character, and then you can copy it, right? So Ctrl plus C, Ctrl plus V, and then bam, 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 bam. As you can see, it really improves the speed of copying things in your program. Of course, I'm doing things like that very fast right now. It might be new things to you. So just train. You just need to train, and finally you're gonna know all these shortcuts pretty well. You have got them all described. You can print them. So just train. And you have got also something what is called Ctrl plus Home, which allows you to jump from the place where you have got your cursor. Okay, so you can jump from here to the home of your program and to the end. It's very useful because you can sometimes want to go to the top of the program, and it's also useful because you can use the Shift plus End, Shift Ctrl plus End, and as you can see, now you are selecting with using something like that, right? Ctrl plus Shift plus End allows you to select from the place, from the cursor place, and home like that. There is also very important shortcut for this editor. When you type, for example, something like system, then you click a dot. As you can see, you have got here many hints, right? But sometimes you can lose them. You can do something like that, and you want to somehow get them back. You don't need to delete the dot in order to see it again. You can also do something like Ctrl plus space. As you can see, then you get hints like that. So it's very useful to get hints. You can also use the Ctrl plus space to, for example, create a code, like for example a loop for. As you can see, then you can just change things here, and you have just created a pretty big code. This is called a snippet, right? You can create a snippets like that using the Ctrl plus space, and well, I want to check if something is true or not. So this is pretty useful. As you can see, while loop and other things like that. Okay, so that's all in the lesson. Just train it. Thank you very much. Hello, today I will tell you what are variables, what is a type of variable, what type of variables you can create. So a variable is a container that you can use to store information, data, like for example, numbers, characters, and other things like that. So variables are looking like that, right? A container that you can name and you can put something inside. And well, the truth is that it looks more like that. You have got a RAM, which is random access memory. Yes, that's why you need RAM. You want to reserve something from your random access memory, right? And when you do it, you can store there, for example, numbers, characters, or floating numbers. So numbers like that. And how to do it? How to give an instruction to your computer to reserve something from the random access memory. In order to do it, you type something like that in the main method. Int a, for example. So I have just reserved in the random access memory a place for numbers, for integers, int stands for integer, right? Which is a number. And now I can store there a number. How to assign there a number? How to change the value there, right? In order to do it, we type the equal sign and then we say what we want to assign there. So for example, 10. So right now we reserved in our random access memory, because this is an integer is saving 33 bits, which is 4 bytes of your memory. So yeah, it will take 4 more bytes. Your program will take 4 more bytes when you click play. And well, you assign there 10, right? This assigning is called initialization. When you assign a value to variable the first time. So you can later, of course, change this value, or of course you can also send it to the output using the, for example, system out print line. This shortcut that I've just used is when you type the cout and you click tab, as you can see, then you don't need to type all this thing again because of the NetBeans IDE. So I've just sent 10 on the output. As you can see, it's working fine. And of course you can change this value anytime. So you can change it to, for example, 15. And as you can see, now it's 15. So that's how you change a value. Well, variables are called like that because they are able to vary, which means that they are able to change, right? And we have just changed the value of the variable like here, which can store, of course, only integers, which are numbers. So we have to remember to be careful to not set something like that, right? Because this is called string, which is sequence of characters. You cannot store characters inside different container that has got the wrong type. Okay, so we need to learn about all possible types that we can use. So if we wanted to store here something like, for example, string, we need to type string. Then, as you can see, we can easily store something like that. So for example, my name, right? And of course, as you have probably noticed, I can't assign to a string a number, right? You can't change the value to the different type value. So when I play it, as you can see, here is my name. You can of course create, and you should name it a bit better. So for example, name, and now my surname, right? And now we can do something like name plus surname. Plus is used to connect two strings. And as you can see now, it's Arkadiusz Włodarczyk. If you want to add a space, you're just gonna do something like that, right? Arkadiusz Włodarczyk. You've just added a space here, right? Using this quote signs. So that's a string. We need to do something in comment. Let's create it. Let's describe what we have just learned. So there are integer types like the int, and it's 33 bytes. Let's copy it here from here. And well, you can store there from -2 to the power of 31 to 2 to the power of 31 minus 1. Well, we could go into this a bit deeper. You just need to know that you can store values from that range to another range, right? So when you do something like int a, you cannot assign here something like that, because this say, hey, you know, this number is just too large, okay? It's too big, you cannot do it. But hey, what if I wanted to assign here something big? Because, you know, sometimes you want to do some scientific stuff. Then you're gonna use, for example, long. Long is 64 bits, and you can store there numbers from -2 to 63 to the power of 63 to 2 to the power of 63 minus 1. And when you do something like that, as you can see, now it doesn't work still, but it's because by default any number looking like that is integer. If you want to change it to the long, you need to do something like that. You need to type at the end L. Let's do it with the big letter so we can see it, right? And now when we get it to the output, as you can see, it's working. If we did it that way, it's not gonna work. If we did it, for example, that way, it's also not gonna work. Okay, so you need to add this L at the end to say that you know what you are doing. You want the big number here. Okay, and well, what in the other integer types do we have? We have got some short one, like for example byte, which is 8 bits. Byte is really 8 bits, so it's nothing surprising. This is the smallest amount of information you can store. 1 bit is the smallest information you can store in your computer, which is 0 or 1, right? And the range is from minus 128 to 127. So you're gonna use a byte when you don't want to store big numbers like that. You want to store just very small numbers, and you don't want to use too much space in your memory, right? You're going to save your memory. You can also use the short integer, which is 16 bits, and you can store there from 32,078 minus 32,768 to 33,767. So you can do something like that, right? And you can store there just a bit bigger number between this and this. Okay, so these are integer types, and now character types. You can use the character type to store a character. So for example, well, let's create a character and let's assign here a character like A. And let's get it to the output like that. And as you can see, we can see a character here. You can store here only one character. We cannot do something like that, right? If you want to do something like that, you have to use the string, which can store sequence of characters. And look at the difference here. Here we have double quotes, right? Here we have an apostrophe, which is single quote. And if you want to create a string, you need to use that one. If you want to create a character, single character, you have to use the apostrophe single quote, right? That's very important to know. So of course there is a string which can store many characters, right? So the one that we have learned here, like that. There are two more types, which are called floating numbers, which allows you to store numbers with a fraction. So like for example that, right? In order to do it, we should use the type that is called float or double. So float is single precision, which means you can lose precision here. And double is double precision, which means that it's better to use double precision. The truth is that right now almost nobody is using the float because it might give you more headaches than good things. Okay, this has got 33 bits, this is 64 bits, and this one can store 1.4 multiplied by 10 to the power of minus 45, so the fraction is very small. You can have 45 zeros, right, after the dot, and to 3.4 multiplied by 10 to the power of 138. So So it's very big number, and here is even bigger because you can store here 4.9 to the power of, wow, minus 323, so it's very big, and here 308. But as I said earlier, do not use float unless you want to store very small number and you don't want to almost do any operation on it, okay? And you really want to save the random access memory, which we have tons of it, right? Right now it's so big that we shouldn't most time care about something like that. But if you do not need to do any operation, you need to store a number that is, you know, that doesn't have many things after the dot, then, well, yeah, you can use the float. But there is a small problem. When you create the float, for example, number, right, and you assign here something like that, you will notice that, hey, here is something wrong. You have to cast it to float. What the hell? What's going on? When we do something like that, as you can see, the program is not working. So float is not working at all. When we create a double, it's working fine, right? But double, well, any number that has got a fraction, that has got that, is automatically adding here something like D, right? Which stands for double. Okay, now it's working fine, as you can see still. For float, you need to just use here an F. Why? Because, you know, some people could make this mistake to create float number, not knowing that it's single precision, and it can create for him problems that would be very hard to solve, okay? So that's why instead of float, it's better to use just double, okay? Unless you don't do any operation on these numbers. It's also good to know that when you are creating variables, you can create many at once. So you can create something like int, and then you can do something like C, D, E, F, G, right? Without any problems. It's a good idea to add here spaces so it looks a bit better. And of course you can initialize one of them, for example like that, and it's gonna work fine, right? Oh, of course you cannot use the variable that is uninitialized, which means that it doesn't have a value. So you need to do something like that. Okay, that's all in that lesson. Thank you very much. Hello, today I will tell you about naming conventions for variables. I will tell you also what you should avoid. So naming conventions means how you should name your variables. The first thing you should remember that you should create a variable that should be self-descriptive, which means that it should be like when you look at it, you know exactly instantly what it's gonna be used for, okay? So when creating a variable and you call it A, it's a bad idea. Of course, I used it in the last lesson, but it was just to show you how to create a variable, but you should avoid situations like that. Your variable should be self-descriptive. So if you are creating a string that will store names, you should call it name, okay? If it's gonna store surname, call it surname. So surname are cut. The second thing you need to know is that the size of each letter matters. So if I want to change this name, I shouldn't type something like, for example, that, because it is not gonna work. As you can see, it's not working because this variable is not the same as this one. If I did something like that, I'm just gonna create another variable, right? With just starting letter, which is big. And you should also remember that you shouldn't start name of variables with big letters, because this is a convention. Variables should always start from the small case, and then if you want to have, you know, something like name and surname, for example, right, then you should do it that way. You should, for each word, try to have the uppercase of letter. Okay, so now you can instantly see, hey, it's a name and a surname instantly, right? Oh, okay. Because if you call it A, you don't know what is stored here exactly. You have to look at the value. Okay, maybe this value is very easy, but maybe this value is sent from the file and you don't know exactly what is gonna be here, right? So always try to name everything to be self-descriptive. And well, you should know that you cannot create as the name of variable, as the label of variable, you cannot use keywords, which means that you cannot do something like that in public. As you can see, it's just not working, right? You cannot use things that are reserved. Why? Because, you know, interpreter is just going one line by line and it's trying to compile it. How can he compile it when he knows that static means something totally different, right? It's not gonna work. The second thing is that you shouldn't start creating a variable from the number. So you cannot do something like that. As you can see, it's not working. You can have numbers inside, like for example here, doesn't matter, but you cannot start from the number because, you know, the compiler thinks then that you are creating a number, not a variable. And the third thing is that you cannot use spaces, so you cannot do something like that, of course, right? Because, well, it just doesn't work. There is also one more convention that you should know when you are creating a variable that is constant, which means it's final, it cannot be changed. Like for example, p, number p. So for example, when you create p like that, I'm gonna use, as you can see, big letters because it is not gonna ever change, right? It's always 3.40. So when you're looking in your program, then you know which variables are constant, final, and which aren't, which cannot be changed. And you can even say exactly, hey, I don't want this variable be changed, and you type then final before it. Because of it, when you do something like, for example, trying to change it, as you can see, we have got an error. Without the final here, as you can see, you can change pretty easy this without the final modificator. So you have just learned also what are modificators. They can modify how the variable is gonna work in your program. So let's use the final, let's leave it like that. And well, it's good idea that if you had more than one word in the final variable, to do something like that. For example, number dash p. Okay, you are not, because you are not gonna do here, for example, small case letter. You just, if you want to give a space there, you should use the underscore because this is unreadable. This is readable pretty okay. And well, that's how you should create variables, how you should name it. Remember, self-descriptive variables are very important in order to make your code clear and easy to maintain. That's all in the lesson. Thank you very much. Hello, today I will tell you what is casting. Casting, it means changing a type of variable into another type of variable, and it is used in situation like I will show you soon. For example, when we create a system out print line method and I do something like 1 divided by 5, you probably think that here we will have as a result 0.2, but the result is 0. And when we do something like, for example, 4, hey, it's closer to 5, it should be 1, right? No, it's still 0. But, well, if you do 5 divided by 5, then it's 1. If you do 8 divided by 5, it's 1. If you do 11, it's 2. Which means that the result of division of two integers is always an integer, right? we just take the fraction away and just throw it to the bin, right? It's gonna be deleted. But hey, I sometimes have situation like that. A divided by B, and I don't want as a result 2 here, I want here 2.5. How to do it? Do I need to change the type of variable? No, you don't need to. You can sometimes want situation like that, and then you're gonna do it that way. You're gonna use casting. If you want to cast a type of variable into another type of variable, you're gonna type the parentheses, then the type of variable you want to cast to, then the next parentheses, and the name of variable you want to cast to another type. So right now you want to change the integer to double, and if one of the variable is double, it's enough to be to the result. So the result becomes, as you can see, also double. Okay, so if I did something like that, C divided by D, it's gonna give us as a result, of course, 0.8. If I do C by B, it's also gonna give us the as a result the double. So that's how you use casting. But let's see it in other situations. So for example, let's create a result and let's do something like that: A divided by B and double result 2, C divided by D. And let's get it to the output. As you can see, the result is 2, of course, because 5 divided by 2 is 2.5, but the result is what? Integer. And now imagine a situation you want to divide A by D. Yeah, you want to divide two different type of variables. Well, you have probably noticed that we could do it that way, right? Here it's gonna work, but here something is not working fine. Why? Because, well, here we just printed it out, but here in the line 11, we want to assign the result into the variable called result. That type is int, right? We want to assign double into int, and it's not possible. So you have to change the result into the integer. You have to say the compiler you know what you are doing. Because here, as you can see, it says incompatible types, possible lossy conversion from double to int. So it means that, hey, you can make some problems here. I want to make sure that you are doing everything fine. So you have to use the casting, right? But not to double, but to integer, because you want to change the D into the integer. So you have got the integer divided by integer, so the result is integer. And now everything works fine, right? Because 5 divided by 15 is 0.33333, but you're gonna throw away the fraction. That's how it should work, because this is a division of two integers. Okay, let's see what would happen if we did something like that. C divided by A. So we want to divide to maybe C divided by, 12 divided by 5. It should give us as a result, as you can see, 2.4. It's double because, well, double by integer is double, okay? So you can assign double to double, right? So everything works fine. But if you want to see as a result here, for example, only integer, you could do just something like that. Hey, I want here an integer. And as you can see, now we have got here 2, right? We can change it any second to another type, doing something like that. You also need to know that sometimes you can do things like that, and as you can see, the result is wrong. So if you want to fast change the result to the right result, you need to change one of the type to the double, right? Using the casting. But you can do it a bit faster way. You can do just something like, for example, that 1.0. Why it's gonna work as that? Because this is the true double type, the value of double. You need to use the point. But hey, you are thinking right now, in line 8, you are not using something like that. That's true, but in the background, the compiler is gonna change the integer into double here, okay? It's because double has bigger precision and that's why it's gonna work, right? But as you can see, for example, if you do something like that, it's not gonna work because, you know, double cannot be stored inside an integer because double has got bigger precision. It can be a big number and it has got lots of more bytes and other things like that. So you cannot do things like that without exactly saying, hey, I want to change this into the integer. I want to lose everything from, you know, after the dot, right? You want to lose the fraction. So that way it will work. Okay, so that is casting, and there is another thing, another place where you're gonna use it. It's gonna be used when we're gonna talk about polymorphism, but it's gonna be in the future lessons when we're gonna talk about object-oriented programming. For now, it should be enough for you. That's all in that lesson. Thank you very much. Hello, today I will tell you what are operators and we'll talk about arithmetic operators. So, operator is, as the name suggests, an operator or something that is operating on something. In our situation, it's gonna operate on variables, so it's gonna do some actions on variables. And in this lesson, we'll learn about arithmetic operators. So, for example, plus, minus, asterisk sign, and the backslash sign. As you can see, they are used for adding, for subtraction, multiplying, and dividing. These are pretty easy one, so we'll focus on a bit harder one, okay? So this one you just use by, you know, typing on the left side one variable, on the right side another variable, and it's the same like if you did in on math lessons. These are the basic operations. It's 100% that you know them. So let's focus on things like here. When we have got a variable, so for example int a, and I assign it to 5 to it, and we send it to the output. As you can see, we have got 5. What would happen if I wanted to increase the value inside that variable a by, for example, 3? What to do? Well, I will need to do something like that. A assign to a plus 3. So we are assigning here the value that was in a before, so 5, and now we are adding 3, so 5 plus 3 is 8. And because of it, as you can see, we have got 8 here. So in order to change the value without losing the last value, you have to just assign the value that was there in the first place. You might be like, but hey, how does he know that here is 5, not the new value? Well, the instruction is gonna be always executed from the right to left. So first we are going to add 5 plus 3, and then we assign the sum of it to a. So as you can see, that's how you do it, but well, it takes a bit of space, and you know, every programmer is a lazy person, but in the intelligent way. So you can type something like that. As you can see, it's working also. Well, let's delete this one. As you can see, we have got here 8. So yeah, plus 5 plus 3 is 8. So this is a shortcut for doing something like that, okay? Of course, you can also use it to do other things, like, for example, let's subtract from this, for example, 2. So you have 3 as the result. As you can see, the result is 3. You can, of course, multiply. So we'll have 5 multiplied by 2. So it's 10. 5 multiplied, well, divided by, for example, 3. As you can see, it's 1. Why? Because 5 divided by 3 is 1.66666. And this is an integer operation, right? Because this is an integer type. The result is also integer. If we change it to double here, of course, the result is having the fraction, right? Okay, so that's how you use the shortcuts, and you use them because, well, these are very often used operations, so it's very useful to know about them. You will surely meet something like that in your adventure when you are gonna program. And well, you can also use something like incrementation and decrementation. Incrementation and decrementation allows you to fast add one or to the value, to the original value, or decrement the original value by one. Okay, so for example, we could do something like that a plus plus, and as you can see, when we execute it, we have got here now 6, because 5 plus 1 equals 6, right? And of course you could also write something like that, and it's the same, but you know, it's shorter. So we are even more lazy here. This is the most frequent operation when you are doing anything with loops that we'll talk about, for example, in next lessons. So these used very often, so they even more decrease the amount of characters you have to type in order to achieve something like that, right? So we are just decreasing the amount of characters we need to type, doing things like that. Of course, you can also use the decrementation, but there is also one more problem here, something like post-incrementation and pre-incrementation. Post-incrementation means that you are gonna increment after sending it to the output, and pre-incrementation means that you want to send it to the output first, with the value already increased. Well, let's show it an example. Here, when we do it that way, it doesn't matter because we are not sending it to the output in the same time. Where it matters is, for example, here. When I do it here, a plus plus, as you can see, we have got 5 here. But if we did something like that, you will notice that we have got 5 here, but then 6. Why? Because, well, it is a post incrementation, which means that we have to firstly show on the output 5 and then increase it by 1. So it will be, the value will be increased by 1, but you will be able to see it only later, after this instruction here, right? If you want to change the behavior like that, you just need to type something like that. So as you can see, now we have got here 6, and here is also 6. Of course, the decrementation also works the same. So as you can see like that, when you do it that way, you will notice that we have got 5. Firstly, because we are doing post decrementation, which means that we want to first send the value of variable to the output. And there is also something what is called the mod operator, the reminder of division operator. This is one of the coolest operators because it gives you the remainder of the division. It gives you the fraction, right? What is rest of the division. Let's see, for example, let's do something like 5 mod 1 mod 5. What will happen? What will be the result of this? As you can see, it's 1. Why? Because 1 mod 5 is just 1 divided by 5. So it's like something like we just take this place here, right? When we do something like that, you will notice that we have got 2. We just take the fraction, right? But what happens when we get here 6? As you can see, we have got still 1. Why? Because 6 divided by 5 equals 1, and 1 divided by 5, right? So we are taking just this place from here. And well, if we do something like that, it will give us as a result 0. Why it's 0? Because 5 divided by 5 is 1, and point zero. There is nothing after the dot, right? So you might be like, hey, but you say that it's very cool. Why it's so cool? Because imagine a situation when you want to do something after each 3 rounds. So for example, when somebody click on button 3 times, I want to show something special. If he doesn't, I don't want to. So how to do something like that? Well, look, when somebody click first time, we could increase here a value. So for example, a variable, right? We could assign I here, and we could do something like that. I mod 3. And as you can see, it's 0. So it is the first time. And then we could increase the I, so we could do something like, oh, let's do it that way. I++. And as you can see, now it's then 1. Again, it's 2. And then when somebody clicks the third time, as you can see, it's 0 again. Because 3 mod 3 is 0. And then again, when we do the same thing, as you can see, it's 1. So every 3 times, this result is gonna be equal to 0. So we can use this information. We can do something like the conditional statement that we'll talk about later. We could do something like if the expression like that equals to blah, 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 0, then we can do something, and well, things like that we'll do in future lessons, right? But this is very useful for situations like that, when you want to do something, when you want to invoke special instructions after somebody, for example, clicks the button 3 times, right? When, for example, you want to have each third row being colored or something like that. You don't want to have all of them, but you want to print to the output many rows, but you want to have only colored each third one, right? Then you could use something like the modulo operator. Okay, that's only the lesson. Thank you very much. Hello, today we are going to talk about relational operators, which are most time called comparison operators. Well, they are called comparison operators because when you are relating to something, you want to see how two things relate to each other. Relations are, a connection between two people, right? And you want to compare how they relate to each other. And in our situation, you want to compare how variable, for example, A compares to variable B. So you want to check if they are equal, if one of the variable is, for example, greater than the other, or maybe it's lower, right? So how to do it? Well, let's create a variable, for example, A, and let's assign here 5, and let's create a variable B, and let's assign here, for example, 7. And I want to check if they are equal. How to do it? Well, then you just need to use the comparison operator, which looks like that. It compares two variables and checks if variables are equal. And you might be like, hey, but I can see here that they are not equal. Why do you even bother checking it? Well, you can see it, right? The program doesn't. That's the first thing. The second thing is that you don't know most time what values of your variables have. For example, you can create a form where somebody can put things there, right? You don't know what numbers will be there. For example, the numbers can come from database, they can come from the file, they can come from the Android application, other many examples like that. So right now, we don't know how to do other things like that. So we are doing just basic things like that. So you can compare, right? So let's do something like cout and the system out print line, and let's compare A to, for example, B. And as you can see, we have got here now something saying false, What's that? Why do we see here false? Because 5 is not equal to 7, right? If I had here 5 and here 5, you will notice that we have got here true. And now we have just discovered a new type of variable, which is called boolean, okay? So we can create a variable that is called boolean, and we can call it whatever we want. So for example, is, for example, true. And we can assign here, for example, a equals b, right? Like that. And do something like that. As you can see, it's the same. So you can save to the boolean type only true or false. So you can save here false. As you can see, it's working. You can save here true. It's also gonna work. But you cannot assign here any other value. So you can't here assign here 5. You can't assign here 1, 0. I'm showing it now because if you had programmed in other language, these things would mean something. In this language, you can only assign here true or only assign false. Okay. So that is the boolean, and that's how comparison of two variables work. But you need to remember, and it's very important, that this operator is used for what? For checking if two variables are equal. But this operator, where you have got only one equal sign, is used to assign, right? This is very important because some people make a mistake, like they try to, instead of comparing, they assign by mistake. Because in the math, when you compare things, you are just comparing using the one sign, okay? That's why some people have a problem like that. So I am just, telling you it now and taking so much time just because so you will not make a mistake like that. Okay, so this is that, and you might be also asking yourself, hey, why do even bother using it, doing something like that? Well, in the future lessons, you will find out that there is something what is called conditional statement. You will be able to do something like if, and then you can, for example, use something like if, for example, a equals b, then I can print something like test, right? And you will notice that we can see test here. If we change the values, so for example like that, you will notice that nothing happened, right? This is a conditional statement. You can check if something equals to something and you can decide what to do. That's why relational operators are cool. We'll talk about conditional statements more in next lessons. And well, let's talk about other relational operators. You have got relational operator like that, which just checks if two variables are not equal to each other. You have got also something like greater than, right? Or equal to. So if you do something like that, 5 is not bigger than 7, right? And as you can see, we have got here false. And well, if we change it to 5, as you can see, we have got test here. So it's working fine. Of course, you can use the single character like that. It checks if something is greater than, so then something else, right? So if we have something like that, it's gonna return true here. That's why we have got here a test. And if we do something like that, well, 5 is not greater than 5, so we will not see a test. And of course, less than and less than or equal. They work the same, so you can just train a bit and do research on your own on this operator here. Okay, that's all in the lesson. Thank you very much. Hello, today I will introduce you the concept of logical operators. Logical operators are gonna operate on logical values. What are logical values? Logical values is true or false. So these are the values that we learned about in the last lesson, right? They can be stored in the Boolean type of variable. So it's gonna work on true and falses. But before we gonna learn them, I would like to show you why do we even need them. Let's create a variable, so for example a, and let's assign to it 5. Let's create a variable b and let's assign to it, for example, 7. And we learned that we can use something what is called conditional statements to compare something, right? So we could do something like if, and then if a equals to b, then we can show to the output, for example, true. Right now it's not equal. Let's change it so it's gonna be equal. And as you can see, we can see here it's true, right? Let's say something like that. But what would happen if you had one more variable here? So for example, c, and it would be 7. And I wanted to check if a equals to b, and in the same time I want to check if the c is greater than b. Then what? Then we need to know logical operators. But this situation is for you very theoretical. So you might be, hey, it's not something that makes me think that these operators are gonna be important. They will be very important because logical operators can be used in situation, for example, like that. When you have a desktop application, you can have a form in there, right? And imagine that you have got now a string, for example, password. And here is a password of somebody, right? Then another string, for example, repeated password. And we can see if that guy repeated the password the good way. So we could compare if password equals repeat password, and for example, if is terms of condition checked, and we could save here true or false, right? We could now check using the logical operators that we're gonna talk about soon, if the password is the same as a repeated password, and in the same time somebody checked the terms of condition. If not, then we will just not allow him to do something, right? I don't know, register or other things like that. So it's just up to you what will happen then using the conditional statement. But in order to do something like that, you have to know logical operators. Otherwise, you will need to check everything in another conditional statement. It will take lots of time. It would be just horrible. And well, you can use logical operators to, for example, check the range of numbers. But well, let's go into logical operators now. So we can finally see what are they. Well, the first logical operator, the easiest one, is the exclamation mark sign, which is the negation of operation. It is like saying no. Okay, so let's do something like cout, and let's do something like true. As you can see, we have true here, but if we do something like that, we just change true to false. So true is gonna be false, false is gonna be true. And it is used most time in situation like that. It's terms of condition checked, so we could do something like if not checked, then do something like blah 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 blah, right? That's just up to you what you will do then. For now, we just know that we can just print something out. It's nothing cool, but that's how we do it, okay? And the next cool one is the conjunction, and you use the two ampersand signs in order to use it. So conjunction is represented by the AND word, and it means that you need to have both expressions true at the same time. What is expression? Expression is just something like that, right? If is A equals to B, okay, it's equal to B, so then it's true. And now we can, and in the same time, C is, for example, greater than 5, so greater than A, or whatever. Let's just type here 5 or 4. Yeah, it's greater because 7 is greater than 4. So we're gonna see test here. So conjunction allows you to connect, right, two expressions. That's the first thing. But when it will return false or it will return true. Well, conjunction is true only if both expressions are true in the same time, because it's the word and, right? If you say something like that, well, I am going to go to the cinema tomorrow and I will buy popcorn. It means that you are telling that you will do both things, right? You are not gonna go only to the cinema, or you are gonna only buy popcorn. You are gonna do both things. So if we have expression 1, let's create a table, and expression 2, and the result of that. So if you have, for example, true and true, it's gonna return true. If you have true and false, it's gonna return false. False and true is gonna return false, and false and false is gonna return false. So it's only true when both expressions are true. So let's write it up. So conjunction is true only if both expressions are true in the same time. Okay, and you have got also something what is called alternative, and you use these signs here. And well, you use the word or. Sometimes most times it's called disjunction, but I think the alternative is better word for it, because it gives you alternative option. When you have well, let's copy it because I don't like to write. And the results will be just different. Alternative says something like, hey, I want to choose the alternative good option. And imagine that good option is true option. False means that something is just working bad. So if I have a good option to choose and another good option to choose, I will choose one of them. So the result will be true. If I have a good option and a bad option, I will just choose the good one, right? I don't need to choose the bad one. Bad option, good one. Bad option, oh no, I don't have anything to choose, so I will have to choose one of them, and it's false, damn. Right? Okay, so this junction is false only when both expressions are false in the same time. That's the difference between conjunction and disjunction, right? In this situation, both need to be false in order to make it false. In this situation, in order to make it true, you have to have both expressions true. So if we use the alternative here, you will notice that, well, is 5 equal to 5? Yes, then, well, you don't need to check the other part, right? Because, well, 5 is equal to 5, it's true, then it doesn't matter what will happen here. If it's even false, it's gonna execute the instruction here, as you can see. But if we make both expressions false, so is A not equal to B? Okay, so we can say that it's false, this expression. And if C is greater than 4, it's greater, so we have to increase it to, for example, here to 5. So is C greater than 9? No, 7 is not greater than 9. Okay, so both are false now, and because of it, we cannot see the text here, right? The text is not visible if the condition is not met. As you can see, we cannot see it, but if we change it, even one of the expression to true, bam, it's working. So logical operators allows you to connect two expressions, and because of it, you can do some advanced comparisons, right? Okay, that's only that lesson. Thank you very much. Hello my friend, today I will introduce you the bitwise operators. Bitwise operators allows you to work with bits. Bit is the most basic information that your computer can store. It is 0 or 1. These are impulses that your computer, electronic impulses that your computer is gonna interpret, okay? There are many sequences of the 1,0,1,0,1,000 millions of sequences, and they are interpreted into everything that you can see. And you can work with the 0 and 1s using bitwise operators, okay? And before we start learning them, I would like to tell you where you can use this knowledge. You can use bitwise operators, for example, when you want to compress data, when you want to do some data encryption, when you want to work with colors, when you want to communicate between ports and sockets. So this is a topic about connection between computers. So if you are not interested in topics like that, you probably don't need to know this too much. But if you are interested in topics like that, it is just a must-have, okay? But it's a good idea at least to know what's going on. You know, it is a good lesson to know how to see how some things are done in our computer. So before we go into the binary code, which is 0 and 1s, we have to talk about our code, which is decimal code. When I have number 126, this is truly something like 1 multiplied by 10 to the power of 2 plus 2 multiplied by 10 to the power of 1 plus 6 multiplied by 10 to the power of 0. So as you can see, here are the numbers from that decimal number, and here is then here is how many numbers are in our system that we are using to count. So it's 10, and as you can see here we have 2, 1 and 0, which represents the position here. This is the first position, so here is 0, we are counting from 0, so 0, 1, 2. And it's gonna be the same for the binary code or another code. When you have a number, for example 1010, let's change it to the decimal number. 1 multiplied by 2, because this is a binary code, to the power of 0, 1, 2, 3, to the power of 3, because it's on the fourth position, so 4 minus 1 is 3, plus 0 multiplied by 2 to the power of 2, plus 1 multiplied by 2 to the power of 1, plus 0 multiplied by 2 to the power of 0. And it equals to what? 1 multiplied by 2 to the power of 3 is 8, plus 0 multiplied by anything is always 0, so 0, plus 1 multiplied by 2 to the power of 1 is 2, so it's really true, 2. And 0 multiplied by anything is 0. So when you look at this, it is 10. And well, this is at 10 when you do something like, for example, integer a, and you assign 10 to this integer, you really reserve in our RAM a place, 32 bits, and there are 28 zeros, and then there is 1010, okay? That's how it works. And 1010. Of course, I didn't count how many zeros are here. So this is a number in the binary code, and you might be like, do we have to really do so much operations in order to count this to this every time? You can really do it a bit faster. I will tell you how to do it. Look at this here. Here we have 0 multiplied by 2 to the power of 2. When you have 0, the truth is that there is just 0, because 0 multiplied by anything is always 0. So we can just do something like that. And here something like that. Okay, so it's smaller now, right? And now you know that the 1, when 1 is multiplied by anything, it is neutral. It will not change the thing that happens here, right? We did not change the result. So it can look like that. And as you can see now, it's pretty simpler than the thing that we had before. So let's train a bit. When you have 1, 1, 1, and for example 1, what is this number? The truth is that you can just think something like that. Here is stored 1, here is stored 2, here is stored 4, here is stored 8. So these are numbers that you get the power of 2. So it's 1, 2, 4, 8, and then 16, 32, 64, 128, 256, and so on. And because we have got here always ones, it means that the result of this is 8, 12, 14, 15, right? And if we had something like 1, 0, 0, 1, it means that we have as a result what? Here is stored 1 and here is stored 8, right? We do not care about this 0 here. We just think about places that have got 1 here. So 8 plus 1 is 9. So you can very fast see what is under number like that. Okay, so now we know how the binary code is working. Now we need to learn how to use the bitwise operators, finally. Let's start from the bitwise AND. As you have probably noticed, it looks very similar to the conjunction, which had 2 characters like that instead of 1. And it also is gonna work very similar, because 1 is really true, 0 is false. But only, of course, for this operator, okay? So do not assume that true is in Java is 1, because this is totally different type. But it will be easier for us because we learned the table in last lesson, and we said that the conjunction is true. So bitwise AND is true only if both expression, and in this time if both ones are the same. So we can do something like that. Let's send to the output something like A in conjunction with, oh, maybe 10 in conjunction with, for example, 5. So here is 10, right? Let's create 5 now. So it's 0, 1, 0, 1. Here is 1, here is 4, so 4 plus 1 is 5. And when I do a conjunction, what will be the result? So 1 and 0 in conjunction is 0, because we don't have 2 ones here. 0 and 1 gives us 0, 1 and 0 gives us 0, and 0 and 1 give us 0. So the result is 0, right? If we had something like, for example, not 10, but for example 11, so we had something like 11 here, the result is what? 1. As you can see, it's true, it's 1. Okay, but you might be now like, really? Where can I use something like that? This is looking like very unuseful thing. Well, for example, let's imagine a situation that you created some kind of forum and people have their privileges. And you can store privileges in something like that: 0001, 0010, 0100, and 1000. And imagine that this first here is representing that somebody can edit post. Next one is for posting. The third one is responsible for example, deleting. And here you can, for example, ban somebody. Well, whatever. These are privileges, and you can go so on, right? Like that. And then you can assign pretty easy in very small number to somebody that, hey, you can do something like banning people, deleting things, and for example, you can't post, but you can edit post. So somebody can do this, this, and this, okay? And this number is equal to what? Well, this number is equal to 1 plus 4 is 5, 5 plus 8 is 13. So if I do something like 13 and for example 1, so I am checking if he can edit. As you can see, the result is 1, right? Let's check if he can post. The post is really the number 2, right? Here is the number 1, here is 2, here is 4, here is 8. So if I do 13 with the conjunction of post, which is 2, you'll notice that we have 0. So this guy cannot post anything. So we can store many privileges in one small integer instead of many variables. And we can then check if he can, for example, if the person can post by comparing something like that with something like that. Pretty cool, right? So this is just one of many usages. I think this is one of the most popular one, at least for people who will not compress and do other things like that. Okay, so we have got also Bitwise, which is working the same like the alternative logic, right? But with the bits. So let's change it here to, to the alternative. And 13 with the alternative of 2 is what? Maybe let's use this number here. So it was 11 and here we have got stored 5, right? So 11 and 5 will give us what? 1 and 0 gives us 0 because we choose the alternative option, which is 1. 0 and 1 is also 1. 1 and 0 is 1. 1 and 1 is 1. So it's gonna be, as you can see, 15. If you had a situation like that, so 11 and 1, in this situation 0, 0 and 0 gives us 0, and the result is 1, 2, 3 plus 8 is 11. So that is the operator alternative, and you have got also something what is called XOR, which I presented here. It is exclusive OR, and it differs from the normal OR in that thing here. Normally, this would be true. 1 and 1 would give you true, right? But the exclusive OR says that it's exclusive, right? You can have only one option that you can choose. You can have two options that you can choose that are good. That's how you can remember it. So 1 and 1 is here. And as you can see, the result is 10. That's because 1 and 0 gives you 0. 0 and 0 gives you 0. 1 and 0 gives you 1. But 1 and 1 gives you 0 this time. So that's why, as the result, we have got 10. So one can use, for example, XOR in a situation like that. XOR is cool because, look, XOR is gonna return always 0 if both things are the same. So you can check for equality using, for example, XOR. If anything is a bit different, it's gonna return a value that is different from 0. So there is two more operators, well, 3, that allows you to move bits to the left. So for example, if you type something like 1 and let's move it, maybe let's try 5 and let's move it to the right by 1. As you can see, we have got 2 here. Oh, maybe it will be easier to present it at 10. We have got 5 here. So here we have, for example, number 10, right? And this number, when we do something like that, is gonna be moved to the right by 1. Everything is gonna be moved to the right by 1. What does it mean? Well, this one will be here, right? So we'll have something like 0, 1, 0, 1. Because there are many zeros, right? I remind you. So this will be 0, 1, 0, 1, and it equals to what? 1 plus 4, which is 5. So the truth is that we divided this number by 2, typing here 1. If we did something like that, we're gonna divide it again by 2. So here is how many times we want to divide this number in this place to the power of 2 to the power of 2. This time maybe 2 to the power of 3. How many times we want to divide it, right, by 2. So that's how it works. Of course, when we do something like that, you might be like, hey, but why it's still no 2.5? 5 divided by 2 is 2.5. Because this is integer, right? This is not a double number, so that's how it works. And left shift, so moving to the left side, is gonna multiply it by 2. Here is gonna multiply it by 2 and then again by 2, so it's gonna be 40. You're just moving everything to the left side. You have got also something what is called bitwise negation. And this is gonna change. So for example, when we do something like that, as you can see, this number to -11. It might be like y. Bitwise negation is changing ones to zeros. So this 0 becomes 0 and these zeros are now 1. But hey, look how many zeros we had here before it. So we had so many zeros and now they're all ones. And when the first bit is 1, it will represent the negative number. Okay, that's why it looks like. When you use the calculator in the Windows, when you click 10 here, as you can see, here is our 101, and here are many zeros. And when you click not, as you can see, the first one is here now 1, and that's why we have got number that is just not a positive number. Okay, that's all in that lesson. Thank you very much. Hello, today I will tell you about one of the most important topics in programming, which is called conditional statement. As the name suggests, conditional statement is the instruction, a statement that allows you to condition things that happens in your program. So for example, when in future you will learn, for example, how to program an Android application, somebody will put something to the form, for example, his email address, and you want to check if the email address in the first input is the same as the repeated email address, right? You want to check if something is equal, right? So conditions are used in situations like that. You want to check what is inside a variable, because right now we just know that you can create a variable and you can assign here something, and we already know what's there, so it will be like, hey, do I really need to check it? Of course, there are many other situations when you're gonna use conditional statements. For example, you want to run some instruction as long as for example, a variable will be equal to 10. Things like that are called loops. So we are gonna talk about the usages in other lessons. Right now, let's focus how to use conditional statement, how to make it work. So in order to do it, you type a word which is called if. So it just checks if, and then we say in the parentheses what you want to check. And here should be an expression. Expression is just something like that. For example, is 5 greater than 7, okay? And this thing, as you know, returns true or false, right? It can return true or false. And if expression is true, then the instruction that is below this conditional statement is gonna be executed. So here we type instruction that is gonna be executed if the expression is true. If it's false, then this instruction here is not gonna be executed at all. So let's check it out. If A is lower than B, then I want to see on the output, for example, A is lower than B. And as you can see, it's true. But if I change here value to, for example, 15, we'll not see this statement. Sometimes you want to check more things at once. For example, I want to check if A is not lower than B, else if A is greater than B. Then I want to put into the output, as you can see, now we have got here A is greater than B. So we can check all possible things that happens. But we didn't think about 7, right? Is 7 equal to 7? Yes, so it's not that condition, it's not that condition. And you can do again else if A equals B, and then print to the output A equals B. But you can also do something like that. Else, totally else. If all other conditional statements were false, then the instruction here is gonna be run, okay? So that's how you can make your conditional statement a bit longer when you want to check more than one condition at once, right? If this is not happening, then I want to check, hey, maybe this is happening. Or maybe, well, all these conditions were not met, so I want to execute the instruction here. You can, of course, check here more instructions, right? You could check here many more. But if you did something like that, of course, then the instruction here, something else happened, well, will not happen at all, right? Because we just check all possible situations before. But in some situations, you might want to do something like that. Okay, so let's leave it like that. I would like to also show you that you can have more than one variable. Well, you can use the logical operators here. So you can do something like C equals 10, right? And you can do something like if A is lower than B and in the same time C is greater than, for example, 6, then I want to see this. At the moment, this is true, right? And here 7 is not lower than B, so we'll see this message here. Something else happened. But if I use, for example, alternative, right? And we know that alternative is working like that you can choose the option that is true. So C is bigger than 6. So the result of this expression will be true anyway, right? So we'll see this message here, which is not true because A is not lower than B, but we could write here whatever we want, right? We could, increase it to C is greater than 6. Whatever. The truth is that we are just learning how to do it on some theoretical example, right? Okay, so that's how you use conditional statement. That's all in the lesson. Thank you very much. Hello, in the last lesson I told you what are conditional statements. Now I will show you a problem that happens when you want to execute more than one instruction if the condition is true, when the condition is met, right? What will happen if I do something like that here? As you can see, we have got an error here. It's not working at all. Why? Because only one instruction is gonna be run if the condition is met. If you want to group more than one instruction and you want to make it to run like a one instruction, you have to use curly braces, okay? When you do it that way, you say that the range starts here and ends here for this conditional statement in the line 19. As you can see, now everything works fine. So here is also a range for this method. Here is a range for this class. We don't know exactly what is function and class right now, but as you can see, curly braces are used to say where something starts and where it ends, right? It also is gonna make some other things, like for example, when you create a variable here, as you can see, well, for example, let's call it D, because you have got A, B, and C, D here. It's not gonna be you are not gonna be able to use it, for example, here. As you can see, it doesn't exist here, right? You cannot run this program anymore. Why? Because every variable after the curly bracer, ending curly bracer, is met, is gonna be destroyed by something what is called garbage collector, because it's not gonna be needed anymore. Okay, this is called local variables. We talk about things like that in well, another lesson also, but well, this is a first glance into this topic. So this is a curly bracer, and you also should know, so you do not make mistake, because some people make a mistake like that. They want to execute, for example, something like that only if all conditions were not met. And when you execute it, as you can see, we can still see the message here, right? Message here is gonna execute always. Why? It's gonna execute always, even though this condition was met, right? Well, you need to remember that when this condition is met, all other conditions are not gonna be executed. Well, it's because like that, because the truth is that white spaces are not interpreted, right? You need to remember that only one instruction is gonna be run. If you want to make sure that this instruction is gonna be executed only when all instructions here are not, when all conditional statements here are not met, then you have to remember about creating here a scope, right? Using the curly bracers. We want to group these instructions into one instruction using these curly bracers. Okay, that's all in that lesson. Thank you very much. Hello, today I will tell you about conditional statement, which is called switch. Switch is used, as the name suggests, to switch between the values of the thing that is gonna be sent to the switch. So if you create a variables, for example, A, and you assign it to it 50, and you create a switch and you send the variable A, you can switch between cases. So for example, case 50, I want to then do something like send to the output A is equal to 50. And if there are other cases, so let's create other cases. 50, let's do for example 100, 150, so here 100 and 150, and if it equals totally different value, then I want to send to the output A is different, it's not 50, 150, and we can say A equals, for example, A, right? Of course, this is very unpractical example, but I just want to show you how switch is gonna work. So as you can see, everything got executed. So did I lie to you? No. Well, the switch is gonna execute everything after one of the case is met. So we have got here a value 50. So everything is gonna be executed after this case. So this, and this. If I had, for example, 100, you will notice that only this instruction, and this instruction will be executed. Right? Okay. When you do 150, only this and this. If you do totally something different, only this. But if you had default here, you will notice that everything got executed anyway. So is switch even usable? Yes, it is, because there is a special instruction which is called break. You can break totally the case. Well, you have to break it if you want to stop execution, because you know here you don't have something like curly bracers to show where the case starts and where it ends, right? well, this will not work, okay? Here, when you do it that way, it's still gonna execute everything after it. Well, everything until the break is met. So 50 and 100 was executed, right? Curly bracers here is just not working to like it would break the switch, okay? You have to type the break instruction in order to make it work like that. But you might be like, hey, but is something like that usable? Yeah, you can do probably something like that. If A is equal to 50 and it's maybe 100, so it's like alternative, right? If it's equal to 50 or it's equal to 100, then show that A is equal to 50 or 100, right? And then you can see that this thing got executed, right? And the case 150 wasn't executed and default wasn't executed, right? You don't need to type here break because, well, it's the last instruction here, so this thing is not needed, at least if the default is at the end. But you might be wondering, do you need the switch if you can do really everything with the conditional statement that you learned about in the last lesson? You don't need it. The truth is that switch is only looking a bit better, right? Because you have got everything shown case by case. You can look at this and code might be a bit easier to read. The truth is that I have almost never used it. This is, you should just know it because some people might use it, so it's a good idea to know the syntax, right? So you know how to read it, how to read the code written by other people. And it's also a good idea to know that you can't send the switch double because you can't compare doubles. Doubles are just, have got broad precision and it's very hard to compare something with fraction, right? You also cannot compare something what is called string because string must be compared using something what is called equals method, but we'll talk about this in the future lessons. And well, you can compare characters. So if you wanted to compare characters, you could just type here something like that, right? Using the apostrophe. And if the character was like A, capitalize, this thing will be run. As you can see, the case here was met, so everything is gonna be run until the break is met by the interpreter of this program, right? Okay. Let's change it back to integer, and here 50. That's only the lesson. Thank you very much. Have I told you that programmers are very lazy people, but an intelligent way? After this lesson, you will notice how badly they are lazy, okay? Because let's imagine a situation like that. You want to check if the number is even or it's odd, right? So the even number can be divided by 2 and the odd number cannot be divided by 2. In order to check it, we can use conditional statement, right? So we can create a variable like that. And in order to see if this variable is really odd or even, we can do something like that. If x modulo 2 equals 0, then it means that it is even. Because 6 mod 2 is 0, right? So it's even. It can be divided by 2. Otherwise, we can put the output it's odd variable. As you can see, it's even. When I change it to 7, for example, it's odd because 7 mod 2 is just 1, so 1 is not equal to 0, so here we have got false, and this thing will be executed here, right? Because condition here was not met, so this condition is gonna, the instruction after this condition is gonna be executed. And now, look, programmers are very lazy, as I said. You could write it that way. If, then even, otherwise odd. And you can save it, for example, to is even variable. and you can send to the output it's even. Now let's comment it, and as you can see, it's odd when you do it that way. It's even. So this construction is called conditional expression. When you have something very small to check, right? Like this. You can use conditional expression, which looks like that. First you type expression, then the thing to execute if expression is true, and then after the colon, the thing to execute if expression is false. That's how you do it. Don't use it, of course, for something bigger, just for things like that. And only if you think you're lazy. Well, the truth is that it might be sometimes more readable, but sometimes when people do not know how it works, and believe me, some even advanced programmers forget about it, they have to go to the website and look about what is these things here. So maybe it's even better to sometimes write more, right? But at least you, when you meet a code like that, you will understand how it works. Okay, that's only the lesson. Thank you very much. Hello, my friend. Today I will tell you what is an array. Array is a sequence of variables that are stored next to each other. If you want to create more than one variable at once that has got the same type and they are connected to each other somehow, you want to use array. Why? Because imagine a situation like that. I'm telling you, hey, create 50 variables that will store numbers. What you will do? You will do something like that. Integer, then variable 1, bam, variable 2, variable 3, variable 4, variable 5. Okay, I'm just kidding. I'm not gonna go to do it 50 times. But now you can imagine this situation, right? And now imagine that I would tell you, hey, we don't need 50, we need even more, we need 90, we need 10,000, okay? That would just take forever. It would be hard to, even check what value is where and other things like that. That's why we have got something what is called an array, because we can create using a syntax like that an array. So here's a name of array and here's a type of array, and you just need to add the square brackets like that, and now you created an array. Now it's empty, there is nothing there, you didn't reserve anything in the memory. If you want to reserve something in memory, you have to type something like that, array equals, and then you type the keyword new, which says, hey, I want to reserve in the RAM, in the random access memory, right, space for the thing that I will type right now. So for integers, and I want to say how many integers I want to reserve there. For example, I don't know, 30, right? So we instantly created like 30 variables that type is integer, and we put them next to each other. Because they are next to each other, because they are really 30 multiplied by 33 bits, right? Because integer is 33 bits and it's multiplied by 30, and they are next to each other, right, in our memory. Because of it, you can access them very easy using something what is called index. So in order to access, for example, the first variable, right, the first value of the array, you need to type something like name of array and then use the square brackets and type 0. And as you can see, we have got as the result here 0. If we type 1, it is also 0. It's because the array right now has got default values. For the integer, when you do not assign anything manually, that is gonna be zeros. But of course you can change these values. So for example, you can type here 70. And now, when you access this first value, as you can see, it's 70. You might be also asking yourself, hey, but you're using 0 here and it's not fair. You should use 1. You should start counting from 1. Well, yeah, we are counting from 1, but in programming, you have to remember that arrays have to be counted from 0, okay? From 0. You're counting indexes from 0 in arrays. That's very important because many people make mistakes like that. So if you create an array like that, you really created 3 variables, but the first one is at the index 0, then the second one is at the index 1, and the third, the last one, is at the index 2, okay? So in order to access the second element, we type, for example, something like that, and the last element, something like that. And now, of course, we can access all these values doing something like that. As you can see, everything is working fine. But we have to also notice that you cannot access things that are out of, reserved memory that we reserved in our RAM. So if we do something like that, right now we don't have an error, but when we play, oh, now it's wrong, right? Now we have got an error here and we have got exception that something happened. The array index is out of bounds exception, right? Something is wrong. You cannot access something that was not reserved by our program, because you have to know that when you are running your program, right, you are reserving memory for this program, for all variables, for the program itself. And if you do something like that, right, like that, you want to access array of index 3, which was not reserved in the line 17, then you are trying to access something that could be reserved by another program. For example, the NetBeans, for example, the recording tool that I'm using, whatever, right? So that's why you cannot access things that are not reserved, okay, in the random access memory, in our RAM. That's why we need RAM, right? We need to reserve things. So arrays, as you can see, are very useful. You can instantly reserve lots of space in instant. There are another ways of declaring arrays. You can do it also that way, because spaces are not interpreted, but the convention is that in at least Java you should create them that way. But this is the thing that some people do not know. You can also declare it that way, but as I said, convention is to do it that way. And now finally, you have probably noticed that we are starting to know what's going on in our program. Hey, here is a string, and the type of this string is really, well, the type of this variable here is really not only string, it has got this square brackets, so it means that it is an array. So it means that here we can send from, for example, another program, or for example, from the console to our program, arguments, right? Arg stands for arguments. Of course, I could call it whatever I want and it will be run, because this is the name of an array here, right? But they call it args because, well, it's then self-descriptive, and that's how all variables should be called. So here, people can send many arguments that we can later use, right? We could do something like args0, if args0 equals to open, then we can, for example, open something, right? That's how this thing works. And the cool thing is that because it looks like that, you can send more than one, right? That's very, very cool. You can reserve memory, as in normal variables you can assign values to normal variables in one line. You can do, of course, things like that, right? So you can do it in one line and everything is gonna work fine. You can also initialize array like that. For example, let's call it array2, and you can assign values into array instantly. You can do something like that, and later we can access, for example, the first element, which is 124, so it's at the position 0, like that. And as you can see, it's working fine. We have got 124 here, right? This solution is rarely used because most time you do not know what will be inside an array, what values will be there, because they are sent from, for example, database, from the file, from the forums, and other things like that, okay? But it's good idea to know, because there can be situations where you want to initialize it in one line, okay? Because you don't know exactly how many things will be here. The cool thing about this solution is that you can add here new things and the size will increase automatically. So, well, there is also one more thing you can get using the dot length, the length of the array. As you can see, it's 5. 1, 2, 3, 4, 5. And it's very useful to know how many things were put into an array. Because of it, you can access, for example, last element of the array. Because the last element is at the index, in our situation, 0, 1, 2, 3, 4. As you can see, the length here is returning 5. So if we did it that way, we're gonna have a number 4, and we can use this value as the index, right? Like that. As you can see, now we have got here 55. And when I add here any number, right? And now it's the last element here, we're still gonna access the last element. Okay, that's only that lesson. Thank you very much. Hello, today I will tell you what are multidimensional arrays. But before we go into multi-dimensions, we need to think about what is a single dimension. Single dimension means that you go into one way. For example, you have got a row here, right? This is a horizontal row, and this is a single dimensional array. But when you want to add columns, so when you do something like that, you are going two ways. You go horizontal way and the vertical way, right? And then you can create a 2D game, for example, chess, right? You can then put, for example, some pawns or any other figure that exists in chess game. Of course, you will need to increase this by the column size, you will need to make it fixed, right? But now you know what I'm talking about. This multi-dimension, we have got horizontal, vertical. If you wanted to create another dimension, it will go like to you, to the monitor, right? It will be three-dimensional. That's how we have got objects in real life. We see everything as it was in the three-dimensional space, right? Now the indexes are gonna look a bit different. Here we're gonna have the number of row, and the second index is gonna represent what is the number of column, right? So here we're gonna have 1, here is gonna be 2, here is gonna be 3, and here is gonna be what? 1 again, 2, 3, 1, 2, 3. And to make it a bit better, let's do it that way. Bam, 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 bam. Okay, so that's how the two-dimensional array looks like. And how to create it? Well, before we were doing something like that, using the one square bracket. Now we just use two square brackets. If you wanted to create three-dimensional, 3, 4, 5, 6, 7, right? So this is a two-dimensional array, and now we call it, for example, tab, and now we initialize to it. We are reserving in our memory space for what? For integers, and I want how many rows? 1, 2, 3, 4. So I type here 4. And how many columns I need? 1, 2, 3. So I type 3. And now we created two-dimensional array, which we can change. So for example, we can do tab of 2.1, and I want to change it to, for example, 99. And then we can send it to the output. As you can see, the result is 99. So we change the value of this guy here. And remember, again, I'm telling you that you have to count the indexes from 0. That's why we type here 4, even though we can see here that here is 3, because the first row, as you can see, is called 0, 0, right? Okay, remember about it because it's very, very important. And you can initialize also multidimensional array also in one line. You can do it that way. Tab 2 equals, and here is the semicolon. And now you have to create rows. Each row should be inside curly bracer, okay? So now you can say that I want here a value like that, and like that. And if you want another row, you add here a comma and then curly bracer. Another, and another, like that. And now let's train a bit. Let's think about how to get to, for example, that guy that is here. So this is the last row, so we should type tab of 2, and the last row is 1, 2, 3, 4, but you have to count from 0, so it's 3. And in order to get to the second column, we just gonna leave that 1 here, because the first column is at the index 0 and the second column is at the index 1. And as you can see, we have got here now minus 53. So that's how you create multi-dimensional arrays. And as I said, you can create it to use it to, for example, creating two-dimensional games. So that's all in that lesson. Thank you very much. Hello, my friend. Today I will tell you what are loops. Loop is a solution that allows you to execute as many times as you want instructions. Because there will be many times in your programming adventure when you want to run instructions more than once, which are very similar to each other, okay? For example, as you can see, we have got here an array of video courses, and the type of this array is string. So we have got here 4 strings, right? And how would you do it if you wanted to print all these things to the output? Well, you would do something like that. You would get into that array and then type the index of array. You would copy it 3 times and then you would do something like that. And you would execute it. Okay, it's fine. But now imagine that we have another course, for example, Grand.js, right? And when you execute it, we don't see it. So we have to change something in our code. You have to remember that when you are writing a code, your code should be universal. By universal, I mean you shouldn't change your code when something changes in data. Your code should work that way that it's gonna work anyway, even if somebody adds something new to data, okay? That's how you should always try to program your code. So when you look at the code, you instantly can see that it's very similar. It only differs by these numbers here. And this is the time when you should think, hey, I should use a loop. Okay, so how to create this loop? Well, in order to do it, you type while. This is a while loop. And then you create parentheses, and in parentheses, you type the condition of loop. So for example, while I is lower than, for example, 5, then I want to execute everything between these curly braces. Let's create this variable which is called I. So for example, let's create an integer. You have to assign here a value, right? For example, 0. You have to start from something, because if you do not assign anything, we don't know what's in I. So we assigned here 0. And we are going to run instruction between this curly bracer until this thing here is true. This condition is true, okay? So is 0 lower than 5? Yes, so we can print something out. So let's print, for example, I outside. Let's play it. As you can see, now we can see that, oh, really? These zeros are not gonna end, never. You have to stop this program. Why? Because 0 is always lower than 5. So this loop is infinitive loop. Infinitive loop happens when your condition is always true. So you have to change this value, and in order to change it, you're gonna use the operator, arithmetic operator, that looked like that. You're gonna increase I after each time by 1 using this instruction here. So when I executed this time, as you can see, we have gone on 0, 1, 2, 3, 4. Why? Well, let's check it out. Is 0 lower than 5? Yes. So let's print 0 outside and then increase 0. Well, increase the value inside the variable I by 1. So right now in I, we have got 1. Is 1 lower than 5? Yes. So let's print out 1. Then we increase it again. So is 2 lower? Yes. 3, 4. And then is 5 lower than 5? No, it's equal to 5. So it's not gonna print 5. It's just gonna print everything from 0 to 4. And hey, this is something is gonna work here with that thing here, right? Let's copy it here. We had here numbers 0, 1, 2, 3, 4. So we just gonna delete this 0 here and put here I. And bam, we just printed all courses that are inside here. We can delete this. As you can see, we just printed it. Pretty cool, right? But as I said earlier, your codes should be universal. By universal, I mean when I add something new, so for example, SAS, as you can see, it's not working. So you should now increase here to 6 this number, but you shouldn't code your code like that, that you will later change something in your code when you add a data. So in order to change it, we gonna get from video courses length of this array using the length variable that we can access using this dot, right? I told you about this property, this variable here, and it's gonna return here right now what? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, right? And yeah, now it's gonna print everything out. And now you can add something totally new. So for example, Java Android, right? And bam, as you can see, we added it because this property has got always the value that is actual in that array, right? And that's the program. That's how you should create your programs in your future. Okay, they should be universal. Okay, so this is a while loop. Let's create now a do while loop. You can create a loop doing something like that. Do while I is lower than video courses dot length, right? And well, let's comment this and let's put this inside like that. And when we execute it, as you can see, it works the same. Well, you might be thinking that it is working the same, but the truth is that if you change here the I to, for example, that number, it's gonna execute anyway. We have got here a problem now because this big number, we don't have a value inside this array, right? We can't access an array with so big index because do while loop is gonna execute this thing at least once. So the condition is checked at the end, okay? But if we take this under the comment and we uncomment this section, you will notice that that these instructions between these curly braces were not executed at all. Why? Because condition is checked at the beginning. So this is the only difference between do while and while loop. I'm sorry, my friend, but I now have to give you an exercise. You have to train. So what you should do now? Please create a program with an array that size will be, for example, 8. And I want you to assign values to this array in that way. The first value at the index 0 should be 10, then 20, 30, 40, 50, 60, 70, 80, 90. Well, I think that it should be size 8, right? So something like that. So you should assign to values something like that, and then print all these values outside, okay? So this is your homework now. If you have any problem, just ask me, create a discussion, I will help you, so do not worry. That's only that lesson. Thank you very much. Hello my friend, today I would like to introduce you another type of loop, which is called loop for. And in order to use it, I'm just gonna change y to 4. But now focus please. I'm just gonna add here a semicolon and here a semicolon. And it's gonna work the same like while loop. So why even bother using it? Because we can add here now space and here space, and these places here are reserved for the thing that should be done when the loop starts. So for the initializations of variables that will be needed in loop. So for example, this I, right? Here we have got a condition, and here should be played something that is gonna be executed after each time the loop is run. So like that. And now it's also gonna work fine. Isn't it cool? So this loop I think looks better than while loop because you have got everything that is connected to loop in one place, right? It is not outside of the loop somewhere here, and the thing that is done after each time the loop is run is not at the end. You can just look here and instantly see what is this loop responsible for. I like for loop the most from the loops, okay? So let's do something like that. Here is the place for initialization of variable. Here is the condition, and here are things that should be done. Things to do after each iteration, so after each time the loop executes everything inside its body, and that's all, okay? And of course you can, initialize here more variables, so you can do something like that, but we are not using now, so we don't need to. And you can do with the comma also incrementation of more variables, right? So we could do something like that and something like that. It's gonna work fine, okay? So this space can be expanded. You should also know that the condition here is gonna be checked at the beginning. So if we do something like that, nothing is gonna be shown. So the condition is checked at the start. So this thing is run first, then the condition is checked, then this thing is executed, then we are increasing the value of variable I, and then we check the condition again, bam, 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 until the condition is not met, okay? That's how it works. So let's change it back to something like that. So use do while loop when you want to execute something at least once. Use for loop in order to, I think, make your code clearer. While loop, I think, is most time used by other programmers that just prefer it, right? It's really the preference. So use the one that you think that you like, but I really think that this one is better because you have got everything in one place and it's easy to read in one line what that loop is gonna do. That's only that lesson. Thank you very much. Hello, in the last lesson we learned about the for loop, and in that loop we had to type lots of things here. There is an enhanced for loop that you can use for situations like that. Enhanced means that it is upgraded loop. It has got another syntax that is easier for situations like that. So how to use it? We just type the for, then parentheses, and of course the curly braces, where is the body of the for loop. And now we do not type these semicolons, and we do not have displaces here first for initialization, second for condition, third for things to do after each iteration. But now we just type the type of the array that we want to parse, that we want to get values from. So in our situation it is what? String. Okay. Then we type whatever we want. Yes, it's true. You type here the name of variable that will store values after each iteration, after each time the loop will go through the loop. Okay, so it will store one in the first iteration C++, then C++ operating on files, Java Android, and so on. So let's type here, for example, my value, right? And then we type the colon, and then we type the name of array that we want to go through. So in our situation is video courses. And now we just type my value, right? We just type this here because it stores the value after each iteration. And now when we comment this, you will notice that when we run this, hey, it works fine. And of course, now you can add new things here, right? Java database, for example. And of course, it's gonna be also added. So this looks, of course, simpler than this one, right? But in some situations, it's maybe not the best because, for example, what if you wanted to have a variable inside? You would have that would count, right? You have to create it outside, increment here, because sometimes you want to check what iteration is, and then if iteration is equal to 5, you want to do something special, right? So you can do something like that, blah, blah, and as you can see, once after the 1, 2, 3, 4, 5 in the 5th iteration, we type blah, blah. Of course, most time you want to do something different, but hey, now you have got against something outside, right? So it really depends on what you want to exactly do. And you need to also remember that here you can do whatever conditional statement you want. You can do here, you can use the ampersands, right? You can use the conjunction, disjunction, other things like that. You can do whatever you want here. Here you don't have something like that. You just go through all values inside, okay? So it really depends on situation, what you want to do. Okay, so let's take this other command and let's undo command here, and you will notice that sometimes even your IDE will help you convert to for loop. And as you can see, we instantly the IDE converted it instantly, and it also gonna work, right? So we can do, as you can see, Ctrl Z, Ctrl Y. So that's the difference. Okay, that's all in that lesson. Thank you very much. Hello, today we'll exercise a bit. I will show you how to create a multiplication table using a loop inside another loop. So it's another exercise, how to use loops inside another loops, right? That might be a bit difficult at start, but I think this is gonna be easy after I show you this simple example. So, how does multiplication table look like? Well, you have got something like that, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then what do? You multiply all these values by 2. So you have got then 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And then what do? You multiply not this row, but the first row again by 3. So you have got this 3, 6, blah, blah, blah. Okay. And then what do? You multiply by 4. So 4, 8. Of course, you know how it works, but you should look as a programmer on this like that. Hey, I have got here one row. I want to print this row, and then I want to just multiply each time the same row by 2, then 3, then 4. And that's when we can use something like loops. So let's create a for loop, and we'll initialize here variable I, and we'll assign to it 1 because we want to start from 1, right? And then if 1 is, if I is lower or equal to 10, then increase value of I. So this loop is gonna be executed now 10 times. When we do something like that, we'll see numbers 1 to 10. Okay, but I want them next to each other, so we will not use the method print line, but we'll use the method print. Now they are next to each other, but we want to have a space between here, so let's create a space like that using something like adding a string with the plus operator, right? And now, as you can see, we don't have got an enter here. We should add enter at the end. So let's do it, but let's do it outside. So we're gonna do it like that, system out print line. And we not gonna send anything there. It's gonna just add enter here. Okay, so now it looks fine. And now look, we have got now this first row here printed using this instruction, right? Because this is really something like running this instruction 10 times. But let's imagine that this is one instruction that solves a task for printing out 10 numbers. And now I want to multiply all these values by what? 2, then 3, then 4, then 5, then 6, then 7, and 9, 10. So it's also a situation where we want to create another loop that will be outer loop, right? This will be the inner loop, and let's create outer loop for, let's create here, let's declare here variable, for example, j. Let's assign to it 1, and if j is lower or equal to 10, then j plus plus. And now let's take it into the curly braces, and we just need to multiply I by j. And as you can see, now we created multiplication table. And the coolest thing about this solution is that we can now create even bigger multiplication table, and it's done instantly, right? That's the power of our computers. If we did it manually, it would take just tons of time. Okay, so let's focus on how it works, right? So let's do something like that in the command. And at the beginning, we are assigning to j 1. So it equals 1. And we check if 1 is lower than 10. Yeah, so okay, let's go to this loop here. Do you have got an instruction here? So we declare I and we assign to it 1 and we check, hey, is 1 lower than 10? Yes, it's lower than 10. So okay, so let's print out what? 1 multiplied by 1. Okay, let's do it, and let's print space. And then what? The first pass of this loop, the first iteration, is gonna end, and we need to know that the thing here is gonna be executed, right? At the end of the for loop. So the I is gonna be increased to 2. And we again check the condition if 2 is lower than or equal to 10. Yeah, it is. So 2 multiplied by 1 is 2. And we again increase it, so 3. Is 3 lower than or equal to 10? Yes, 3 multiplied by 1 is 3. And then 4, 5, 6, 7, 8, 9, 10, and then 11. Is 11 lower or equal to 10? No. Okay, so it's the end of execution of this for loop. We end it because the condition was not met, and we execute the print line. That's why we have got here enters, right, after each row. And then we gonna what? Well, the first iteration, the first pass, because we could imagine here as it was one instruction here, right? Let's imagine that it would be something like, you know, printing one instruction. So this instruction has ended, and then we have to increase j. So we increase it to 2, and we check the condition. Is 2 lower or equal to 10? Oh yes, it is. So the condition is met, and we're gonna execute this thing again. But after, you know, that for loop has ended, we lost the variable I. So we are declaring it here again. So it's again equal to 1. And we check, is 1 lower or equal to 10? Yes, it is. So we're gonna just show to the person 1, but multiplied now by 2. So it's cool because now we have something like that, right? We've got the second row that is gonna multiply all these values by 2. And because of it, we're gonna see as a result this row. And because we have then 2, 3, 4, 5, 6, 7, right? And 2, 10. And all the time, these values will be multiplied by the static value 2. And after ending this loop, execution of this loop, j will be increased. And then we will multiply every number like that by 3. And that's why we're gonna create another row. That's awesome, right? It might be a bit complicated at the beginning when you look at this, but don't worry. After do things like that a few times, you're gonna feel fluent in things like that. So what you should do after this lesson, you should write it on your own, okay? This is a good idea to close this video now and try to not look into the code here and try to write it on your own. It will be a good exercise for this lesson. If you have any problems, just feel free to ask. I'm always here to help. Best regards. Hello, my friend. Today I will show you how to break or continue the iteration of loop. What does instruction break and continue means? So here we have a loop, a simple one, that is gonna show values from 0 to 9. And now imagine that we would like to see only 0 to 4. So we would like to see even numbers, right? Or maybe I would like to see odd numbers. So 1, 3, 5, 7, 9. How to do it? In order to do it, we have to know how to use continue and break instruction. Well, we need continue for this one, but it would be a good idea to also learn about how break is working. So let's do something like that. Let's create a conditional statement. If I is equal to, for example, 6, I would like to continue. What does it mean? When we execute it, you will notice that 6 disappeared. Why? Because continue is working like that. Stop execution of the iteration, so one of the paths of this loop, right? Stop the execution of iteration of the current iteration, but continue. So it means that every instruction after this one won't be executed. So this thing just didn't execute, right? If you had more here like that, you will notice that when we should have here 6, it's not there, right? All instructions here from this place to this are not gonna be executed if the continue instruction is executed. The break is a bit different. It's just gonna stop totally this for loop. So break means, hey, break, man, I don't want to execute this loop anymore. Break is used in situations where, for example, somebody clicks on something and you want to stop the loop, right? You could check here all the time. If somebody clicks the button, then break. But, well, nobody has clicked anything, so there should be some operations executed, right? In our situation, we need continue, right? Because, well, we do not want to stop total execution of for loop. We want to see 0, 2, 4, 6, 8, and for example 10, whatever. We want to see even numbers or odd numbers. How to do it? Well, we could use the modulo law operation here. So if I mod 2 equals to 0, we're gonna continue. What will happen? As you can see, now we have got numbers 1, 3, 5, 6, 7, and 9, which are odd numbers. How does it work? Well, we assign here to I 0 and we check, is 0 lower than 10? Yeah, so 0 mod 2 equals 0. Yeah, so this thing is gonna be executed, and because this is gonna be executed, instructions after continue are not executed, so we'll not see 0. But later, when the I is gonna be increased, we're gonna check the condition. Is 1 lower than 10? Yes. 1 mod 2 is 1, and it's not equal to 10, so the condition is not met. And well, this continue is not gonna be executed because condition was not met, and we're gonna see on our here output 1. So that's why we can see odd numbers. If we did it that way, we're gonna see even numbers. The coolest thing is that now we can execute lots of them very fast, right? Okay, so that's how continue and break works. Now let's see how it works here when we have got a loop inside another loop. So this is a harder example. What will happen if we do something like that? If I equals, for example, 5, I will continue. As you can see, the column 5 disappeared totally. Why? Because every time when I was equal here 5, right? It doesn't matter what j was, 1, 2, 3, 4, 5, 6, 7, whatever. The instruction here was not executed. So we didn't multiply 5 by 1, 2, 3, 4, 5, 6, 7. So that's why we removed the column, right? The fifth column. If we did something like break here, you will notice that all columns after 5 disappeared. That's why that's because break leaves the inner for loop, okay? It's not gonna break this loop and this loop. Break is gonna just break the loop that it was executed in. So that one. And that's why when I was equal to 5, it left, because of the break function, we left this for loop, and well, this for loop still executes, so the j was increased, and that's why we have got another rows here. It might be a bit hard for start to jump from something so simple like that to something like that, so do not worry, you just need to train a bit. As an exercise, I would like you to right now try to somehow print every second row. So you want to print this one, this one, this one, okay? And if you have any problems, do not worry, I will help you. Just create a discussion. That's all in that lesson. Thank you very much. Hello, let's train this lesson and let's create a program that is gonna sum up, so add all the numbers that are inside this array. How to solve a problem like that? Well, if you're gonna add each time a number, it's gonna be very similar instruction. That's why you should instantly think about using a loop, right? You want to execute very similar code. So we need to also store it somewhere. So let's create a variable that we store the sum. So let's call it like that. And it's a good idea to assign to it 0. Why? Because when you are adding 0 to 1, it's still 1. You need to have a neutral value in order to do something like sum plus equals numbers of, for example, 0, right? Then you are adding, at least at the start, a value to the neutral value. That's why it's not gonna change. If you did something like that, the result would be different, right? And that's why we need to assign here at the start 0. And now we need to create a loop. So for, and let's create a variable I, and if I is lower than the number's length, then I++. we assigned here to the I0 because I remind you that we number all values, we index things inside arrays from 0. We start counting from 0. That's why we start here from 0. And now we can just add to sum plus numbers of I. And then we can just send to the output the sum outside of the loop, right? And when we execute, we instantly can see the result. Of course, we can, let's do it on something simpler. So 1 plus 2 plus 3, it's 6. And as you can see, it's working fine. You can upgrade it a bit. You can do something like that. It's gonna look a bit better, right? And you can upgrade it even more by using the enhance for loop. So we could type here the type of the array we want to go through, so int, then the name of variable that will be storing the values after each iteration of each place here, right? So for example, number, and then we type colon and then the name of array we want to go through, so numbers. And now we will not type something like that, but we'll just type something like that. And as you can see, it's also gonna work fine. And it looks, I think, it's more readable now, right? Okay, that's all in the lesson. Thank you very much. Hello, my friend. Today I will give you overview on the topic that is called object-oriented programming. But before we talk about this, we need to tell ourselves what is an object, because hey, this is going to be oriented programming around the objects, right? So we need to create something in the Java language that will be connected to objects. So what is an object? How to create it? How to use it? Why do we need it? So what is an object? Well, object is everything that you can see and you can describe. Okay? Right now I am looking at the monitor. I am looking at the things that I have got on my desk. There are lots of things here. It's even hard to, move on my desk. That's how I work. But hey, there are lots of things. They are all objects and I can describe them. So in object-oriented programming way, you want to describe things, and you want to describe them because you want to connect all the things that are similar to each other and have them in one place for the future usage, for future changes, for easier future changes. Okay, so object-oriented programming is cool because you can work with many people, because it will be easier to work with something that is set once properly. Okay, so objects, well, I said here, are containers also that stores variables and function thematically connected to each other for easier future usage. So for example, when I'm looking at this monitor, it has got width, it has got height. So this is the properties, these are features, so part of something that describes the item, okay, this object. And well, this monitor can be closed, can be opened, right? It can be, I can change the brightness. So these are methods, functions, and this describes the things that can be done with objects, okay? What can you do with objects is described by methods and functions. So let's create this very simple one, class. So for example, class monitor, and a class is a form for creating instances, copies of objects, okay? So classes are used to create objects. So I'm just creating right now a class that is called monitor, and I am using the curly braces to say where I want to describe things that will be describing monitor. And here I'm going to create, for example, two variables, integer width and integer height, okay? And well, width is gonna describe the width of a monitor, and height is gonna describe the height of a monitor. And these things are called properties, okay? This is very important. This is properties. And now let's create methods. So something that can be done with monitor, okay? So for example, void and then change brightness, okay? Something like that. So this is a method that can do something with the brightness, okay? So I can also create a variable that will be called brightness, and it can be later changed using this method. So for example, we can send an argument, other things like that, but we will talk about things that are like that in future lessons, okay? So things that will be done by method are gonna be described between these curly braces, and well, so this is place for instructions to be done. That void thing can be really something else. It can be boolean, it can be many types. It is the thing that is gonna be returned by the function when it's invoked, but all the things like that we'll talk about later, okay? So don't worry about this weird keyword here. Right now, you just need to understand what is objective programming and why do we need it, okay? So I just described a monitor like that, and because I have got a monitor, one monitor, it doesn't mean that all of the monitors will be the same, right? Well, we can have many different monitors, and we can create using classes, right? Many monitors. So I can create, for example, in the main method, a new object using the monitor class. Monitor can be used as a type. As you can see, I can type monitor, now the name of variable, so for example, monitor1, whatever, and now I'm gonna type equals sign and new monitor, which means reserve for me in the memory, in the random access memory, a place for these properties and this method that can be later invoked, okay? And as you can see now, when I type monitor1 dot, as you can see, I can access the brightness, the height, the width, and I can change brightness, for example, right? So let's access, for example, width and set it to 1000. And let's send it to the output, so like that. And as you can see, hey, it's working fine, right? Well, we could also do something like get width. For example, we could create a method, right? And we could send to the output the width that we have got here, okay? And we could do something like monitor1 get width using this method. This is called invoking of methods, okay? Well, this thing should be looking like that. As you can see, we have got 1000 now. Why we have to go have this here not inside the system out print line, we'll talk about later, okay? But well, as you can see, it's cool because you can now have things, methods connected to monitor here. Because you know, right now we have got very small programs, right? Imagine a situation where you have got big program with like 10,000 of lines. It would be very hard to keep everything in one file and in one class, in well, whatever, something like that. It would be just horrible. But using classes, you know, you can have a class for monitor, you can have a class for a keyboard, you can have a class for the printing device and other things like that. And then when you want to change something, when you want to look for something, it's gonna be just easy and easy to find, right? That's why it's so cool. So the cool thing about it is also that I can create another monitor. So I can create another type of variable which will be called monitor, for example, monitor2, and create a new monitor. And now I can type something like monitor2 and change the width to, for example, 20,000. And of course, when I use the monitor2 get width method, which is executing this thing here, right? It's like, hey, I'm gonna jump from here to him and execute this code here. So, bam, as you can see, it's the 20,000 that I type here. And well, I can, for example, invoke first this, then this. We have got two different instances. We have got two different copies of objects. That's the cool thing, right? We can create many different monitors. This is just a blueprint. This is just a form for creating instances, right? Blueprint, maybe it's maybe even better word. And you might be like, hey, this is very theoretical example. Yes, it's kinda is, but it's easy to understand it then. But look, hey, we've been already using classes. We created something what is called strings. And if we type, for example, name, you will notice that inside of it, we have got access to many methods, many functions that can do something with the value like that, with the sequence of characters, right? So I can type something like name dot, and now I can, for example, check what is the character at the position 4, right? And we can send this to the output. So we can do something like that, easy, right? And it's D. So there are many methods that you can use inside of it. You should also notice that you should name your classes with the big letter, okay, with the uppercase at the beginning, and you should name methods with the small letters at the start. Why? Because then it's easy to, you know, see what's what in your program, right? You can instantly see, hey, this system is really an object, right? And it's true. When I type system dot, I can access some methods here and some properties, right? That's very cool. And well, when something is starting with a small letter, it's gonna be a property or it's gonna be a method, right? So it's very useful to use the convention of naming your classes like that. You have also probably noticed now that finally we understand what's going on in our program. Here we have got a class, right? And this class is public class. What does it mean that it's public? It means that it's available everywhere. Because, hey, here we have got a package. Package means that we have got everything sorted in one place, like, for example, the classes. And when I create another class here, so when I do something like that, as you can see, we can have many classes. They are all in the same package, right? In this package here. And well, you can have your own packages, and there are many other packages created by other people, by, for example, creators of Java or any people. You can find things like that, like, for example, frameworks on the internet. And you can import these packages here using the import keyword, right? And your package can be also imported. How to do it, we will talk about it in next lessons. But you can import them. And when you are using here something like that, it means that it cannot be imported, okay? When you don't add public, it means that this class is gonna be only available to this package. If you create another package, so for example like that, and you create here inside another class, and you would like to access things from here, it would not be just possible, okay? If there is no public behind the class. But if there is public, means that it's available everywhere. The same goes for the public here, okay? It means that it can be accessed from anywhere. Well, I will talk about also static. It means that it's available all the time method, okay? So it means that it's even available when you didn't create your class. So that's why the static is needed for the main, because main method, as I said in the first lessons, is the method that is gonna be executed as the first thing when you play your program, right? So it needs to just exist at the start, so we can execute all the instructions here. And well, here is a word called void, which means that what is gonna be returned by the main function when it's gonna be executed. And void means void, which is nothing, okay? We'll talk about the returning types and how to invoke methods more in the next lessons. And of course, here are arguments that can be sent to the main method later, and they can be used inside this method, right? The same for this change brightness. We can send here something and change, for example, this thing. Well, we will improve our skill, our abilities in writing things like that in the future. Well, and above 10 lessons. So this is a very long but also very important topic in order to understand anything in Java, okay? If you understand this part of programming, well, programming anything in Java is gonna be just easy, okay? So keep with me, and if you have any questions, just feel free to ask. I am always here to help you. Best regards. Hello, today I will tell you what are constructors and how to use them. In order to show it, I will create a class that we'll call a point. So point is a class, and the class can be represented by properties. What properties are representing the point? Well, it's coordinates, right? X and Y. So let's create properties like that. Int X and int Y. Okay, so now we want to create the point. In order to create the point, we type new keyword, which will reserve in our random access memory a place for our new object that we're gonna create, for the copy of object, for the instance of the object, okay? And we have to type the name of the class and then parentheses that are invoking the constructor, okay? This parenthesis with the name of the class is invoking the constructor, the default constructor. And now we created something in our memory, but well, we didn't create a reference for this thing here, right? We didn't save it anywhere, so it will be just deleted also instantly. So we should save it somewhere. So we should create a place where we could store it. So yeah, we have to create a variable which will be called this time an object. So we have to type a type of variable, a type of the object that we want to create, and we'll call it point, and for example, let's call it, well, P. And let's assign this into this, right? So now we have got a reference. Now we have got something in the memory where we can point to. So this thing is called invocation of the default constructor. And you assign it to the variable, which is P right now. This is an object now. And we can get to the X and set, for example, the values there. And later we can show it to the output. And well, as you can see, it works fine. But what would happen if I wanted to change the values, the coordinates, using the constructor? Because, well, constructor means it's gonna construct something the way you want to construct it. If you had to do something like that each time, right? Imagine something like that, bam, bam, and now P2, P3, and then now here different values, right? It would be just horrible code. You would have to do lots of coding like that. And now imagine that you have got, you know, more properties, like 50 of them, right? It's a good idea to keep everything simple and close. So it's a good idea to keep everything in one constructor that you're gonna create on your own. Let's create a constructor. In order to create a constructor, you type the name of the class you want to create constructor for, then the parentheses and these curly braces, okay? And this is the default instruction and constructor that was invoked here. Okay, so this thing is done automatically. As you can see, nothing has changed. But if we do something like that, this is default constructor, you will notice that, yeah, this is the thing that was invoked. And default constructors are used to, set some default values. So for example, let's say that I want to have default values 100 and 100. As you can see, here we have 10 and 20, but it's because of these two lines here. When we delete them, as you can see, it's 100 and 100. So we set the default values. When we delete it, it's 0 and 0. Default values for the integer inside the class is just 0 and 0, okay? But if you want to change the default behavior, you can use the default constructor. But if you want to create something more, right? You want to, for example, send here, for example, 10 and 20, you need to create another constructor with parameters. So you're gonna declare here, for example, first parameter and then the second parameter. And well, right now, as you can see, we don't have errors, and we didn't see also the message, this is the default constructor. It's because this constructor was executed. And now we send here in the line 17, 10 and 20, they were assigned to these variables here, so to the first and the second variables, and we can now assign these values to the values of actual object. So we can type something like x equals first, y equals second. And now when I run this program, as you can see, it's 10 and 20. So now when we want to create another point, we just need to do something like that, right? P2 and then, for example, 4 and 25, right? And now we just need to copy this thing, so bam, and P2, and as you can see, it's working fine. So constructors allows you to do things that are constructing the object once, right? You don't need to copy your code. So because of it, if you had, for example, some, I don't know, conditions here, right? Many instructions, you wouldn't need to copy it each time you wanted to create another object, right? This is the place for constructions, for, conditions. For example, if first is lower than 100, then I want to change the first to, for example, 150, right? That's why you will notice that we have got now both times 150. So it's like, hey, if the first is lower than minimum requirement, right? So we could type something minimum requirement 100, then you have to change it to 150, right? So you now get it. If not a constructor, you need to make for each object something like that. And if you wanted to change then something inside the code like that, you will need to change in every place you use it. That's why constructors are also great, right? Okay. So to sum up, constructors are constructing objects. That's all in the lesson. Thank you very much. Hello, today I will tell you about a keyword that is called this. In the last lesson we did something like that with constructors. But look, this thing here is not a self-descriptive name. First, second, really? Maybe we could call it x2 and y2. Then, oh yeah, maybe it's getting better. But the truth is that it is just nonsense to create a new name for it. It would be best if we could do something like that, right? Now it looks 10 times better. The problem is that compilator doesn't know now if we think about this x or the x that was sent here, right? The 10 here was sent to this place. We assign this 10 to this x. and then, hey, which one is which? And you can exactly tell the compiler which one you want to access by using this keyword, okay? When you do something like that, you say that you want to exactly access this element. So if you have a conflict of names, then you should use this keyword in order to exactly say that you want to access the current value of object, okay? So this in the situation, like for example in the line 17, it would be like p.x, right? p.y equals the x that was sent here, y that was sent here. So, but in the line 18, it will be p2, okay? So this is gonna be replaced by or this. It really depends on the situation where you gonna invoke it, right? I'd like to also add that these variables are called parameters, okay? Parameters. And values that are sent to the constructors are called arguments, okay? So here are temporary variables that are called parameters, and you need to know by temporary that I mean that they are deleted after this curly bracer, okay? So these values that are sent here, 10 and 20, are local copies for this body of constructor, and after the ending curly bracer, they stop existing, okay? That's all in that lesson. Thank you very much. Hello my friend, today I will tell you what are methods, functions, how to create them, and why they are needed. Function is simply a block of code which can be invoked, executed as many times as you want in different places in our code by us or even other people. So far we've been using something like that. Look, when we do something like that, system.out.println, as you can see, we have got here many versions of println, and we can send, for example, string, right? We can send something like test, and we can see the message. So there is a block of code somewhere there that we are executing. And the cool thing about methods is that you can now simply do something like that and everything is still gonna work, right? We're executing the same code each time. And now if somebody who created the println method would like to improve it, for example, he just invented a new algorithm so it will work faster, right? Then he will just change it there and we'll see the result here. Without using something what would be called a method, he would need to say to everybody, hey, you know, you have to now change your code in order to make it faster. This would be crazy, right? I just cannot imagine working without something what is called methods, okay? So let's create a sample class that we call test, and we'll learn the syntax in this lesson. So this will be theoretical examples, okay, of methods. So you will know them very well. In the future, we will write some better methods. But before we go into writing it, I would like to tell you that some people might have problem with me because I'm calling function methods and method as functions. Because, well, in other languages, all functions are outside of classes. And things that are inside classes are called methods, and that's the only difference. The truth is that in Java there is just no difference because there is just one type, right? Everything is inside the class, so you can call all of them methods, but if you call them functions, nothing wrong will happen, okay? When you look at the name function, it is called like that because as the name suggests, it's taking a role, function of doing something, right? And well, it's a method because it's a method for resolving the problem, for example. So methods can be used, for example, for printing something out. It can be used to get something from the input, from the forms, or it can be used to calculate something, right? Okay, let's go back to how to create a method. In order to create a method, first you need to type what is gonna be returned by the method. Right now we don't know what does even return mean, so we'll return nothing, which is void, right? Void means something like emptiness, right? It's nothing. So we're gonna return void, nothing. And now we need to call our method. It should be self-descriptive. Right now, let's call it, for example, print something out. Okay, our method right now is gonna just print something out. Okay, so let's do it. Something out. So now we want to invoke a method like that. In order to do it, first we need to create an instance of that class, right? We need to create an object and we need to store it somewhere. So let's create a variable of type test. Let's call it, for example, A, and let's now reserve in our memory using the default test constructor a place and save it to A, right? And now we can print, as you can see, using this something out. And yeah, it works pretty fine, right? We printed this thing out. Okay, so let's now make it a bit harder. What if I wanted to print not something out, but if I wanted to print my name and surname? Oh, then I should create a place where we can store these values inside this method temporarily. So we need to create the parameters, right? So for example, string and now name, string and surname. And now as you can see, the IDE says us that something is wrong because there are no arguments. We didn't send anything here. Okay, so now we can send them. For example, my name and my surname. And now we can print this thing out. So we can do something like name and a space plus, for example, surname. As you can see now it works, Arek Włodarczyk. The cool thing is that I can very fast print many things, more than one thing, right? And another cool thing is that if I, did it like, I don't know, 1000 times in different places of our code, imagine that we have got many classes and we use this print something out method many times. Oh, and for example, I'd like to add enter, right? I would like to add also information, something like name, like that. And the cool thing is now, as you can see, we are going to do it in one place. Look, we are doing it in the function. We are just changing it only in one place. And as you can see, it's been changed everywhere, right? In every place where we executed this code, because every time when we do something like that, we execute the code here. And that's the reason we are using also methods, right? You change in one place and it's gonna be changed in every possible other places where the method was invoked. So invoking the function means using this parentheses after the name of the method, and you can sometimes send arguments. And the place where you invoke a method is gonna be replaced by the returned thing. Right now it's replaced by void, so by nothing. But sometimes you want to, for example, do something like, for example, adding two numbers. How to do it? Well, then I type first the type of thing that I want to return. So in our situation, let's say it's integer. So we're gonna, for example, add two numbers. So add will be the name of our method. And now let's create parameters here. So for example, integer a, integer y. And as you can see, the IDE says, hey, you are missing the return statement. You have to return something now. Okay, so let's return, for example, 5. What will happen when we do something like that? A at 100 and, for example, 500. What will happen then? So you can see nothing happens because the thing that was returned, the 5, is right now here like that. Okay, it's just simply here standing and it was not assigned anywhere. So we have to assign it. We have to create a variable that will be the type of the return variable here. So for example, integer, and now whatever, and assign the at here, right? Let's call it maybe result. Okay, this will be better self-descriptive name. Let's send it to the output. And as you can see, now we have got as the result 5. Okay, so it works. We returned 5, but we wanted to return the sum of this thing. Oh, so we just need to do something like a plus y, right? Oh, maybe let's call it x and y. 600. When you change something here, 320. So as you can see, you can return something, right? Pretty easy. Okay, let's train a bit and let's create a method that will divide two variables. So we need double right now because it can have a fraction. The result can be a fraction, right? And now we'll call it, for example, divide int x, int y. As you can see, I can name variables the same in another method. It's because these are local variables, which means they are destroyed after this curly bracer, as I said in the last lesson. Well, because as you have probably also noticed, the method is looking very similar to constructor. The constructor is really a method, but that method is not returning anything. It's just constructing the object, and then you can assign that object to, for example, a variable like that, right? So, okay, of course, this will be double values now, and let's divide them. So do something like that. And now we'll here divide. And of course, you need to return it to the same type. And as you can see, the result is 0.45, blah, 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 blah. The result is okay, but what will happen if we type here, for example, 0? As you can see, we have got here a message infinity. It's because you cannot divide by 0. And the truth is that double is really, when you are using it, it has got something what is called a wrapper, something like that, and it's doing something like it has got methods. When you do something like that, double A, as you can see, I created it with the big number. As you can see, there are many methods inside the class like that. But well, maybe not let's not go into this topic right now. But well, as we have got the result infinity here, and we could check before, for example, if y equals to 0, then I want to return, for example, 0. Okay, I want to decide to so something like that happens. And as you can see, now we have got 0 because this instruction was not executed. Okay, you could also well, let's do something like that. Test. As you can see, instructions below the return are not gonna be executed because when compiler sees the returns instruction, it's gonna return, right? It's gonna return to the place where the method was invoked. So here, and it's gonna replace this by the thing that was replaced. So in our situation, it's 0. And because 0 is really not a double, it's gonna be changed to 0.0 because this is a double. It is a thing with a fraction, which is 0 right now. But you know, it's maybe a bit complicated, but hey, that's how it works. So that's how you create very simple methods. And as I said, they are very useful because your code becomes clearer. Everything is in one place. When you look at the name of method, you can instantly see what it's gonna do. And you should remember to keep methods and properties that are, you know, used in, for example, also methods sometimes, inside classes that will be connected to each other, right? You shouldn't create a class like I created here that, you know, do something like print something out, add, divide. Well, maybe, well, it could be called math class or something like that, right? But, you know, you have to keep everything connected to one tmeth, okay? Everything must be created in that way so it's easier for future usage. We'll talk lots of more about methods in future lessons. We will create more practical examples, so do not worry. If you have any questions, if you do not understand anything, just ask me. I am always here to help. Best regards. Hello my friend, today I will tell you about overloading of methods. Well, let's create an example and I think that we understand it better because of it. Look. Here we have got a method that returns integer and I'm adding 2 integer numbers. What will happen if I delete this and I do something like add 2 values that are not integers, like for example that, right? What happens now? We have got exclamation mark incompatible types, possible lossy conversion from double to int. And well, it's not gonna work, okay? You have to now change it to double, double, double. But, you know, double takes more space, etc. And, well, it's a good idea to just have another method that will be called the same. And, well, this is the overloading of methods, okay? You have got the same name, but different parameters. And your compiler knows which one to choose because of the arguments that are being sent to the method. So now when I type double result and I send it to the output, you will notice that the output is double. But if I change here to something to, for example, 15 and here to, for example, 55, it's gonna execute this one, right? Oh, well, we inserted into the double, that's why we had 0 there. Oh, everything works fine. And as I said earlier, even here, they use the overloading of methods, right? If they didn't overload here all methods, we could, for example, only send strings to the output. So things like that are very useful. And you have probably noticed that we were creating a default constructor, and then we created a constructor that could take more than one argument. This was also called overloading of constructors. So overloading means that you have got more than one method or constructor with the same name, but you want to have different numbers of parameters. Okay, that's all in the lesson. Thank you very much. Hello, today I will tell you what does this word static means before the methods and before the variables. Okay, so let's create a class that we'll call math. And let's create a method that will add two numbers. So for example, it will return double and we'll call it add, and now we will take here two variables. And now we should return the sum of them. Now, and this is very not cool, we have to create a special object, so for example test, and do something like that. And now we can easily invoke the add method, sending there something like that and assigning this to, for example, result. And when we send it to the output, you will notice that we have got the result. The problem is that really, do I need to create an object in order to add two numbers? Sometimes you want to have your method exist all the time, always. How to do it? You just type static before the type that is gonna be returned. And now, as you can see, we have got here an error, well, the warning, because it will work the same. But the cool thing now is that you can access it through the name of class. You don't need to create an instance of this class, right? You don't need to create the object. It will work the same. So if you have a specific method that you think you don't need an object in order to invoke, then it's time to use the static, okay? And hey, here is a static. Why it's here? Because when I click run, this class here is not gonna be created, right? But this method exists even if there is no class, no class object, right? No object created by using this class. That's why we have got here static, because this method exists always and it was invoked. It could be invoked because of it, because of this word. So the static here, as you can see, allows you to run something even though we did not create the object. Okay, so how does static variable work? Let's create a class that we'll call client or customer. And now let's create here, for example, property like name. And let's create a property that will be, for example, ID. ID will identify the customer, right? Which one is which. And now let's create a constructor that will take here the name and will assign to the name that will be sent here. Okay, so now let's take this under the comment. Let's create customer, new customer, and we're gonna send there, for example, my name. Let's create more of the customers like that. And we've just created 3 customers. Now I'd like to assign to ID different value like 0, 1, 2. But hey, I don't want to type here like 0, then 1, then 2. I would like to have it done automatically. How to do it? Well, what will happen if I do something like that? I will add +1 to the existing ID. Let's assign at the beginning here 0. And let's see what's inside there. So like that, a dot ID, and now B and C. When I run it, as you can see, every time I have got 1. Why? Because you have to remember that when you are creating an object, it's different object, right? And every time when I'm adding 1, it adds to the current property of the object, of the current object, right? And if I want to keep something always the same for all objects, I need to create something what is called static variable. So I can create a static int variable that I will call, for example, next ID, and I will assign here 1. And now I can assign here, for example, next ID, right? And I can increase the next ID by 1 after that. And now we have got 1, 2, 3. Why? Because next ID is gonna exist always. And it's gonna be always this the same, right? Well, it can be changed by, for example, in another place, whatever. But it's gonna be always the same for all objects, for every execution of it, right? When we do something like that now, for example, we get into the customer, we can get to the next ID and we can check what will be the next ID of the next user, right? But this ID here in the line 44, it's a property that is gonna be that's value will be like for the current object, right? For example, A, B, C. Okay, now when you look at this here, you would think, hey, there is too much of writing, right? We could change it a bit. Well, let's create an array. So we can create an array of customers. So for example, P new customer, and now, for example, we want 3 people. And now I can do something like P of, for example, 0 dot name equals Arkadiusz. And now I can do P of 1, P of 2. Or well, the truth is that this thing is still not gonna work, but I want to show you why. P1, P2, and bam, it's not working. Why? The array is only read from, never written to. Why? Because here we are trying to access something that doesn't exist really. We created here a space for 3 customers, right? But we didn't use constructor. Look, we didn't use this constructor here, right? We have to use the constructor for each element. So we have to type something like that. P0 equals new customer. Okay, and now it's gonna look good. So we have to do things like that in order to create more more people. Okay, so let's do something like that. And now, okay, now it's working fine. And now there is one more thing. Look, static means that it exists always. It also means that if the object, if the class, if the something in class like static method exists always, it cannot access things that might not exist yet. So if I create a variable here, int a, inside this class, right? Or inside this class, I cannot access, well, let's call it different a bit, like that. I cannot access this, right? This, that, well, what's this here? The static method always exists. I cannot access something like that because, hey, if I had, for example, 10 customers, which one I access using this keyword, right? I can. This is really accessing current object, but there is no current object yet because maybe it's not created yet, right? Static method exists always. That's why you cannot access also here this thing here, right? You cannot do it. If you want to access it, you have to create special methods. So for example, void sample. And now from this method, of course, you can access it, right? You can change it. But also in order to use the method, you cannot do something like this dot sample, right? But you have to first create, for example, static content, blah, blah, new static content. And now using this variable, then you can access, for example, A or the method sample. It's very important that from the static content, you cannot access things that are not static, right? That do not always exist. Okay, that's only the lesson. Thank you very much. Hello, my friend. Today I will tell you about packages and about modificators for classes, for methods, and for variables. Okay, so what is a package? Package, as the name suggests, is something that wants to pack classes with methods and variables inside that are related to each other by subject. Okay, so they must be related to each other, right? When we have the package called video courses, I would like to have here classes that are related to video courses, like for example this class, like for example box, DVD, and other things like that. We want to have everything to be easy to maintain. Okay, why? Because, well, your program might be big later. It doesn't need to have only one class, it can be thousands of classes. Look, you can import using the import other packages keyword. And when I do Ctrl plus space, as you can see, we have got here a few packages. I can go to one of the packages and there is another package inside that packages. And when I go to, for example, this one, I can get into classes that were created by other people, or maybe into another package. So because of it, everything is easier to access, right? They have their place in, the big amount of classes. If they were all in one class, in one file, it would be just horrible. So that's why we need packages. Okay, there is another thing. How to create a package. You type package, then the name of package. That should be the same name like here, and the same name like the folder like here, because this is really a folder that is gonna store classes. And inside of it, every class that is below it is gonna work in this package. Okay. Now, what will happen if we have another package and I want to access things from here? Well, let's do it. Let's create a package. New Java package. Okay, let's call it new package. It doesn't matter. We just want to theoretically do it. And let's create a class there. Well, we can get called new class. And now we have got two packages. New package and video courses. Okay, now let's create here using the Ctrl plus space the method, static method main. And let's try to access something from here. Let's, for example, try to access this guy here, the video courses. Can we do it? Well, we have to first import it. When I type import, as you can see, now we have got new package, video courses, and I can import this class from there. Why? Because this class has got public before it. If you want to make sure that this class cannot be used in other packages, you want to delete this, okay? Then, as you can see, you cannot import it here, right? You cannot import it. But if you change it back to public, it means that it is public and it is accessible in every possible package. So now we can use it by importing here video courses and now video courses, and then we can create the instance of it. So video courses equals new video courses, like that, right? Or without importing, you would need to type every time the name of package dot new video courses dot, and it also would work fine. So you can use it only because of it. If you create any class inside here, right, inside one of the files, for example, right, like now, for example, class test, and we create a static thing here like that, you will notice that we can access it from here, test.a, right? That's because this class here is package classes, and we are in the same package, right? In video courses package. So we can access it easy. But can I access it here? Well, let's do it. Test that. You cannot do it. Well, can I import it? Import video courses. I can only import video courses. You can import all possible classes using the asterisk from one of the package, something like that, okay? Well, so we imported only this guy, and we cannot use this test here. Can I make it public to make it work? No, I cannot do it. Why I can't do it? That's because you can have only one public class per one Java file, and this class has to be called the same as the file, okay? So you have to create a new class for that, for example, test. And now here, when we copy it to here, right, then we can easily access it also here. Test that, video courses that we need to import it, right? And now when we click test, wow, well, that's why, okay. As you can see, we cannot access somehow this thing here. You might be wondering why, because it's public. Yeah, it's public, but by default, it's good that I made this mistake. By default, everything inside the class is package. Has got a package modifier. Default modifier is always package, okay? So it means that it's not accessible from another file. So here I can access it easy, right? We can send it to the output, test A. As you can see, it's working fine. Everything is okay. But, and it's okay because we are in the same package, but here we are in the package that is called new package, right? So we can import it because it's public now, but we cannot access it because it's not public. So you have to type here public. And now, yes, you can do it. Test that A equals 20, and you can send to the output, for example, this thing, right? So test A, and if you want to run exactly this Java file from another package, then you right click here and then run the file. As you can see, it's 20. So now you can access it because you type here public. So if you want to have your class to be shared by other packages, to have variables to be shared in other packages, you have to type public, okay? Otherwise, it will be only accessible inside the package it was created in. Okay, and you know, most time you really don't want to do things like that. Even more, you want to make things private. Private means that it can be accessed only inside the class it was created in. So if I type here private, we will not have access to it not only in the package that it was created in, we will not have access even, well, we will not have access in another package and also in the package it was created in, right? You can access now this variable only inside this class. So only if we create here, for example, a sample method, and now here I can access this A and assign to it, for example, 25, right? You can do it only from within the class, okay? Not outside the class. You cannot do it. This thing is called encapsulation. We'll talk about it more, why we need things like that. Well, for example, well, in the last lesson we created something what was called next identifier. You should know that we could also change this identifier all the time, right? We could change this ID from outside of that class. It would be horrible if somebody changed it by mistake, right? We wanted to have the ID to be increased one by one. What if somebody changes it from somewhere he shouldn't be able to do it? That's why sometimes you want to use the private here, okay? Modifier. This is modifying how things can be accessed from another scope. And there is also something what is called protected, but in order to understand how protected works, you need to also know what is inheritance, and we'll talk about the protected keyword when we talk about inheritance, okay? So after this lesson now you know how to use public keyword, how to use default keywords, what are packages, they are for, you know, having your code easier to maintain, right? To share with other people, and the accessors, the modifiers like public, like private, and the default one, the package modifier, is used so you can change how things can be accessed, right? So because sometimes you don't want to make people access everything, because it can lead to some errors. And you should know that when you are programming in object-oriented way, you want to have everything in many parts. So one part doesn't need to know about another part. You should think it as the in real life, for example, car is working. You have got, for example, engine, right? And inside engine there are lots of parts you don't need to know about. As the user of the car, you just need to know about steering wheel, how to turn left, right. You don't need to how things work inside. And if you, as the noob in the newbie in the, for example, car theory, you could destroy some things if you try to change them, right? Only professionals should know how to do it. So that's how you should think when you are creating programs in object-oriented way. That's only the lesson. Thank you very much. Hello, my friend. Today I will tell you about encapsulation, and I will show you it on examples. So before we go into the definition, let's get it from the context. So we have got a class called bank account, and well, every bank account has got a balance. So let's create it. And now let's create bank account. So bank account, let's call it a new bank account. So we have got a bank account now. And now, wow, let's become rich. As you can see, now we are very rich. Oh, let's add one more zero, so we are going to be more rich. As you can see, it's a bad idea that you allow people from outside to change the balance that easy. Well, for us, maybe it wouldn't be so bad, but it's a bad idea, right? You should make variables almost always private. When they're private, they cannot be accessed from other classes. You can access them only now from within the class the variable was created. Because okay, I'm not going to change the balance anymore, but it would be a good idea if I could check how much money I have. Then you have to create a method inside the class and get this balance. How to do it? Well, let's call it int get balance. So we say that we're gonna return integer, so the balance. We say that we want to get it, and this thing is called getter. Getter are used to get private members of your properties of your class outside, right? For example, here. So now you can do a.getBalance, and as you can see, it works fine. And now we are poor. Oh, let's give ourselves a gift. let's create a constructor, and let's do something like, let's assign to balance $1,000. Okay, now we have got something on our account. Okay, so now we created a bank account. Now we can get the balance, but we cannot change it. So that's why you also want to create sometimes variables that are private, because you can show it to other people, but you now cannot change it. But hey, what would happen if I want to deposit something? If I wanted to withdraw something from my bank account? Okay, then you should create a method for doing it. Let's create something what we will call setter. Set balance. We will not return anything. I think we should take the number that we want to set our balance to. So for example, number here, right? Or amount. And let's set balance to amount that was sent here. Okay, but the problem is now that we can again do something like balance and send here big amount, and then again we are rich. But here is a difference. I can make here tons of conditions. Okay, I can check if that's the right guy, if you know, he is able to do it, blah 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 blah. You can do whatever you want here. Okay, that's the difference between the solution that we had before when it wasn't private. Okay, so it's very important to make setters, because you need to anyway set things, but you can make conditions now. Okay, let's create now a method that will allow you to withdraw something from your account. So let's call it withdraw, so it's self-descriptive, and the amount will be sent to that method. And now we are just going to do something like balance minus equals amount. And okay, so we have got at the beginning 1000. Let's withdraw, for example, 100. It works fine, but what will happen if I do something like that? We withdrew more than we have got on our bank account, right? So it's not good. We should first check if our customer has got enough money. So if balance of the account is bigger than the amount you want to take from, then you can do it. Otherwise, hey, something is wrong. We'll return false, for example. So let's change the type of the method like that. And well, we need to return something if everything is alright. So return true. We can type return true here, or we can have it inside the if statement. But the truth is that if that condition is not met, right? If else instruction is not run, this one, then we'll just return true. So it can look like that. Okay, so now, as you can see, it's still 1000. So as you can see, it's cool because we can make conditions, and there can be thousands of conditions like that now, and you don't need to repeat them, right? You can now, for example, do something like if everything went fine, like that, then send to the output, okay, otherwise not enough money. As you can see, we have not enough money, so the money wasn't taken. Okay, but there is one more thing. Why did we do something like that when we have got a set balance method here? We could really type something like that, set balance, and now the current balance minus amount that was sent here. Everything will work the same when we type the normal number like that, as you can see. But you know, now we are using the script that has been already written here. Okay, we can use the conditions that were here and many other things that could be here. Remember that methods are really created so you can reuse them, right? Maybe this was very easy instruction because it's really assigning here, and here it was only the subtraction or maybe adding something. This is easy, but you know, this is simple example. This can become very many things to do, so try to use your methods. And now you can also make this private, and you can now withdraw using this method only through the withdraw, and only if you check, for example, conditions here, right? You don't need to allow to set balance outside without providing money, right? Well, providing money, it should work for deposit, right? Sorry, when we create a deposit in amount, now we can deposit, for example, set balance plus amount, right? And return the true. So let's do something like a deposit. So I'm adding 1,500, and as you can see, it's working fine. So deposit is now using this method here inside, and so you don't need to repeat some things that would be inside here, right? And the cool thing also about this is that we have got our program now in parts, in modules. You can exactly see that, hey, this method is for depositing what amount. Okay, here I'm setting the balance, and I am just sending a new balance here. Okay, return true, it means that if everything went fine. Okay, now it makes sense when you look at it. I know that when you are looking at this and you are new to object-oriented programming, you might be like, really, why did it make it looking so bad? I could just do everything in one line. Yes, you can, you could, but it would be horrible if you made everything in one line if you worked with other people. When you are working with other people, you want to create things that way, so it's easy to communicate with other people. So one person can work on one part, the second on another part. When you are writing things in line, right, the fast code, then this is the way you would probably program on your own. And really, this is also the solution. The object-oriented programming is not the only way to program, but that's how Java is constructed. So Java is a language used for working with other people, for creating a code that will be easy to read, easy to maintain, other things like that. There is lots of code that will be added because of that, but this is how you write in Java, okay? And this is the solution for creating the applications, to creating big companies. That's why there is money most time. But if you want to create something fast, very simple, then Java might maybe not be good for you, right? Then you can use, for example, Python, C, because you want to write something fast that will be work, right? But if you want to, understand everything and you want to work with other people, you have to know all this syntax, how everything here works, so you can create things on your own, right? Okay, that's all in that lesson. Thank you very much. Hello, my friend. Today I will tell you what is the difference between references variables and primitive variables. Well, what are reference variables and other things like that? So, the first thing that we should focus on is what is a primitive variable. A primitive variable is just a typical variable like integer, like float, double, character. Reference variables are class type variables. So when you create a class, for example, like that, you can store here many values, right? And they are this class type variable. So when you do something like that, test, test, new test, it means that I've just created a variable that is a reference. Why? I will tell you soon why it's called reference. But before we go to it, I'd like to remind you what's going on when you are creating a typical primitive variable. When you type int, you say, hey, I want to reserve 32 bytes in the memory. And I want to access this memory by using, for example, X label. Okay, now I would like to assign to that place in that memory a value, for example, 50. And now we have got there, under that label, we can access 50, okay? Pretty easy. And now when we create another variable, for example, y, and then assign to it x, and then I change y to something else, for example, 10, and I send to the output now, for example, x, you will notice that x is still 50. Why? Because the y variable is really a copy. And you just assign here 50, right, in the line, and then you change it to 10, that's all. You change this value. But here is the problem. Let's assign here, for example, 20 to this, okay? Let's delete another variable so we do not confuse ourselves. And now let's create test. What's going on when you type this? It means that you are reserving in the memory, in the random access memory, a place. And you assign that address to that variable. You do not assign value, you assign address, okay? That's the difference. So that's why it's called reference variable, because you refer to the place in the memory, okay? This is address. You know, if it was a value, it would be hard to store more than one value, right? You can have here plenty of values, many arrays, other things like that. And you cannot store all these things in one place, right? You have got here in that variable now a reference. So you have got here an address to thing like that. And now when we do something like test, well, when we create another test, for example, test, and we'll call it test2, and we assign to it test, what will happen when you do something like that? Test2 a, and I will assign to it, for example, 50. Now when I send to the output test.a, you will notice that it's 50. Maybe let's change here, this to 30, or comment this section so we are not confused. As you can see, it's 50. Why? Because here in this line I am assigning an address. So the truth is that test and test2 is really pointing to the same place in memory. This test is a reference to test2. It's like, I know, calling a dog baby and calling a dog Rolf, right? I can call him both names, and if he knows both of them, he will react to the same thing, right? Right now, we assigned here, again, I'm telling you this, an address. That's why when you change the value a, you really change it like if you did it that way, okay? This and this will give you the same results. Bam, bam. the same results. And that's how all reference variables are working, but one that makes even more confusions. Well, look, we have got a string, and string is really not a primitive type, but this is a reference variable. When you create a string and, for example, name Arkadiusz, and then you create string name2, and you assign to it name, what will happen when you do something like that? Name2 equals, for example, Viola, right? What will happen when I send to the output name? Well, it's still Arkadiusz. But you just told me so many things like that and I'm confused so much right now. It's only because string is special. Why? Because most people, these beginners, do not know about things like that. They try to hide references from beginners. And this is the thing that happens here. The truth is that you are reserving here, but it is not shown to you, right? It's done in the background, behind the scene, when you compile it. As you can see, the result is the same, right? We changed name2 to Viola, and well, it didn't affect the name 1. Because you are reserving here now a new space in memory, and you type there that place in the memory will be pointing to the place where this value will be stored, okay? Arkadiusz. So that's how it works. And you might be like, why did they do it? Well, because string is so often used, and it's, they wanted to make it feel like it was a primitive type almost. There is another thing that we need to talk about, and we'll talk about in the next lessons, but hey, that's why they did it. So if you are confused about this section right now, do not worry. You just need to remember that strings are almost like primitive types, okay? When you just assign something to the string, you do not change. They are almost like copied, okay? But this is very important how this works, because it can lead to many problems that I will talk in the next lesson. That's all in the lesson. Thank you very much. Hello my friend, in order to understand this lesson, you have to watch the last lesson. Let's see what will happen if we create a class, let's call it test, and now let's create here a variable a and assign to it, for example, 10. And now let's create a method that will not return anything, so void, and let's call it change value, and here we'll take, for example, a variable. And we'll change this variable to the same variable, but we'll add to it, for example, 5. What will happen when I create test, and now when I change the value like that, and then I check what is that value now. As you can see, it's still 10. Why? Because, as I said in the last lesson, when you are creating something like that, a typical primitive variable, we know that the value under the a label is 10. And it's like, hey, I've just sent here 10. And this is a parameter. And the parameter is like saying, hey, let's assign to it 10. Okay, it's like saying something like that. So we are creating a new variable. We are sending here 10, and then we assign to variable 10 plus 5, and now it's 15. And now then after this curly bracer here, it's deleted. That's all. This variable dies. This parameter dies. Okay, here. well, in this place from here. So actually we didn't change the a here, right? If you wanted to change it, you have to make something like that. You need to return at the end the result, and it's still not gonna change it, but you can assign the result to the variable that was sent. And now it's changed, right? Because we assigned a new value. Okay, so let's change it back because I want to show you something. What will happen when I create another class, for example, called foo, and I create in it a value foo, and now, well, let's make it x, and now let's create this foo. So foo equals new foo, and I want to change this foo using this class. So I will create change foo, and I will take it here, so foo variable, and I want to get into it and change x to, for example, the x that it was there plus 15. So let's assign here 10. So when I send this here, the foo that we created here, because, well, the new is really reserving the memory, right? The address is then assigned to this reference variable because it refers to the address. You are using the constructor that is default, so you're not doing anything but constructing it, right? You are reserving the place, and you are also initializing the value, so you're assigning to x10. And now when we do something like test that change foo and send foo there, when I do something like foo dot x and send it to the output like that, you will notice that it's 25. We change the value of the object, right? And why? Because, again, when I do something like that, it's like saying foo equals the variable here equals that foo that was sent here, and here was what sent? Address. So we assign here address. Okay, it's copy of this address, right? Because we have got now a new parameter, but it's still the same address. Still the same. So we are pointing to the same thing. We are making a change on the same thing. That's why when I type something like that, I'm really changing this guy here, right? It was created here, because I am not changing an address, but I am changing the thing that is under that address. And that's the difference between this and this. If you send a string, and please do it as an exercise, it will act as primitive values, okay? Because string is different, it is used very often, and they created it like that, so it doesn't make confusion, but I think it makes more confusion. Okay, that's only that lesson. Thank you very much. Hello, my friend. In order to understand this lesson, please watch 2 lessons backwards, okay? It's very important. So, what happens if you want to compare 2 strings? When you create a string with the name, for example, Arkadiusz, and then you create another string with name 2, with the label name 2, and I will assign to it also Arkadiusz. When I do something like that, name is name equal to name 2, then let's send to the output they are equal. And as you can see, they are equal. But will it always be true? No, because value here and value here can be sent from other place. Right now this thing is called literal. It means that it's literally place it here. I just place here these characters, and when compilator sees a situation like that, hey, it's Arkadir. Why don't we use the same space in memory for them? It's good optimization, right? Why would I store them under two different places, right? Okay, so let's assign to the name the same address and to the name to the same address. That's why when we do comparison like that, we have got something like they are equal. But if, right, these values will be taken from another place, whatever, it could make here a big mistake, because it will compare really that this is comparing addresses, okay? So if you, for example, create it using this method, you will notice they are not equal. They are not equal, right? That's because here is an address and here is another address. Remember, this is a reference variable. Still is a reference variable. And when you check it like that, we can see here that they are not equal, because addresses are different now, because we exactly say, hey, reserve. The new keyword says reserve a memory for this, reserve a memory for this. Without this, because our compilator is very intelligent, he wants to make optimizations, it will put it in under the same place. That's why it's very important to compare in situations like that, well, using the method that is called equals. Okay, the name has got, well, the string object has got a method that is called equals, and it checks if two strings are equal. And then we are comparing really the values of strings, okay, not the addresses, but values. So right now they are equal, and also if I do it that way, they will be equal. I know it makes lots of confusion because I told you so many things about reference variable, but strings are just different. If you do not want to, think about for a long time, just remember that when you are comparing two strings, you need to use this method instead of the equal signs. That's the thing you have to remember, and you have to remember that when you are sending strings, when you are copying string, assigning strings to another strings, they are working the same as primitive values. That's all in the lesson. Thank you very much. Hello, let's exercise a bit, because if we go too fast, we're gonna forget about a few important things. Let's train, okay? Let's create a class that will be called bottle, and we will be able to fill this bottle. We will be able to pour the water out of that bottle, and we'll be able to transfer the water from one bottle to another bottle, okay? So how to do it? Well, first we need to create a variable that will represent water, amount of water, right? So let's create, for example, double amount or just water amount, right? Something like that. And well, it's double because we can use fractional numbers here, right? And we are going to use this class because why should we create another class? We don't need to. Here is a class that we can use. This is the main static method which exists all the time, so we can create in it this class, right? This is just a method that exists always, and it doesn't matter. You can create inside of this class, in that method, this object. So let's create a bottle. So we can do it like that, but let's create more than one. How to create more than one? Well, the best way to do it is to create an array, right? So we don't need to every time create another variable if we want more. We just need to increase the size. So let's create an array. So we have to use this brackets, and now let's call it, for example, bottle, and now new bottle, and for example 3 of them. And now this is very important. When you do something like that, you are reserving the place for these bottles, right? For this type. But by default, all bottles will have the null value. What does it mean? It means that it's really something like that, okay? And why I'm saying this is because right now, well, you know now that this is a reference, right? Null means that you refer to nothing. There is no address that you refer to. You have to first create each guy using the constructor. So a new bottle like that, okay? Let's copy it now, like that, bam, bam. And now we created using this constructor each object, okay? You can do it in loop, and this is your exercise. Do it in loop. If you have problems, just ask. And now let's create a constructor for it. So there is a starting amount, right, of water. So let's create a constructor that we call bottle, and let's send there, for example, water amount, right? Water amount. And let's assign to water amount the water amount that will be sent here. And as you can see, we have got an error here. Why? We just added a new constructor. It's because that if you create a constructor that wasn't default constructor, you delete the default constructor. You have to create it, even if it's gonna be empty, you have to create it on your own, okay? But if you're not gonna use it, then it's okay. You can just, you know, send here amounts and everything is gonna work fine, okay? It's working now. But without sending anything here, it's gonna give you problems. Okay, so we just created 3 bottles with 10, 5 and 1 liters inside, right? And to pour out something from the bottle, okay, the water. So let's create a method that will not return anything. Let's call it fill, and it will take double water amount. So we can call it water, and this water amount, we want to add the amount that was sent here. Now let's copy it, because pouring out will be very similar. It will look like that, right? And now we can do something like that. Bottle of 1, fill, amount, for example, 5 liters, and let's send it to the output. So, well, we should call this variable private, so we keep encapsulation, and let's create a method that will be able to get water amount. So it's a getter, right? And we're gonna return the water amount. So bottle of 0, and now get water amount. Let's run the project. As you can see, it's 15. So we added 5 liters. If we use the pour method, we're gonna delete 5 liters. Okay, let's now create a method that will transfer water, right? Transfer water. And we need to know how much we want to transfer and to where we want to transfer. So to another bottle, right? So we need to take another bottle here as an argument, right? We need to create a parameter bottle, and let's call it, for example, transfer to bottle. And now we want to do what? We want to fill. Well, we want to first take from the bottle we want to pour from. So this, that, and now we want to pour the amount that is sent here, and then we want to send to the transfer to bottle, and transfer water, we want to invoke fill. We want to fill it by the amount that was poured, right? So we can use these methods to do something like that, right? We don't need to again write this code and this code. I know that this code and this code is very small, but hello, we can do some conditions that we will need to do soon. Look, right now we can, for example, transfer water, and let's transfer, for example, amount 5 to the bottle that will be bottle 1. And as you can see now, we lost in bottle on the first index, and the index 0, the first element, right? We lost 5 liters, but we added to the second guy 5 liters. So we have got 5 and 10, okay? The problem is what will happen if I do something like that. As you can see, well, our bottles are bottomless, right? You can take as much as you want water. That's not good. So you have to make conditions, right? You have to do something like that. If the amount of water that we have got right now is lower than the amount that we want to take, then we cannot do it. So if it's bigger, then you can do it. Otherwise, it's not possible. So now it didn't work, at least pouring out, but filling worked, right? So we should somehow inform this instruction that this instruction was wrong. So we should now return here boolean and do something like that. Otherwise, return false. Or return true always, right? Return true if everything here went fine, right? If that condition was not met as condition. So it's gonna return true. So here now we can check if this thing worked, then execute this, right? And then now nothing worked, right? Right now you can say something like else the amount was too much. Oh, there is not enough water. There is not enough water to transfer. So that's how you do it, right? You could also return here false, true, and then return it here and then check here. But the truth is that there is another method to do it even better. It's called exceptions, and we'll talk about it in the special sections. And now I'd like you to train a bit more. I would like you to create here another property that will represent the amount, the capacity of bottle, right? Because right now we can put as much water as you want into bottle. And I would like you to, check in the fill method if we didn't exceed the capacity. And I would like to also, well, it will in the same time check it here, right? That's why we are using these methods here, so we don't need to check 2 times conditions here and here, the same conditions. So let's do it as an exercise, and also I would like you to change this into initialization with the, for example, for loop. Okay, that's all in that lesson. Thank you very much. Hello, today I will tell you about inheritance. Inheritance in real life looks like that. You have got, for example, parents, and you inherit from them some characteristics. For example, you inherit from them the color of the eye, you inherit from them how tall you are, and so on, right? You get it, that's pretty easy. And in programming, it's the same. For example, when you want to create a game, you have got monsters in that game, right? Monsters. And there can be many types of monsters. For example, zombies, skeletons, and many others, right? But you get it. And look, when you look at monsters, zombies, and skeletons, all of them have got, for example, hit points, right? All of them have hit points. Okay. All of them can attack, so they inherit all hit points. All of them can attack, so they have got some habits from their parent. So everyone have, for example, the speed they move, right? There are many things that will be very similar to them, right? So now imagine that you write like 100 line of code, maybe 300 line of code in zombie and skeleton. And now imagine that you want to change something that will affect hit points, attacks, and speed. You have to now change in this class and this class. Okay, what if you had 50 monsters? You would have to change in 50 places this thing. Horrible. That's why you have got something what is called inheritance. You can create a monster and you can create zombie, and zombie will extend. It will inherit things from monster, okay? And that's what is inheritance, and at the same time you know why you want to use inheritance sometimes. Okay, so we now know what is inheritance, how to use it. Let's create a new package, because I want to show you later how protected keyword also is gonna work, but not in this lesson, but it will be in future lesson. So let's create a new package and we'll call it, I don't know, monsters. And let's create a new class that we'll call monster, a new class that we'll call skeleton, skeleton, sorry. And also we'll create zombie. I want brains, yeah. Okay, so we just created 3 classes, right? Let's now define monster. So monster, every monster has hit points. So double hit points. Every monster has got some kind of speed. Every monster can hit, so they can attack. Okay. So let's create a monster here. Monster equals new. And now when I click Ctrl space, enter, you will notice that IDE NetBeans is importing from the another package the monster. Okay, that's very cool. If I didn't import it, as you can see, it's not working. Okay, because it's in another package. So we've just imported this package and we can use it because it's public. If it wasn't public, I couldn't use it, right? And now we have got now our monster, and when I click that, as you can see, I can't attack, I can't use anything. That's because these things are not public. So let's make them public. I know that I am not encapsulating things like that, things here, but we are not focusing on encapsulation in this lesson. You can encapsulate it, so you can just do it private, and do getters and setters, etc. Do it on your own, but because you can train here, right? That's easy. In this lesson, I would like to show you how inheritance works, okay? So, but we need to be able at least to, invoke attack and check if something changed, like hit points or speed. Okay, so we've just created an attack method that allows us to attack. So I am attacking from monster class. So let's imagine that here is script that attacks people. Oh, sorry, maybe people, other monsters. Oh, okay, let's leave it like that. Monster that attack. Okay, it's working fine, right? We have got only one class now. And now let's create a public constructor, public monster. So we can invoke it, and let's create a special monster constructor that will have 2 hit points and speed. And now we'll do this hit points equals hit points, and this that speed equals speed. Okay. So now we can create a monster with some variables at start. So he will have how much hit points, for example, 100 hit points and speed of 10. Okay, and now we can send this to the output. Monster dot hit points and monster dot speed. It's easy, right? We just created a normal class, but now the magic happens. I want to create the skeleton. And now if we did not have something what is called inheritance, I would need to type everything from here, because it would look almost similar here again. And imagine that inheritance is like, hey, let's copy this to here, okay? So we're just gonna type extends monster class. Okay, it's almost the same, like if we had copied it. Great, isn't it? Now when you create here a method, whatever, you will notice that we have got access using this to hit points, to speed, to attack. So it's really like if we had all these methods and properties here inside, right? You can of course say something like, hey, I don't want you to have, for example, attack there, right? When you do something like that, then this, that, and this, you can see you don't have access to attack. It's not possible to use it anymore, okay? So you can change how things work using, for example, private modifier. But if you do not do it, then everything is just here. Okay, so how can we use this information? Because hey, skeleton can be a bit different. He can, for example, move faster and so on. And he can attack a bit different way. How to do it? Let's create a skeleton. As you can see, it imported it here automatically. And now let's, for example, use the attack. What will happen? As you can see, I'm attacking from the monster class, right? And well, what will happen now when we do something like that? I am constructor from monster class. I am constructor from monster class with 2 arguments. As you can see, well, we have got now here, I'm constructor from monster class with 2 arguments, it's from here. And I'm attacking from monster class, it's from here. Let's take it under the comments so it will not confuse us. Now you can see I'm constructor from monster class here, right? So it means that when you are creating a skeleton, you really are invoking first this constructor. Because let's think a second. You cannot do anything in the skeleton without having monster first, right? You have to first create base for skeleton. That's why monster is called here a base class. It's sometimes called super class, or sometimes it's called parent class. And this class, the skeleton, is called right now something like child class. Well, maybe let's go in that way, base. So this is derived class, and this is called subclass, okay? The one that inherits something, that extends monster. And well, what will happen if now I use not the default constructor? Because when I'm using default constructor, everything is working fine. But when I send here, for example, I want to have more hit points and faster speed now, it's not working. Why? Because if you are not using the default constructor, it's not created now, right? We have to now create the constructor that is default, and you have to create the constructor for skeleton that will take arguments like here. So we need to create parameters like that. And now when we invoke it, it's working fine. But there is a small problem. What will happen when we send to the output skeleton hit points? Is it 1000? No, it's 0. Why? Because that is the default value of hit points and speed, right? And it's because this thing was invoked, and as you can see, I am constructor from monster class, and then I am attacking from monster class. It means that, oh, of course, let's do something like that. I am constructor from skeleton class with 2 arguments. And here I am constructor from skeleton class default, maybe default constructor. It'll be easier to see which one is. I am default constructor. As you can see, it says I am default constructor from monster class. The default constructor is always invoked if we didn't specify which one has to be invoked, okay? And if you want to change this behavior, because we invoke the default one and with 2 arguments, but well, we didn't use these arguments. We will need to now do something like this: hit points equals hit points, and this dot speed equals speed. And then, well, it's working, but it's not good idea to do something like that, because really, do you want to repeat everything that's here? It would be great if I could somehow get from here to here and execute everything from here. I know this is only 2 lines, but remember, there can be many conditions, there can be many other things. So you can do it using something what is called super. Super is a keyword that allows you to get to the superclass, to the base class, to the parent class, right? So super, and then you execute with something like parentheses the constructor up here. But when you use it like that, you are invoking the one with no argument, right? Because you didn't send here an argument. So nothing changes here. But you can invoke this one, right? Sending hit points and sending speed, okay? And now it's working fine. And this is a good solution because you are reusing the code that has already been written, okay? That's very important. That's how you should write. That's how you should create things, okay? So now you can, change something. For example, string, type of attack, right? And you can, for example, create another constructor. And you can take here string type of attack. And here you can invoke the method up top, and this dot type of attack equals type of attack that was sent here. And now you can, create the skeleton like that, or you can create it like with, for example, bow, right? You can do things like that, skeleton too. And well, you can, for example, here you can by default set type of the attack to, for example, axe, right? That starts to make sense, right? You can make some changes in the skeleton because it's not the same monster, but some things are very similar. So why to repeat? And of course, you can do the same things in zombie, right? The extends, the monster, and then you can just go on. You can try to do something fun here as an exercise. That's all in that lesson. Thank you very much. Hello, in the last lesson we learned about inheritance and we created a skeleton, zombie, monster, but what if I wanted to, for example, attack as a skeleton or zombie a bit different way? What then? Well, you should somehow invoke the attack method from here in order to, do the script that normally is done. And in the same time, it would be great if I could, for example, create something for my own usage, right? Because here is a type of attack, something different, right? So how to do it? Well, you are just going to type the same things that are here. So you can just copy it and paste it here. Not the body, but the same signature, okay? And now when you copy the same signature here, as you can see, here is an hint. Hey, add overwrite annotation. When you use it, you are adding something like that. This is an annotation, and when you click on it, you're gonna jump to the overridden method, okay? So it is like, from now, I am attack method from skeleton class. When you do something like skeleton attack, you will notice that here is I am attack from skeleton class. We invoked only this method using the skeleton, okay? If you want to invoke things that were here, if there were many instructions that are important for you, then you're gonna type something like super dot and then invoke, for example, attack, right? Because you are invoking now the method from here. And as you can see now, we are invoking both, not first from the monster class and then from the skeleton class. So that's how overriding looks like. If you, for example, pass here something new, so for example, the type of attack, so string type of attack, this is no more an overriding, okay? As you can see, it says remove this annotation, because this is overloading of method. Because right now it's like, hey, you have got this method copied here because of inheritance, and this method is overloaded by this method, okay? Because they have got different parameters. And when you execute the one without arguments sent here, you will notice that we are invoking the one from the monster class. If you send here an argument, right, it's of course gonna invoke the one with the argument. But it's very important to understand the difference, okay? So this is called overriding. But what is a polymorphism? Okay, let's delete all these things from here. Let's create a monster like that, and let's create a zombie, and let's create a skeleton. How many names do you see here? Many, right? Poly from Greek means many. Morphism means form. Right now, you can do something like that. With the single form, you can take many other forms. Okay? It's gonna work. You can easily assign to the parent child. You can't assign child to the child parent, but you can assign to the parent a child object, right? You can point, refer to something like that. And that's very useful. You might be like, but why? Because you can create the method, whatever, and then you can create monster, bam, bam, bam. And now you can send to this method, right? You can later do something like this. Oh, maybe not. We will need to create instance of inheritance, but you could send here. Oh, you can also make it static. When you make it static, we'll be able to do it. So we can access now inheritance and do something like whatever and send there, for example, new skeleton, right? You can send it here. Pretty easy now. You can send there zombie, you can send there the spider, you can send there the wolf, you can send there whatever you want, and you can have only one method for all of these things. That's the great thing. Then you can check what is that what is that class, and you can do whatever you want on that thing. And that's the cool thing about also polymorphisms, right? Because one single thing you can access many. And also polymorphism is looking a bit different when you want to invoke a method. Because look, right now we created something like that. But what will happen if we do, for example, something like that? When we do something like that, what will happen when we do mattack? You will notice that it's very important. When you are reserving the memory, you are invoking the constructor from what? From the derived class, then from the base class, right? And that's why you can assign really monster here, because hey, here is also a monster. Here's monster and skeleton, but they are both here. That's why you can assign it here. But when you do that attack, as you can see, it's invoking both methods also, but it's only because we did something like that. When I do it like that, you will notice that we have got access only to this method. We cannot now from here access somehow the method from monster, okay? You can only access the one from the skeleton. At least for now. It's also very important that you have got access to it only because we created a method like that in here and here. If you had another method, for example, here void test, you will notice that when I do something like that, you can access test and bam. As you can see, it's gonna be invoked. What will happen if I totally delete it from the monster and create a new method here? As you can see, it's not working anymore. That's a good thing to know, right? So it's really very funny because when you do something like that, you have got really access to only things from monster, okay, class. But because here you assigned the reference to the skeleton, when you look at skeleton, you override, because you overridden this method, using this object, you could somehow invoke this attack method. And this is called also polymorphism, okay? Well, polymorphism means that it's like an ability of an object to take on many forms. Ability of something to do many things, okay? Because poly means many and morphism means the form, right? If you do not understand what is polymorphism, it doesn't matter, right? You don't need to know what is polymorphism exactly because you are just gonna program. You just need to know how to use it. And the most important for you to know is that when you are sending here something, right? You can send pretty easy the skeleton here, bam, and you can access it using something like that. You can change this behavior if you want to, for example, if you wanted, for example, somehow access this test here, you could change this behavior by doing something what is called downcasting. You could do something like that. Test. Sorry, not test. We could take the and now we could, hey, let's downcast it down, right? Let's cast it down to the skeleton. And now, as you can see, when we do something like that, I can access test. It's because right now I am saying that this is, a skeleton. It's really a skeleton. That's how you can access things from skeleton. And we are saying that we know what we are doing, right? If there is nothing here, like that, you can only access, as you can see, the methods that are, or properties that are in the monster class, but not the properties on other things that are in derived class, unless they are overridden, right? That's the difference. Because they are also in the monster class, and somehow there is a magic behind, a polymorphism that allows you to use the attack method, for example, here. Okay, that's all in the lesson. Thank you very much. Hello, today I will tell you about protected modificator. Before we go into this topic, we gonna make some kind of rehearsal on the public, the normal modificator, the default one, right, and private. So when this is public, right, like right now, it means that this variable is accessible everywhere. So we can do something like from another package m.dat, and I can access it, right? I can access it in every possible class that inherits another class, and so on, right? It's just, you can access it everywhere. When you delete the public, it means that it has got the package access modificator by default. What does it mean? It means that, well, you can access it now here, right? You can this, that, and you can access speed and hit points. The problem is that you cannot access it now, for example, here. When you click that, and you cannot access it. Maybe it's a good idea that you cannot access it from another package, right? Because somebody could get into things there and do something very wrong. But what if I created, for example, 10 monsters, and I would like to allow somebody to create other monster outside of my packages? Well, when we create another package now here, and well, sorry, not a package, but I wanted to create a class. So for example, I will create a spider, and I want to import here first the monsters, then I want to import from there, well, a monster, and let's extend monster extends, and now let's create whatever function and now let's do something like this, that as you can see I can access attack, right, but I cannot access this because this has got package modificator and this class is here. And that's when you want to use the protected keyword, because if you use the protected keyword, it means that you can access it even if it's in another package. Okay, you cannot access it from, you know, here m.dat, but you can access it from the class that inherits, that extends the class that set one of the property or one of the method to protected. If you set this to private, you will not be able to access it anywhere, right? You will not be access it here in the skeleton, but you will be able to access it in the class that the property was created in. And well, that's how it should be done. But you should create always at least protected get, for example, hit points, right? Something like that, and then return hit points. And this allows you, of course, it returns double, to at least, you know, do something like this, that, and you can get hit points, right? You should create also the setter. So you could do something like this, then set hit points, and you could set it from another package, but there could be some special conditions in it, right? You could make special conditions to check if everything is okay, right? If it's really good idea to allow this guy to change something like that. So set hit points equals to the hit points that will be sent here, so double hit points, and now hit points, these hit points that are sent here. Oh, I'm returning something. I don't need to return anything in the setter. This, that, set hit points, and I can set hit points now, but only through using a method, right? And I can use this method because it's protected. But the cool thing now is that when I do something like m.dat, as you can see, I cannot set it from here, right? From the class called inheritance. I can do it through the class that knows something about monster, not through the class like that one that doesn't know anything about it. Okay, that's only the lesson. Thank you very much. Hello, today we are going to talk about abstract methods and abstract classes. But before we go into this topic, let's think a second, what does abstract word mean? In my humble opinion, it's like something that is very hard to determine, to evaluate, right? It's something very hard to imagine. And well, in our situation, something like that exists from the programs that we are creating, right? For example, this monster. Really, can we somehow describe the monster? Can we say how he looks, how he will animate and other things like that? It's really not possible to do something like that because we cannot imagine it, because only the skeleton, the zombie, okay, I can imagine it, spider, okay, but this one, no. And that's when you can say that this is abstract class. But from now on, you cannot create the instance of the monster class. So when you do something like that, equals new, and now monster, as you can see, it's not working, right? It's not gonna work. You cannot create now the object, okay? You can, as you can see, create the skeleton. So you can create the, you can declare the M object, the type is monster, and you can assign to it, for example, skeleton, but you cannot, reserve memory for just monster, right? And now you might be like, but really, do I need to care about something like that? Well, there are many advantages because of the abstract class. Because right now you can create something what is called abstract methods inside abstract class. So how do they look like? Well, you can type something like that. Abstract. Now the type that will be returned. And for example, you can create description of the monster. As you can see, the abstract method cannot have the body. And it's great. How to describe this monster? It's not possible, right? Okay, so let's just type here abstract, right? It's not possible to describe something that is abstract, right? So this is now abstract, but the cool thing is now that we have got here everywhere errors. Now I have to implement all abstract methods. When I click on it, as you can see, now it implemented it automatically. So it overrided it, right? The cool thing is that now this is required in the classes that will extend the monster. And that's awesome. Why it's so awesome? The thing like that. Why it's so cool? We'll talk about throw later. That's why I'm deleting it. Why it's something like that is so cool? Because look, there may be many times when you create a class and you might think this method is very important. It must be implemented in the classes that will extend my class, right? And because of something like that, abstract keyword, you can make sure that somebody will use it, right? Because you can forget about one of the methods, right? You could create here many methods and you are not required to override them, right? But because of the abstract keyword, everybody who extends it must do something like overriding. And you have probably noticed that it's still not gonna work. Why? Because Spider is in the inheritance package. And you have probably noticed that this is the default, there is a default modifier that is called package modifier. And well, we need to now say that it's protected, or we need to say that it's public, okay? Otherwise it will not work. So now we can implement it here. Okay, so like that. And we also need to change here the signature. So we need to add protected here, and we also need to do it here. Okay, you can change protected to public. Okay, you can change it to the new modifier, but this new modifier must be more accessible than the one that was set before. Okay, you cannot, do something like private now. It will not work, right? As you can see, it's not working. When you do public, it's gonna work, but it needs to give bigger access. Okay, so the abstract class allows you to do things like requirements for the classes that will extend the base class, the superclass, the parent class, right? And it still keeps the functionality of being able to send, for example, the children to the method, right? Like that. I can still send here skeleton, the zombie, the spider, and other things like that. Okay, that's all in the lesson. Thank you very much. Hello, today I will tell you about the keyword that is called instance of, but before we go into this keyword, I like to show it on the practical example. So we train a bit classes, okay? Let's imagine a situation that we want to create a person, a student, and for example, an employee, okay? So let's create a class that will represent a person. And well, the person has got always, for example, name and for example, the surname, right? That's something that the person always have. But well, when we create, for example, employee, he can have also something what is called salary, right? How much money he earns. And when we create a student, he can have whatever. Well, he doesn't have money. Well, of course, I'm joking. Well, whatever, you can create something here. I'm just showing it as an example. Now let's extend, well, not this guy, but this guy by the person and this guy by the person. And well, the first thing that you probably already have noticed is that creating person is just nonsense because we cannot describe him, right? So it's a good idea to say that this is abstract class, okay? Of course, I should create it in new class. It's better than, because it's easier to maintain code. But when I'm creating a course, when I'm creating a lesson like that, now it's just easier for us to keep everything in one file. So it's easier to see what are relations between all these classes, right? So this is the superclass, this is subclasses, right? That extends person. And now let's, for example, do something like, hey, I would like to have a description. So let's create the method that will get description of each guy, okay? And well, we cannot describe person, so it's a good idea to make it abstract. And because of it, we have to implement it in both places here. And we have to implement it here. Okay. So we implemented it here and here. And now we can, for example, send to the output information about the employee, right? I am employee, we would say. And for example, name. We can access here name because, well, as you can see, we are extending the class above, so we have access to all these things, right? I remind you. So let's do something like that. Name, surname, and we can of course do something with the salary, right? We have now access to additional property, which is salary. And well, the same thing goes for this guy, but he is student. And now let's, well, create for example, person. So person equals, and now we can do something like that, right? Because, well, this is abstract class, but this can still allow us to create, for example, employee, right? We can create student and assign it to the person, because this is a reference that is created by constructor of this class, starting from what this guy, right? And well, we should create a constructor here, so we can assign salary, name, surname, and so on. So public employee, and we need what? String name, string surname, and we also need salary. So string, it's not string, it's double, so salary. So this dot name equals name, and surname equals surname, and this dot salary equals salary. And now you have probably noticed that I am making a mistake if I copy this thing here and I do something like that. Where do we have a mistake here? The problem is that, well, it's not that I invoke here. The problem is that, let's have the override here. As you can see, there are no arrows. The problem is about development on your application. I am repeating code here and here, right? So it's a good idea to create a constructor here, right? The person constructor, and the person that will take what? That will take the string name and string surname, right? And you do assign to this name and this surname. And because of it, now we can what? We can do something like super and sender name and surname, right? We do not need to repeat some instructions. Okay, now it's 10 times better. And as you have probably noticed, when we now do something like that, employee, now I will say Arkadiusz Włodarczyk, and now let's say I would like to earn as much as this, is working, right? And you have probably noticed that it's gonna invoke this constructor, but it's invoking also constructor from the abstract class. Yes, it's gonna invoke it and it's gonna create instance of it, but you cannot directly do something now like that, new person. Okay, you cannot do something like that, but through the class that is gonna extend, you can do something like that easy. Okay, so now we have got a person, but hey, we will create person 1, person 2, person 3 for student, for another employee, and so on. No, it's bad idea. It's good idea to now do something like an array, right? An array of people. So let's do something like that. People, assign new person, and for example for people, right? And now you might be like, hey, but you use the new keyword here. Yes, I used it. So what? I am really reserving the space in memory, and this space in memory right now is for each element like that. Null, 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 right? The people of 0 is really null, of 1 null. So I didn't use the constructor directly, right? This one. I just reserved a variable that will later refer to some place, right? To the address. If you do not understand it, please go to the lesson about references versus variables. It's very, very important lesson. So right now we can do what? We can do something like people of 0 dot, and we can access name and surname, get description, everything, right? When we do something like that, it's not working because right now we didn't assign anything here. So people of 1 dot, and we can, for example, sorry, without that, do something like new not person, but new employee, or something like that, and we're gonna send here the name, the surname, and my big salary. Let's increase it even more. So yeah, now it's to the 0. Now it's working, right? And well, let's create another guy, and let's make it a student. Student doesn't have salary, and make it something different like that, so we can get access to description of both guys now, right? That. And as you can see, the cool thing is that we are using one name, and this is the polymorphism, right? We are using one name, we are using one name of method, and we get different results because we executed this method and then this method, and the magic happens behind the scene, and it works, right? It's very, very cool. So now I would like to show you the instance of keyword. What would happen if I wanted to show all people, but as you can see here, it's a good idea to use a loop. So when I use a loop, so let's make a loop that will stop execution after we go to all of the elements. So if I do something like people of I dot get description, you will notice that, well, I printed these two guys, but then I have got exception, an error. I have to fix it because, well, I'm trying to access here at the people of 0, people of 1, and then 2 and 3, and 2 and 3 is really what? Null, right? We inserted here employee and here student, so here is an address, and we can get the description from there. But from null, from nothing, it's not possible. So we can check if the guy we go through, the guy we check, is instance of the person class, okay? If yes, then we can show description. As you can see now, we don't have error. But when you do something like that, you will notice that it still executes after, there are nulls. If I do something like that, it will execute even more times. We can use, for example, something like that. Otherwise, break. So we do not lose time, right? That's why something like break is pretty awesome. Okay, so that's how instance of is working. It's checking if the thing here is an instance of the class here. Null is not instance of anything, right? So it was just false and this thing was invoked. But is employee instance of person? Yes. Why? Because when you are invoking this constructor here, you really are invoking also the constructor of the class that you are extending, right? So you are invoking the superclass constructor. So it means that you are really also instance of that class above you, right? So that's why this will return true. And that's how you can solve some problems like that. When you go through many objects, you can check if they are instance of some kind of class, right? You can also, what's very cool, do something like that. And then you will show now only employees. Wow. And now you're gonna show only students, right? Oh, the problem is that we had a break here. So now we're gonna show only students. So maybe here would be better to use the continue, right? We don't want to end, we want to continue. But well, there was nothing, no other instruction here. So it wouldn't give us any bonus, right? But isn't it cool? We can now if we had more classes, right? Imagine that it was, for example, here monster, here many type of monsters, right? You could just get from an array only monsters that are the type of like that. Pretty awesome. Okay, that's all in the lesson. Thank you very much. Hello, in the last lesson we learned about the instance of keyword, and you have probably noticed it's very cool because you can check exactly if that object here is an instance of object here. But there is a problem because we all the time invoke a method that is overridden from the abstract class, but this is no real life example. There will be many times when you have something like, for example, special method that will call, for example, work, and you know, here are gonna be some instructions that will, you know, make some work. Okay, we are just gonna send something to the output, and now you will notice that we cannot access this method. Why? Because you need to know that right now we are really having here a type of person, right? So we can access only things that are called like here. We could access the get description from here, but it only happened because the signature was here. Okay. So if I want to access somehow the class that is down, we need to do something what is called downcasting. Okay, we need to go down because this one is the highest in the hierarchy, right? And now we can do something like people. Oh, we can now do downcasting employee, and now we still not have access to it because we need to have a parenthesis at this and do something like that, and now we can access the work. As you can see, now we can see a message, I'm working, so it's working fine. And you know, but when we delete this condition, as you can see, once it worked, because well, here we have an employee, but then we have got a student. That's why it's very important to check condition like that. And you're probably like, how it happens that the compilator is not checking if there is an error? Because your compilator, when he sees something like that, he believes you that you know what you are doing. He believes you that, you know, you are probably using it on the right class, right? I don't know yet. Let's run this program. And this thing, the checking if the connection is good, if the binding is good, is called late binding, okay? And now, as you can see, when I check something, everything works fine, right? So it believes us, but well, it might make a problem if you do not understand how things like that work out, right? So you need to remember to make a condition to check if it's really employee, because if you check, for example, for student, well, it's gonna be wrong. If you check, for example, for person, it's still not gonna be wrong because person doesn't have this method, right? Only the employee. Okay. So this is downcasting, and if you do not like how it looks like, right, you could do something like, for example, you can write people of I, and you can downcast it. So you can use the, I want to downcast this to employee, right? And we can create temporary employee, and now we can, for example, as you can see, invoke the work method. That's all in the lesson. Thank you very much. Hello, today I will tell you about a class that is called object. Yes, that's true. There is a class that is called object. When you do something like that, you notice that you can do it. When I click on it with Control, I can navigate to this object and can read about methods inside of it. There is a class like that. So you can use everything from that class because you inherited everything from this class, right? There are methods from it. As you can see, I created a class called point. It's very simple. You just can get this point, create a point, right? And well, you do not need to especially extend by object because all possible classes in your applications, any of them and created by another people, the developers, all of them will inherit from object. So if you do something like point p new point, and now you, for example, create a point like that, and now when you do something like p dot, as you can see, you can access not only methods that we created, so that these two, but you can also access method like that, like that, like that, right? You have methods that you can access. So let's access one of them. So for example, p.getClass. What will be the result of it? As you can see, it's just the name of the class and the package, right? So you can get additional information about the point, for example. And there are other methods, like for example, equals, which is very important for checking if one object is equal to another object. Because you have to remember, I remind you, that if you create, for example, another object like that, and we, for example, make a comparison, like for example that, if p equals to p2, and then I will say they are equal. As you have noticed, they are not equal because here is 1 and 10, 5 and 10. But what if they are equal? They are still not equal. Why? Because I remind you that here and here I have got address, and here I have got different address. Because the truth is that the new keyword is reserving an address, and you keep reference to that address here, right? This is a reference variable. The type is reference type, right? And here also. So these two objects do not know about each other. So when I'm comparing like that, I'm comparing two different addresses. So it's very important that if you want to compare two objects, you should create a special method that is called equals. And you can override things from, for example, object, right? So you can do something like that, and now here you can return, for example, true. So it means that it will be always true, and now it's when you invoke equals, so when you do something like equals and you send the p2, it will be of course true. If you now return here false, it is gonna be false. Now you decide what's gonna be false or what's gonna be true. So I think in our situation that we will need to compare x and y. So let's make a comparison. So if this object, so that p here is this right now, that x equals to the object that is sent here, so the one that is sent here is this one, right? So if the O is, and now we have get the problem, hey, I don't have access to the x and y. Why? I hope that you watched the video about the downcasting, because when you create something like object and you now do something like that, you need to remember that you don't have access to the methods, to the properties of the child. You can refer to it, but you don't have access to things there. If you want to have access, then you have to make something what is called downcasting, right? You have to make sure that you can do it. So you can create, for example, point B, and now you can cast. So you can do something like that, point, and now like that. And now, as you can see, I can get access to get x and get y. I still cannot get access to this, but it's because it's private, okay? So you have to make what? You have to first do something like that. You have to take that O, you have to make downcasting, and you can, for example, send point, assign it to the variable. So then it's gonna be easier to use. So send point dot, and we compare the x, right? And if they are equal, I want to return true. We know that when you compare two values, it's gonna return true or false. So right now, only two of the values, first values, must be equal, and it's gonna be okay. The second is not gonna be checked. How to check two things at once? Well, you have to use a conjunction. So it's very important to know that there are another operators, right? It was very crucial to learn things like operators before going into object-oriented programming. So if you didn't do it, so go back. Otherwise, well, you can keep going. And now we can check using the conjunction, which checks in the same time two conditions. So we can check if in the same time this dot y equals to send point dot y, right? And now we are going to check both points. So both, both coordinates, sorry. And now they are equal, right? Isn't awesome? Now we have got a special method that can check if something is equal or not. And you know, it's very important to do something like that, because now you decide how a comparison is working, right? Because you know, when you create a person, you want to compare, for example, no, I know, their salary or maybe their name. It's up to you what is gonna make it true or not. But now it's also very important to, you know, make it bulletproof, because most time you're gonna do things like, for example, like that object and now points, and you're gonna create, for example, point, for example, 4 points, and now you will do something like points of 0 equals new point, and now, for example, a point, right? Now you would do something like that, and now 1 2 3, and for example values, let's change them a bit. Array required but not, oh sorry, of course here is should be array, and now it works fine, right? But if you are comparing something like that, let's make it a bit smaller. When you are comparing something like that, so if you do something like that, p of 0, and now is it equal to, for example, p of 1, let's check comparison. Okay, let's do something like that, and let's send to the output if it's true or not. As you can see, it's true, right? If I change something, it's of course false. But what if I send here, for example, something like that by mistake? Bam, it's wrong. So I should check if the object that is being sent here is not equal to true, right? If yes, then please return false. Now, object equals to null. Well, it's still not working, but it's because we have got here an exception, an array index available bound exception. We tried to access something that was not, you know, created, so we need to do something like that, and now, as you can see, it's false. And because p of 4, p of 5, p of 6 is null, right? If I did something like that, I was trying to access here something that doesn't exist at all. There is not even null, right? That's why we had a problem like that. So now it's false. So without this condition, we would have still a problem. Okay, so we solved one of the problems. But there can be other problems. Like, for example, let's imagine that we have got a point, 3-dimensional point, and we want to compare them, or somebody sent here an object that is not the same object, right? They are not the same classes. So we can check if this dot get class is not equal to object to get class. If they are not equal, we can return instantly false, right? And we can also speed up a bit. It's just additional thing you can do. For example, we can check if the object that we are trying to compare, so that one, has got the same address as the object that is being sent here, then return true at the start, right? So it means if you do something like that, we compare the same guy, it means it's true. So that's how you do things properly. Of course, you can add here now also an override notation, for example, so it knows that it's overwritten. And well, that's how you do it, right? Because of it, you can compare your own objects using special method to it. And you could create your own method, call it whatever you want. But the cool thing about this that everybody knows that equals is used for comparison, right? And later, if they want to compare two objects, they know that you have probably implemented something like that, okay? So it's almost like a convention. Okay, that's only the lesson. Thank you very much. Hello, in the last lesson we learned about the object class, and there is one more method that I would like to tell you about. This method is called toString. It is taking the name to the string. It means that, hey, when I do something like that, as you can see, we can see here a string, object class .point. So it's the name of the class and the package it's in, and some kind of something what is called hash code, okay? So something generated just for the purpose of this class. And well, we can see it's working, but it's not giving us good information. We can exactly create an information that will give us more information. So in order to do it, we just need to what? Again, override it. So we can do something like that. And we can give an add notation override, right? And now we need to return the string. So if we return here whatever, it will be always the result of something like that. P of 0, P of 1, P of 2, 3, right? But we can now do something here like that. Get x plus, for example, get y. Well, it's a good idea to add a space, for example, like that. Well, we could say that it's x, this is y, whatever. As you can see now, it's 4 and 55. So now it's very cool because when you want to, for example, using the loop, get through all the objects, right? You can send to the output the information, the description, like that. As you can see, it's now working, but of course here is a null, so we should check if p is instance, if p of I is instance of the point. And now it's gonna work fine, right? So it's very cool because you do not need to especially invoke a method that is gonna, say get x, get y. We didn't need to use the downcasting here also, right, in order to invoke the get x and get y, because this method exists everywhere, not only here. It exists in the object, it exists everywhere. So you can easily at least debug, for example, your code, give some information about your objects. That's all in that lesson. Thank you very much. Hello, today I will tell you about the final keyword. As the name suggests, final means last time that you do something with, for example, local variable. When you create a double pi and you assign to it 3.14, you will not be able to change this value later, okay? So this is how it works for the local variables, okay? You cannot change the value. So it is good idea to create it for example, constant values. But this is really rare situation. Let's find, for example, a situation that is more real life example. We have got here an abstract class person and a class called employee that extends that person. And employee has got something what is called date of employment, right? Yes, that's true. So let's create a date of employment. So this should be, I think, created using the date class. Let's import it. So I click the control plus space and imported it. And there is also another way of importing Control Shift plus I. And as you can see, then you can import all classes that were not imported. And now let's, for example, call it date of employment. And I think it should be final, because you can't change date of employment. If somebody was employed 3 years ago, that's the history and you cannot change it, right? As you can see, it's not working now, because when you are declaring something like that, like a property as a final, it means that you have to set it in the same line or in the constructor. Here it's okay, you can change it, for example here, right, to 3.14, but you cannot change it later. Okay, so once you can do it, because well, at the beginning it was not set, but later, hey, you have to remember about it. You can do something like that. You can use the constructor, and I think this is more real life example when you do something like that. Okay, new date. Why I think it's better idea? Because, well, when you run your program, you don't have any objects, right? And all these objects will be created really using, for example, database. You will just create many objects and send their data, from example, from database, right? And that's how it should be done. So you should have also something like that, right? A constructor like that, and do something like that. So if we create an employee, you will notice that we cannot change now a date of employment. As you can see like that, it's just not working, right? You can send it to the output. But you cannot change it. Okay, as you can see, it's very cool because you can see what's inside a date. Okay, so that's how it works on properties, but how does it work on classes? Well, the first thing, when we, for example, delete an abstract here and set here final, as you can see, you cannot just extend it. Okay, so final class is a class that you cannot extend, and you will probably never use it because it's a very rare situation. You want to make a class final if you really do not want somebody extended, and the situation like that can happen, for example, when you have some very secure things inside, right? Like, for example, authentication, passwords, and other things like that, and you might be worried that somebody extend your class and do something wrong with it, something that will be horrible. Okay, and it's very, very, very rare. And it's good to know that you cannot create in the same time final and abstract class, because abstract class means it should be later extended, but so this is just stupid to have them next to each other. Okay, so that's how abstract class work, final class work. And now let's see how the final method works. So if you create, for example, another class, programmer, and you extend the employee, so when you create, for example, a method here that will be called get date of employment, and you return the state of employment, right? And you, for example, do something like that here, you can override it now. But when you set it to final, you cannot override it anymore, right? It's just not gonna compile. And the same situation like for the class. If you think that this method has got some very secure things that you don't want to be used by other classes, then you can use the final keyword. Okay, some people say there is a performance increment, maybe in some Java virtual machines, but you shouldn't even care about things like that, because if it even is speed ups, it's so small amount that you shouldn't be even worrying about it. So use it only if you think that you do not want somebody to do something like overriding your method in the class that extends something. Okay, that's the only situation where you should use the final keyword for method. So most time you will use it only for properties. That's all in the lesson. Thank you very much. Hello my friend, today I will tell you what are interfaces. Interface is very similar to class, but it has got a bit different properties and methods inside of it. any method that you create inside an interface is gonna be public and abstract, and any property created inside a interface is gonna be public, final, and static. So when you create an interface and you do it that way, you type interface, then the name of interface. Anything you create here will behave like I've just said, right? So if you create, for example, double pi and you assign to it 3.14, this thing is really public, final, and static. So you cannot change it, right? That means final. Static, it means that you can get to it using something like that, right? Using the name of interface. And public, it means that it will be even accessible in other packages, right? So name of interface pi, we can get to it and send it to the output, right? So this is default modifiers that you do not need to add here, right? You can do it, but you cannot change it, right? So it's just useless. You just need to know that they are like that. You should know that you cannot type here public interface because this interface was created inside class that was called main in the main.java. If you want to have interface that is public, you have to create a special file called name of interface.java, okay? So you can have only one public class or one public interface in one file. So that's how the property work. And now let's create, for example, a method like that. And this method is by default public and abstract. So this sample method has to be overridden in the classes that will implement interface. What does implement word means? It means that you want to take after all behaviors from the interface. It is very similar to extending, to inheriting, but implementing this word means that you want to take behaviors, okay? So how something behaves. Because the purpose of creating interfaces is normally because you want to have some kind of requirements of behavior for other classes. For example, I have got right now a monitor in front of me. You have got it also. And look at this. You can turn off this monitor. You can also turn on it. You can change the brightness and other things like that. And it's not by mistake called interface, right? This is something between your face and it's interface, right? Something between your face and this monitor, right? This thing. And this thing is really a behavior, right? The implementation of this behavior is gonna be different for each monitor, right? Because, you know, there can be different ways of doing things like that. We don't know exactly, for example, when you look at the monitor that is called BenQ or LG, how do they do it, you know, inside of that monitor, that you turn it off or on. Probably it's almost the same because you just cut that circuit, but you know, we don't know where and exactly it happens, other things like that. So, but the behavior is almost always the same, right? So you can, for example, create an interface that will just make every monitor that implements an interface like that to do things that are required. Because as you can see, we are not implementing, we are not creating the behavior inside here, right? Because we cannot. This is an abstract method. So if you create a class, for example, employee, you can now implement, so here is a new keyword, for example, name of interface. And this means that I have to implement all abstract methods. As you can see, this was the abstract method by default, right? We didn't need to add these modifiers. So that's how it works. There are, of course, many more better examples. I will show you one very cool about sorting objects in the next lesson, but right now I'd like to show you also the difference between interface and an abstract. Because you might be now like, hey, you know, in abstract class, I also could create a public abstract method and public final static things and other like properties and other things like that, right? So why even bother creating interfaces? Because you can implement more than one behavior, more than one interface. So you can create another interface, some other interface, right? And you can just do something like that, right? Comma, and it will work. And it's pretty, you know, logical, because you can have to, you sometimes want to have many behaviors from many interfaces, right? You can, interfaces can group these behaviors in one name, right? So you can implement more than one, but you cannot extend. So if you create, for example, class programmer, you can extend, for example, employee, right? But if you create another class, for example, A, you cannot do something like that. You cannot extend more than one class, okay? So that's also a big difference. And in interface, every method is public and abstract, and every property is public, final, or static. In abstract class, you can implement something, right? Here, you cannot do it at all. And well, here is one similarity. So when you create, for example, a variable like that, you cannot create, of course, instance of it, right? As you can see, it tried to do something like that. This thing is called anonymous class, which means that you are creating it inline without the name, anonymous one, and it implemented this method. For right now, this is useless. But as you can see, you cannot create an instance of this interface. So why even bother creating a type of variable like that? Because you can refer the same way like you would, for example, do in when you did something like that, object B, right? You can do something like new employee, and here you could do new employee. So the superclass, the one that is in the highest place in hierarchy, can refer to the one that extends it. And also when you implement, like here, when we implement the name of interface, we can do the same thing for interfaces. And then, of course, you cannot access every possible method. As you can see, we can access sample, that's only because sample is here and it's here in the same time. But if you create another method, so for example, get salary, and then, as you can see, you cannot access it, right? You have to first what? You have to first do something what is called downcasting. So you have to do something like that. And then, yes, you can get salary. Of course, we should create here, for example, a salary. Like that, right? return. And well, we should create also a public constructor employee double salary, this dot salary equals salary. Okay, and now of course we need to use not the default constructor, so we need to create, for example, salary for this guy. And as you can see, it's not working. I don't know why exactly. Oh, sorry, here. When we extend employee, we have to create also a constructor for programmer. So public, for example, programmer, and we have to do something like double salary, and we need to send it to the constructor up top, for example, or we need to implement it on our own, so like that. Okay, so as you can see, the behavior here is very similar, like for classes, right? Like for abstract class, but there are many differences between abstract class and interface. Like for example, that interface every property is like that, and every method is like that, and you can implement more than one behavior. Okay, and interfaces, remember, when you want to create interface, you most time want to create it so it's like a requirement for behavior for some class. Okay, that's on the lesson. Thank you very much. Hello, in the last lesson I told you about interfaces. In this lesson I will tell you how to use interfaces on practical example. So we created in the last lesson class employee and class programmer, and now imagine a situation when you want to, for example, create a programmer. Okay, for example, well, many programmers, so like that, and now we're gonna create a few of them. So like that, new programmer, and we'll send a salary there, and something like that. For example, like that. And now I would like to sort it. How to sort programmers by salary? You could create your own method for sorting, but really creating something like that is like inventing again a wheel. When you have got really methods that are gonna do it for you. You have got something what is called an arrays class. When I use the Ctrl+Shift+I shortcut, as you can see, we imported it. And now you have got access here to many methods. You have got here a method that is called sort, and it is overloaded many times because you can send there different values. As you can see, you can send there characters, doubles, floats, and well, for the integer, for shorts, and other types that you can see here, there are already implemented interfaces. Well, there is already implemented one interface that is called comparable, that allows this method to sort things, because sort method is just not gonna work without implementation of comparable. When I send here now p, as you can see, our program is not gonna work. It's because, as you can see, this thing really needs an implementation of this comparable thing, right? Comparable interface. So we have to implement it first. But before we go into it, let's see if the thing that I say is true. So when I do something like, for example, that new integer, 3 integers, and I do something like for example, like that. And now when I do something like that, right? What will happen if I do it like that? Oh, this we have to take under the comment. As you can see, oh sorry, 1, 2. The first one is minus 51 because this is sorted ascending way, so it's going from down to the highest value. So as you can see, minus 55, then it's 5, then it's 15. So this method can be used to sort integers because there was already implemented comparable. So this is like a requirement for sorting, right? As I said, interfaces are in requirement. So if you implement, for example, now comparable, okay, as you can see, it says instantly that we need to, well, implement, sorry, comparable. We need to implement all abstract methods, and this method here is called compare_to. We can go to comparable interface, and as you can see, it just looks like that, right? There is an interface with just one method. So now we have to implement it the way it should be implemented, the way the behavior should work. When we go to the documentation, you can go there by doing something like that, right click and now then click Shift Alt plus F1 or click on Show Java Documentation. You will get to this page, okay? And when you go down, as you can see here, we have got description of method compare_to and how you should implement it, so the comparison will be good for your object. Because, you know, right now we can, for example, sort these things ascending way by salary, but there can be many different situations. For example, what if you wanted to sort by not salary, but for example by the name and surname, other things like that, right? It really depends on situation. So that's why we are here for deciding how to implement this behavior exactly for our employee, right? The behavior is to compare for this method, the sort method. This is the requirement that this method requires for comparison, right? I hope you get it now. So we have to now implement it, and we can, for example, return here 0. At least now it's working, right? We could, oh, I need something like that. As you can see right now, at least it's not, it invoked this, so we don't have got an error. So we can, for example, do something like p of 0. And as you can see, get salary. We can get the salary. It's okay, but well, it's not sorting because we return here 0, which means that everything is equal for the sort method. What do I mean? You have to implement behavior the way it was intended to work. As you can see, it says compares this object with the specified object for order, returns a negative integer 0 or a positive integer as this object is less than, equal to, or greater than the specified object, the one that will be compared. So we can, for example, do something like that. P of 0 dot compare to, and we can send there, for example, P of 1. So we send, as you can see, using this object, we'll use the method to send there P of 1. We can send it because here is an object, right? We can access object, well, our object can refer to any possible class, because this is a superclass for every possible class. But in order to get to values, to methods, because right now, as you can see, we don't have access to methods like, for example, salary, other things like that, we have to first do downcasting, right? So we have to do something like that. And we can, for example, do like that. So now, as you can see, we have access to this thing. Okay, that's great. So now we can type something like temporary and we can get to salary. And this is pretty cool because we can use that method or this because we are inside the class, right? That is employee, okay? That's why. And now we can compare this object. So if this dot salary is lower than the one that was sent here, I should return what? And then we go to the place where it will be described how this behavior should work. We should return negative integer if this object is less than the one that is being compared. So we should return -1. Otherwise, if it's bigger, then we're gonna return what? Then we're gonna return positive if it's greater. So we can return positive number. If it's equal, it's just gonna be 0. You have to remember that returning means that this is the last instruction invoked here. So the truth is that we don't need to use else if, and it can look like that, right? If this happens, then it's gonna return. If this happens, it's gonna return to the place where it was invoked, right? Otherwise, it's gonna be this. And now, as you can see, we have got here -1 because, let's comment this because we sorted it first, right? It's 1 because 10,000 is bigger than 2,000. And this method, the result of this method, is being used in this method somewhere. Somebody implemented the result of this method. And that's why this requirement is so cool, right? Because it is now required for comparison for example, things like that. And now, when you do things like that, like sorting, as you can see, it's -1 because we change all the positions of things. Let's send it to the output. So let's, for example, programmer, and for example, do something like programmer that gets salary. So before comparison, it looks like that, the way we created it. But after comparisons, after sorting using these comparisons, using our method, it looks like that, 2,000, 5,000, 10,000. So we sorted it ascending way. If you want to change this behavior, you send another argument here from using the collections class, and you use here the static, as you can see, static method, reverse order, and now it's gonna sort it this descending way. So from the top from the highest salary to the smallest salary, right? Like that. So that's how you use interfaces created by other people. As you can see, it is cool because if not this implementation, we wouldn't know how we should implement the behavior needed for this method, for example, right? Okay. Well, that's all in the lesson. Thank you very much. Hello, today I will tell you about nested classes, and I will also tell you what's the difference between static class and inner class. In the next lesson, we'll try to make something that would represent the usage of nested classes. In this lesson, we'll focus on, things that are a bit boring, but you have to understand first before going to something practical. Okay, so let's create a class. Let's call it, for example, A. And let's create second class that we'll call B. And as you can see, this class is inside this class. That's why it only exists only within this class. What does it mean? It means that if you create, for example, a constructor that we'll call A, and we'll do something like that, I am from outer class A, and we'll create a constructor here, I am from inner class B. When you do something like A temporary new A, you will notice that only the outer constructor was invoked. You have to now invoke manually this constructor in order to create this class, right? Okay. So this class is called inner class because it's inside, it's internal class of A. And now we should think about the level of access between both these classes. If you create a private variable, for example, temporary, here, let's see if you can access it from example, this constructor. As you can see, it's possible. So inner class, because it exists within class A, can have access to the things, to the properties, to the methods. If you created here a method, you would have access to it from inside this class, from the inner one. However, if you create here private, for example, variable that we'll call double sample, you will notice that we do not have access to the properties of inner class, even if we make them public, of course, right? It doesn't matter. We do not have access to them. How to remember something like that? You know, we are humans and we cannot access, I don't know, my heart, for example, right? But heart is working and somehow accessing, you know, blood, other things from outside, right? Maybe this is stupid how I try to relate this, how to connect this, you know, and remember it. But something like that, when you think stupid way, you start to remember things, right? Okay, so you cannot access something that doesn't exist yet, right? That's also the reason. When you created this, you can see here, I am from outer class. You didn't create the inner class guy. You didn't construct things here, right? You have to first construct everything inside. So in order to construct it, you can do it, for example, from another class. Or you could, you know, do something like that, B new B, right? And then you have access to the sample, okay? Then it's possible. That's okay. So now let's see how to create this class, not from here, because from here it was pretty easy, as you can see, how to create it, for example, here. Class B is called nested class, inner class, and it means that you cannot, you know, create it without first creating this guy. We've already constructed the outer class using the constructor here. Now we need to use this object in order to create the inner class, and that's the syntax. And now we have to save it somewhere. We have to create a reference variable. The reference variable should look like that. So as you can see, whatever, this variable here have access now to, it has got the reference now to this object, right? That created with this constructor here. And this is the syntax in order that you use in order to somehow get, well, we could do something like outer, so it will be easier to remember, right? Like that. Okay. And now let's talk about static class. Static class, if you, for example, did something like that, as you can see, we have got a few errors now. Because static class is right now only nested class. It means that it is inside, it's nested inside the class A, but it's not inner class. It doesn't exist within the class A. Because it can exist even if you do not create an object of class A, okay? That's the main difference. So as you can see, we have got here an error because right now we can do it a bit different way. We can go into A, then we can go into B, and we can invoke the constructor now. So we can do something like that. And we can save it, for example, here. Okay? So now you can access it here because, you know, the static class is a static thing. It can exist even though we didn't create the outer class object, okay? That's the main difference. And it also means that you cannot access now from here, as you can see, variables outside, right? In the outer class. Why? Because how can you be sure that something like class A object was created, right? This thing can exist without this object class A. So, hey, you do not have access to it because it might not exist. So that's why you cannot access it now. And it also means that you can finally create here, for example, static variables. So you can create static double pi equals 3.40. If we did not have it, as you can see, you cannot create static variables because static variables should exist always, even though you wouldn't have created the class A object. But, you know, class A is outer class right now. This is inner class, and you have to create the outer class object in order to create the inner class object now, right? Without the static modifier here, right? With static modifier you do not have to, okay? So that's the difference. So let's create, for example, another class, static class C. Okay. So it means that you can have static double pi, for example, inside, right? So that's the difference. And well, here we are creating things like that, but C can be created like that, right? C, so sorry, A, and then let's go to C because it's outer class, and then we go to the class that is nested. And this is called nested class and inner class. This class is called nested class. It cannot be called inner class, because how can you call something like that an inner class when it doesn't need to when it doesn't need, in order to exist, the outer class. Okay, it is just nested, it's just inside of it. Okay, that's only that lesson. Next lesson I will show you some practical example using this nested class, because right now you might be like, whoa, really, so much pain for nothing. That's all in the lesson. Thank you very much. Hello, today I will show you a bit more practical example of inner classes. Look, we have got here a bank account, and that has got an account balance. And every bank account has got something what is called interest, which calculates how much you're gonna gain money if you have got your money on that account for a bit longer time, right? So this is the interest rate. And you might be like, okay, so let's create a class that will represent interest, and let's put there, for example, thing that will calculate for this bank account the account balance and other things like that. Well, we could put it in another file, but it would be hard to connect these two guys, right? And it would just take time, and it would just make no sense, because creating the interest class with a bank account class is not a good idea, right? So if there is a situation like that you think that it's not a good idea to create the class outside of the class you are creating, you think that you're not gonna extend it as and so on, then it's probably a good idea to create an inner class. Okay, so the inner class is used for grouping, right? For making things that are related to each other easier to maintain. So let's create inside of it a class that we will call interest. Okay, and we will create the private variable that will be called interest rate. So let's create, constructors and other things like that. I'd like to show you that if you use Ctrl plus space, you can generate, for example, the constructor for the properties that been already created. As you can see, it's pretty fast now. I can of course also create the getter, so it's also very cool. And the same for here, so we can create this and this. I think it really improves the speed of creation of class for the simple things that happens a lot of time. So first you need to create properties, and then you can create very fast constructors or getters using something like that. Okay, and so we have got now a class interest that allows you to get the interest rate, and here we have got the bank account that can be created. Let's create a bank account. So bank account, new bank account, and we can send the account balance at the start, for example, for $1,000. And now we can get to the bank account and, for example, get account balance to see how much money we have got there. So as you can see, it's working. And now imagine that we want to calculate the interest rate. Okay, so let's create a method that will be invoked by somebody else each month, for example. So let's create a method that will be public void and we'll call it calculate interest. And here we need somebody to send the interest rate, right? So double interest rate. So we want to calculate an interest rate here. So we have to first create this instance of class for interest, right? So like that. So we can access interest rate from inside, right? What did I do wrong? Oh, of course, we have to send the interest rate. Sorry. Because we don't have the default constructor created, right? So we have to use the one that we created. Okay, so now we can go get interest rate from there, or we can calculate the interest rate inside this method, right? So we can, for example, create a method public change account balance, right? Something like that. Void. And we'll change the account balance using the interest rate that's been sent here. So double interest rate. So we can now get that bank account there, because this class is really a class that can access outer properties, right? So we can do something like where is this? Oh, account balance. So we can get to the account balance and add to it the interest. So maybe let's first count it. So double interest equals, and in order to count it we have to take the account balance and multiply it by the interest rate, and we have to now divide it by 100, right? Because we need percentages. So we have to divide, for example, I know 5 sent here by 100, and then we have got the percentage, right? Because percentage is really a number divided by 100. Percent means dividing something by 100. So here we have interest that we can now add to the account balance. Okay, so we can now change the account balance using this. So now we can do interest dot change account balance and send there the interest rate. Oh, sorry. Well, we don't need to use this here, right? Because you can use the fact that we created this private variable here. So why send 2 times the same thing? That would be just horrible. Okay, so change account balance. And now, well, it should work, right? It compiles. So now we can do bank account dot calculate interest, and we can send, for example, 5 percentages, and as you can see, it's 1050. 5% multiplied by 1000 is 50. 50 plus 1000 is 150, and you can just repeat now this method, right? So you can, for example, invoke it each month or something like that, and then you can see how the interest rate affects the account balance. So you might be like, maybe it's looking worse than normally, right? Because when you are new to syntax like that, it might be hard to understand that you want to group things so badly. From the object-oriented perspective, this is the way you should do it only if you think that this class really is only related to this class and it has totally no sense outside of the scope, right? So this is really very rare situation where you want to do something like that most time. And so do not worry if you do not understand things that are happening here. It's good to know also that you can create something what is called local inner classes. You can just cut this and you can paste it now, for example, inside here, like that. Okay. And now, as you can see, this class is inside this method. That's cool, right? So we have got the class inside the method, and this class will be created just for the sake of this method. We send here the interest rate. As you can see, this interest rate is also here, but this parameter is only available here between this and this place for things that are not inside class, right? So this parameter is a local variable for things here. But you can add something what is called a final keyword here. And since now you do not need to do things like sending using the interest rate like that, because interest rate with the final keyword here is available everywhere inside the class also. Okay, so that's the difference. Now I know that you might be very confused right now, because most time you do not do things like that, and I think that this thing doesn't look good, okay, for more complicated classes. For simple class where you have to do something very fast, it might be okay, and then you will use most times something what is called anonymous class that we will talk about in the next lesson. Okay, so this I haven't really written a code like that, because well, it's just good to know the syntax, so you know what's going on if you someday have a chance to see a code like that. This way that I created it before, yeah, it's gonna happen that you see a code like that, the inner class of the class, but this looking like that, I think it makes more it makes it harder to understand and harder to read, right? So I think you should avoid it. I just showed you it so you know the syntax and the possibility of doing things like that. Okay, that's only the lesson. Thank you very much. Hello, today I will tell you what are anonymous classes and I will show you the purpose of using them. Anonymous class is, as the name suggests, a class without the name. So when you look at something like that, at first you are like, really? Why would I need a class without name? When the class purpose is to describe properties, methods, and other things like that, right? So maybe somebody can reuse that class, right? But there is a purpose for anonymous classes. For example, let's imagine a situation like that. Let's create an interface that will, for example, be something like action after click. Okay, and here we will want somebody to implement action. And now let's create a class that we'll call button. And now I would like to, implement action after click. And then implement all abstract methods. And now we can, invoke this action. So action from button 1. And now if you want to create another button, you have to create another class. So this is not good, right? Well, you could probably do it a bit different way. For example, you could extend it, right? So button 2 extends button, and then you would need to override this for this guy, right? Again, in order to make the action different from this button, right? And situation like that you have more than one button in the application, because when these all things are buttons really, right? It's very often. And you would need to create a class for each possible button just for the action. When you look at a situation like that, you are like, wow, really? That's why we have got a better solution. A solution with the anonymous classes. Let's create, for example, action after click. And now, as you can see, normally you cannot do something like action after click. Oh, it created it for us, something like that, right? Because you cannot create an instance of interface. But as you can see, when I did something like that and I used the Ctrl plus space, it generated for us here the local, the anonymous class without the name. As you can see here, we have got here only curly braces. So we have got here inside of it just the action, just the thing that should be done after clicking. So the behavior, right? What should happen? We can now store it here and we can send it later to, for example, the class button. So now we can do it rather a bit different way. We do not need to implement it here. We just need to create a class button and, for example, create a method add action, and here we will take action after click. Okay, and we can invoke here the action that will be placed here. I am action from anonymous class. Because as you can see now, using this, we can easily, as you can see, access the action, right? So we can access this method here. It's because, as I said, interfaces that are implemented by a class can refer to that class, right? And here we are not referring to the interface, right? We are referring to that anonymous class that we don't have name to. You can of course here create properties, you can create here another methods, right? This is not a problem, you can create it here whatever you want, but this is not the purpose of this anonymous class, okay? The purpose of this anonymous class is just to do something very fast, just to implement the action. And now the cool thing is that I can create a button, right? And you can create here some properties like width and so on, the height and whatever, and I can implement the action just sending this, right? So this is the behavior that should be done after clicking it. As you can see, I'm action from anonymous class, so this is the action that was invoked here. Of course, this method here, right, should be invoked after somebody click on something, but we do not know how to implement events or something like that right now. But that's how that's useful now, because now you can create another button, right? P2. You do not need to extend every time the button for another button. You just create a new variable for another button with new properties, for example, height, width, and so on. And then you just, add action, and you want new action for this guy. So you don't even need to do it that way, so that you need to store that action. You can just, do something like that. Hey, I want this action looking like that. And let's send here I am action from anonymous class for button P2, right? And as you can see, it's working, right? So you are just adding action to be done for this button when somebody click on it. So but of course this method should be invoked after clicking. So as you can see, it's very useful, right? You are not making somebody create every time new class just for the behavior. So this is very powerful thing, and that's how it's done. I created here in the comment in Java Swing. When you want to implement an action, you have got something what is called a J button. This is a class that has got things like that, right? The button, and it has got a method like that, add action listener, and you are sending there anonymous class that implements action listener, right? Which says that what behavior should be implemented, what you should do when the action is performed. And for the button, the action performed is really just click, right? So when somebody click, just perform things that are done here. So we did the same thing here, but well, we created this code on our own. So that's how you use anonymous classes, and this is the practical usage for it. That's all in that lesson. Thank you very much. Hello, today I will tell you about the aggregation. Aggregation means connection, means addition, okay? This is the meaning of this word. And imagine a situation like that. We have got an employee, and now this employee has got a name, right? But this employee has got also something what is called an address. And now let's imagine an address, right? So for example, USA, and then the name of the street, and then for example the number, and other things like that. As you can see, here are a few properties that I think should not be defined in one string, because later you wouldn't be able to extract it, right? You wouldn't be able to query it to make some kind of operations on them, because it would be hard to, for example, change the order, because you wouldn't know which one is which and in what order, and other things like that. So this is the place for creating a new class, an aggregation, an addition class, a connection, okay? So we are going to create an address class, okay? So we are going to implement now create class address, as you can see, right, like that. So we are creating a class address, and now we are going to have the street name, right? We're gonna create, for example, street number, and string, for example, country, and so on, right? Now control plus space, let's generate the constructor for it, and let's generate the constructor for this guy. And now we can create an employee, and as you can see, when I use the control plus space, I have got here some kind of hints. Now the street name, blah blah blah, number, and country, for example, Poland. Okay, like that. I created it as a string. Okay, that's wrong. So let's change it to int. Well, you could keep it string, because some, not every street has got a number. Sometimes you can have, for example, a whatever, but it's just doesn't matter for this lesson. So as you can see, we created the employee. Now let's create a toString method, and now let's just return, for example, this name plus then the space plus we can get access now to the address because we sent the constructor of address here, right here, and we created it and then we assigned it to here, so we can easily get the country and so on, right? So we can now just do something like that, and as you can see, we have got now that Arek is from Poland, and we can, you know, send out to the output the street and other things like that. So this is called aggregation. So aggregation means that you are creating, connecting an addition object inside and another class, okay? And there is also something what is called composition. Composition means this is like a specific aggregation that also means that this class is just nothing without this, okay? This object here is nothing without this class. What do I mean? For example, when you create a job, right? So we need to create control plus space. Let's maybe use this, create a class in the package aggregation. So as you can see, really job doesn't exist without the employee, right? There can be many different types of jobs, right? So it's a good idea to have it in another class, so it is not the inner class, right? But this is not something that can exist without the employee. Address is something that can exist without the employee because, you know, address can be assigned to, for example, the address of where the CAD is, right? The address to where to deliver something, right? So this is called aggregation, and this is called composition. So this is just, you know, how you call things, so it really doesn't matter so much. And well, another example of composition could be, for example, the engine in the car, right? Engine is something that doesn't exist, it doesn't work without the car, right? But that there can be different types of engines, right? Okay, so this is how you can create an object inside another class and use it, like for example here I have shown you. That's all in that lesson. Thank you very much. Hello my friend, today I will tell you about something what is called exceptions. I will tell you how to catch exceptions, what are exceptions, and the most important thing, why do we even need something like that when they really do something very similar what is done by using the conditional statement if. But the truth is that it has got very powerful thing that most people do not know about. So let's start from very simple exception like that. We cannot divide by 0. What will happen? As you can see, our program is throwing an exception. That is called like that. And well, you can go to that file and see what it is. But, you know, we do not need to care about what it is exactly. We just know that something wrong happened. Our program is not working, right? This will not run. As you can see, nothing after this line is running. And you have to remember that if exception happen, you should catch it, okay? Because the exceptions are thrown, so you just catch it. And in order to do it, you're gonna use the syntax looking like that. You're gonna type try, which means that you want to try to do something that is between these curly braces. Instructions to try. And later, you're gonna catch every possible exception, like for example, arithmetic exception or, you know, exception, whatever, that will happen. And here are instructions that you do in order to make your program work. You know, these are the instructions just that you want to invoke if the exceptions happen, okay? And well, how would it look in our situation? We should do something like that. Let's try the code here and then catch arithmetic exception like that. As you can see, now our program is running. This will not run. As you can see, this is gonna run, right? So this is a place where you can catch exception and send to the output something informing that something happened, or you can, you know, revert some instructions. You can do whatever you want here depending on what happened, right? Right now somebody divided by 0, so we can send to the output something like exception dot, and then for example get message. As you can see, the exception, that EX here, is really an object, right? Arithmetic exception is, when we go to it, is just a normal class that extends runtime exception, and when you go there you're gonna see that it just gonna do something like that, right? You can just go ahead, but you know, this is just a simple class that is gonna be constructed when the exception happens, okay? So when something like that happens, 5 divided by 0, and as you can see, this exception happened. So here you can type whatever you want, okay? This is just a name of a variable. It doesn't matter what you write here. And there are a few more things you should know. The first thing is that nothing here will execute if exception was thrown. As you can see, we just can see only this thing here. If exception do not happen, as you can see, we have got the result from here, and this instruction is gonna happen, okay? So it's really important to sometimes invoke instructions even though the exception happened, but you also want to execute these commands when, for example, the exception wasn't thrown, right? So this is this thing you can do in the finale block. So this line will execute always. So as you can see, we have got now here exception, and this line was executed, and as you can see, this line was executed still, even if we did not have exception, okay? So this instruction will gonna be executed if the exception happened, but this instruction will not be executed then. So this is this is solving the problem if you want to invoke something that has to happen, has to be invoked, executed anyway, okay? And you should also know that you can catch more than one exception. So for example, here is catch arithmetic exception. What if there was more than one? Let's create our own exception, because as you can see, arithmetic exception is extending something, right? So we can create class our exception. Of course, this should be self-descriptive exception. We're just making some very weird names now here. We're gonna extend the exception, and now I'm gonna use Ctrl+Space and generate the constructor for our class, and as you can see, it's gonna invoke the constructor of the superclass of the exception, and this will allow us to give our error a name. So now you can, for example, do something like that. If a equals to, for example, 0, you are naughty. a cannot be 0. Of course, this is very stupid, but I'm just showing you how does it work, okay? And you can, for example, throw here an exception. In order to throw exception, you can do something like that. New, then, before it, throw, new, and we're gonna invoke the constructor of our exception, right? Like that. And as you can see here, it says that, hey, I didn't catch it, because you have to catch every possible exception. So you can now use this here and add catch clause, right? Like he did. So he created it for us. And well, we can do the same thing like we did here, right? And as you can see, we have to remember that this exception was thrown first, so this one couldn't be invoked at all. So if we comment it, as you can see, you are naughty, a cannot be 0. So that's how it works. So that's how you can throw your own exception. Sometimes you do not want to, create for each possible exception if they are very similar to each other, new names, and for each catch, if you just send a message, you don't do anything specific, you can then catch every possible exception using the exception class, right? Because exception is the superclass, so superclass can refer to the subclasses, right? Without any problems. We can just do something like that, and whatever will happen, this or this, it will work. Okay, so these examples were very weird. They didn't show us the purpose of it, because when you are looking at it right now, you might be like, really, we could do almost every time just if something then something, and this is just giving you headache, right? And I at the start really thought about things like exceptions the same, but there is really very good reason why they were created. The first thing is that you can execute something in, for example, finale block when, for example, somebody closed the program. You can, something suddenly happened and he closed the program. You can save, for example, here in the finale block, because finale block will always be executed, right? But this is very rare situation. There is better thing that you can do using the exception. As you can see, I have got here a class bottle, and we created it in one of our lessons. And this bottle program could get water from water amount, fill the water, pour the water, transfer the water. And you have probably noticed that when we, did something like that, bottle, be new bottle with, for example, 5 liters, and B2, and we will do something like B, transfer water 10 liters to, for example, B2, which is too much because we have got only 5 liters here. We have got here information there is not enough water to transfer. The problem is that this solution is very wrong. What if I wanted to not send a message there is not enough water to transfer? I would like to, for example, do something like transfer all possible water, so 5 liters, and that's all. I wouldn't like to inform anybody about it, right? This is my solution. I cannot do it now because somebody already gave the solution, right? I cannot change it now. If I want to change it, I have to create my own bottle class just for this. And this is just bad. And here is the time when you want to use exceptions. Look, instead of returning false or true, I will return void, and instead of doing something like that, I will just throw new exception and I will just say there is not enough water, right? There is not enough water. Okay. And as you can see, we have got now here information that if you had thrown something, you have to catch it. So we would have to catch it here, but the truth is that we don't want to catch it here. So we can inform it. We can do something like throws exception. We can inform that this exception will be later taken care of. Here we had the problem is that I didn't say throw also. As you can see, it's still not gonna work, right? Add throws clause exception. So when you throw something, you have to catch it, but you can also say, hey, somebody else is gonna do it. And because transfer water is invoking the pour water method, and it's returning void now, so we cannot change here if something is true or not. So we're just gonna do it now this way. It means that we have to catch it here. But the truth is that we still do not want to catch it here. We want to allow how to do it right here, right, in the main function. So we're just gonna throw it again. And now, as you can see, we can here decide what we want to do with it. We can also again throw it again. So we can, I don't want to do anything with this exception. Let's just throw it away. There can be reasons like that. Maybe you just don't want to do anything with this condition, right? With this exception like that. But if you want to, you can now just do something like try catch, and now I can catch the exception. Oh, of course, I can just click Ctrl plus. I can just use this here and do something like that because I do not like to write too much, right? This is very cool because it writes the code for you. And now we can send to the output exception get message. So there is not enough water. So now we used the message from here because we can use the message from here. The truth is that we do not need to use this message now, right? We can do whatever we want now. We can say there was not enough water, so we transferred the water that was left in the bottle B, right? So this is the cool thing because we can do whatever we want now, right? This doesn't matter here. We gonna say what's gonna happen here, and we do not need to do if something, and we don't need to do it in here and then again here, and maybe if there was more things like that again. So this is the exceptions are solving some architecture problems, right? Okay, so this is very cool. And well, I think we shouldn't throw exceptions that are called exceptions. If you want to create your own exception, you should call it. So for example, not enough water exception. That will extend exception, and you just gonna control space and invoke the constructor up top. And now at least you're gonna see instantly what's going on, right? Like that. Okay, and of course we do not need to call it the same here. We can call it exception because exception is the superclass, so we can do it like that or like that, whatever. But as you can see, it's really improving the readability of our code because when somebody look at our class, and imagine that you have got thousands of classes, and he look through the signatures of your methods, he's gonna see, hey, here is something thrown, so there can be a problem. Somebody can want too much water, right? And okay, so I have to take care of it. because this thing was thrown. Okay, so that's how it works. And it's giving hints to the programmer that is gonna work with your code. If there was a boolean returned with many methods inside classes, somebody can miss it, right? Okay, so this is the reason, the true reason you want to use sometimes exceptions. Most times though, you want to use conditional statements, okay? If you use here, for example, just for checking the amount exceptions, your code would look horrible. So do not use it everywhere, because there is a place for exceptions and there is a place for conditional statements. That's all in the lesson. Thank you very much. Hello my friend, today I will explain you something what is called lambda expressions. You will finally understand them, okay? Because they are not so hard as they sound like. But before attempting this lesson, you should already know about something what is called anonymous classes, and I talk about them in the section about object-oriented programming, okay? So if you haven't watched it yet, then do it. So just to remind you, anonymous classes were used to what? To create something what is called a behavior, right? In one line, and you could store this behavior. Then you could, for example, use it like for example here, right, in the line 26, or you could create another behavior for a button. So you didn't have to create for each new button new extension of button, right? This was just stupid. So anonymous classes are great, right? And the truth is that implementation can be written a bit different way, and that's where comes lambda expression. So I've just used NetBeans to create a lambda expression from this implementation, and as you can see, it looks now weird, at least at the start, because you're like, what the hell? Here is parentheses, here is something like an arrow, then curly braces and some code. But the truth is that this, and I will use the shortcut Ctrl+Z, is the same as this, okay? This and this is just the same. Lambda expression is just implementation of behavior that looks simpler, okay? That's all. So the truth is, you don't need to know it, because you can already achieve everything with this, but this can look a bit weird if you're gonna use it a lot, right? This looks a bit better, right? This is just simple one-line code, but well, if you look at this at the start, you are like, no, this doesn't look simple. This is better. But let's just start to understand this syntax. When you look at this parentheses here, why it's here? It's because this method here do not have any arguments. The truth is, it's like, hey, let's create a method from the action after click interface, like here, and let's send here nothing, right? Because, hey, there are no arguments. Then we have got an arrow here. This arrow represents lambda expression. So this is gonna inform our compiler that I've just created lambda expression. That's all. Then you have got curly braces, right? And they represents the body of this method, right? This one. And then you have got the implementation of that method. So this is just this. And that's all. So this is just a simple version of it. That's all. That's only in the lambda expressions. And the cool thing is that people just make lots of interfaces for representing some kind of behavior rather than just implementing the behavior that can be reused many times in somebody code. Because when behavior is different for each object, right? For example, list. Let's imagine that you have got a list of people, right? And you want to get from the list people whose age is lower than 18 or something like that. And you have got another list of people, right, who you want to choose only people who, I don't know, have odd age, or have, for example, name that is called arg or other things like that. You would have to create each time new class for it, right? And so the truth is that you can use lambda expression, or you can use the behavior like an interface and create anonymous class. But the truth is that it's just the same, and that's how you use it, right? You send here arguments, here you are telling the compiler this is a lambda expression, and here you say the implementation. Okay, so let's do something harder. Let's create an interface. Let's call it action after click, for example, 2. And let's implement action, but right now this action will have, for example, 2 arguments here, right? Like that, okay? So we've just created another action after click 2 interface. So this one will, for example, I don't know, add 2 numbers, okay? So let's implement it. So let's create a place where we'll store this action, this behavior. So let's call it A2. And now we have to send there 2 arguments. Okay, so let's create parentheses and let's say int A and B. Okay, so we just send 2 variables there. And now we are using the arrow, so we are telling, hey, you know, we are going to create lambda expression. And now we have to say what will be inside the method, like the action 2. Let's send to the output, for example, A plus B, okay? And I think that it will be good, right? And we still have variable A is already defined. It's probably because it's defined here. Okay. So let's do it that way. Incompatible types, incompatible parameter types in lambda expression, int A, int B. We send 2 variables, and that's true. And the truth is that, well, this is my fault. It's good that I made this mistake, because he could have made it also. Look, I just, you know, oh, that's good. It's good idea that I made this mistake, because look, the truth is that you can have only one action, one behavior per one interface for lambda expression. You cannot do something like void action to int A and B here. As you can see, now it's not gonna work, because you can because you know, lambda expression is just short thing to just implement one behavior. That's all. So for each behavior you have to have second interface, and as you can see here, I tried to use what action after click. So I try to use this interface, and I send there what int A and B, and there is no signature of matter like that. So the truth is I should have just used something like that, and now it's okay, right? And well, we cannot use here A, because, well, he doesn't know which A is here, which A is here. So let's just do something like that. And well, x2. As you can see, now it's working. And look, when I do something like that and click here, I can use anonymous inner class. I can change it so it looks like anonymous class. So you can see exactly what I've just done here, right? So I've just created action after click 2, and I implemented action 2 with 2 arguments, so int A, int B, and the implementation of this method look like this. That's all. This is the behavior that we can use now somewhere, for example in the button, or any other to tell any other class, right? That's us, that we will decide where we can use this action. So we can, for example, here add action 2, and now we have to get here action after click 2, and for example we'll call it the same, and we'll invoke action 2. The problem is that we need to send here some arguments. We can send here, you know, whatever, 4 and 5, but it would be a good idea if we had taken them when somebody invoked this method. So we can do something like int x, int y, and we can send them there, right? So int x, int y. And well, Now we have to invoke it. So p dot, and as you can see now we can add another action like that. So we can send now arguments there. So for example 10 and then for example 15, and we invoke the behavior that is represented here. So just 10 plus 15. As you can see, it's 25. So yeah, it's working fine. Okay. And of course we could, just take it here and do it like that, take this under command, and it's also gonna work, right? It doesn't matter where this is just an implementation in one line. We saved it for here, so you can reuse it in, for example, many buttons, but hey, you can do it in one line. It really doesn't matter. And well, let's do something even harder. So for example, let's return here integer. What will happen? Well, because we are saying that this thing has to return integer, this action to method, here we have got an error because we didn't return anything, right? Because here is the implementation of this method and there is no return and a return keyword. So we have to return now, for example, a plus b. So we do not need to send to the output now. We can do something like that, and well, this will be enough. But the truth is that, well, when we are sending here x2, so we are sending it here, and then we are invoking it with the arguments that were sent here. Well, the result is here, so we have to also return it here. So we're gonna return it like that, and now we can store the result here, right? And we can send the result to the output, so like that. And as you can see, it's 25. Great, isn't it? So that's how it works if you want to also have a return, right? So in order to see how it works, use anonymous inner class. So this is like implementation of the action 2, so this guy, 2 arguments and the return. That's all. And the cool thing that you can make it a bit smaller, even smaller, right? You do not need to type here integer or integer. Why would you even need to type it here when the interface can only represent one behavior? So hey, when you look at int here and int here, when the compiler looks at it, he's like, I know what's there, why did you even type it here? You do not need to type it again, right? So this is gonna work. And the next thing is that when you have got something very short, like return statement only, you can make it even shorter. Why even bother doing all these things? Hey, let's do it just that way. Okay, return a plus b. Or why do we even need return keyword? Let's do it that way. Bam, 25. So well, this looks simpler, right, than if we had, inner class here. But it also might be hard to understand for some people when they look at this. When you look at something like this, when you find something like that in a code, you will see lambda arrow, right? It means that somebody wants to use the lambda expression. Here are the thing that will be used inside the method, and here is the implementation. Okay, so you are just saving a behavior that you can reuse, that you can use somewhere. That's all. Okay, you do not need to exactly know what's gonna happen, because that's what you gonna exactly do, right? You are the person who's gonna make the action, right? And that action will be used somebody else. Okay, so the reason of anonymous classes and the reason of lambda expression is to create actions, behaviors that can be used in other classes, so you don't need to create for each action a new class. That's all in the lesson. Thank you very much. Hello, today we are going to talk about documentation. Well, there is a very big documentation of all possible classes that were created by the Java creators, right? There is just tons of packages with tons of classes that you can read about, with tons of methods. And really, I don't know all of them. There is none of programmer who knows all of them and they remember all of them. That's why people are creating documentation, because it's just impossible. We are just humans. It's impossible to remember everything, right? And when you look at the package, you have got the description of this package. Then when you go to this package, then you can get a class summary that says something about the classes in that package, right? And when you go to the class, you can then see that this class implements something like that. Here is some kind of description of it. Then you can give some notes. Here you can see from which version this is available. Here you have got some links. So you can go to another thing that is related to this. You have got field summary and constructors and methods, and you have got tabs, so you can see, static only methods. You can see what is returned here, what is exactly happening here, right? And you can create your own documentation, and that's really cool. So you have probably noticed that I didn't delete the comments in this lesson. This is very weird, right? Because normally I delete them. So this is a normal multi-line comment, and well, here you put just listens. So you say that you can use your program that was created by you the way you specify here. That's all. This is not documentation. Documentation is something like that. When you add one more asterisk here, okay, it is the something that will be interpreted by the Java program. When you click here, run, and then click generate Java documentation, you're gonna generate, as you can see, you can take it from the path like that, and you can send it to someone. This is a Java documentation for your package with your classes. As you can see, I can go to the main, and right now here is nothing, right? Only this static method that is gonna be executed when you run your program. That's all. So now it's your time to create your own documentation, right? You can, for example, change the author. So my name is Arkadiusz Wodarczyk, right? You can, for example, do a version of this. So for example, right now the version of program is like that. Today is, for example, a day like that. So you can do whatever you want here, right? You can describe the classes. So let's create a class, for example, that we'll call employee, and let's do the same thing like here, right? And let's, for example, describe our employee. So for example, class, and now we can use HTML tags. That's very cool. So in order to, for example, say this is a code, employee, and represents employee and it is superclass 4, and you have to blah 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 blah. So this is the place that you describe it. When you generate it now, as you can see here, we have got the description of it, right? So it should be description of it. When you go here, you will have a bigger version of it. And well, that's how you use it. So let's create something maybe harder. Let's create a few private double salary, private string name, private string surname, right? Something like that, for example. And let's create constructors. So Ctrl plus space, Ctrl plus space. Let's create now a getter. So get, for example, name, get salary, get surname, and now the setters. So Ctrl plus space, set name, set salary, and set surname, right? So we've created very fast a few methods using our IDE, and now it's time for creating the documentation, right? So for example, we can document this constructor. So as you can see, it's very cool because this IDE is helping you, and it added something like here, that add notation, the parameter. And now you can say that this is constructor that will create an employee with properties that will describe salary, name, and surname. do not forget to you can give some hints, right? Because now, for example, salary should be, you shouldn't use very big precision because this double, you should use different type really here and other things like that, blah 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 blah. So salary describes or sets salary of employee. So name, surname, and now when you generate it, you will notice that we have got now bigger description like that. When we go here, we can see the description of parameters. So pretty awesome, right? What about, for example, returning? Because you can see we have got instantly something like that. Returns the name of employee. And when you generate it, you will notice that when we go to get name, we have got the information what it returns. Well, we don't need to say returns because it's here already, so we could then return the name of employee, right? That's enough. So you can also give some additional information here, right? That's just up to you. What about here? Parameter name. So sets the name of employee, and here you can give some additional information, like it's gonna check if the name is, the name of woman, or if it's woman, it's gonna accept it. If it's man, it's not gonna accept it. Whatever, you know what it's about, right? And when you generate it, you're gonna have information now for setters, as you can see here. And when you go here, then you can see the parameters, everything about it. That's very cool. And you can, for example, inform that this getter is since the version 1.1.1, right? Something like that. And when you generate it again, you will notice something like get name. It's since version 1.0.0. So you can inform some button about something like that. It's rarely used in things that you create. It's mostly using the official things, like, for example, this here, okay? And you have got something very important that I didn't tell about. It's something like that. You can do something like see. See, it's like saying, giving information, additional information about the thing you want to show. So for example, you can now, as you can see, we have got suggestions here from our IDE, and we can say project documentation. So it's our package name. And we can send somebody to, for example, employee, and can send him then using the hash to the property or to the methods, right? So I can send him, hey, if you want to create it, go to the constructor, whatever, right? And generate employee. And when I do something like that, I'm instantly at the default constructor. So you can you can send somebody to something that's very important about your class. So for example, classes that will inherit it, and you can give information why it's very important here, right? This is very useful. You can also give the normal link here. You can do something like, for example, using the HTML, you can give here the link to the website. So for example, http://videocoursesonline.com, right? And you can use the target attribute to open it in the new tab. And here is the name of website. So for example, video courses, and like that. And now when you generate it, you will notice that here, when I click it, it's gonna open the website videocoursesonline.com, right? So you can send, for example, to the article that will describe your class, whatever. That's just up to you. The cool thing about these descriptions is that right now you have got additional information. Look, when you do something like that, employee, you have got the description that you created here. You have got also links here, right? You can use them. That's cool. Wow, look at this. It even opens it here, right? Well, maybe for web page it's not gonna work so good, but hey, it opens connection. You can jump from this place to another. So you can create employee, and now, as you can see, we have got get, for example, name, right? What does it do? It returns the name of employee. Oh, okay. Of course, you know, this name is self-descriptive, so probably nobody would read it, but if there was something very important done inside, it would be probably a good thing, right? The cool thing is also that you can, for example, show how to use it. So employee, new employee, and then, for example, e.getName, right? This is simple, so it's maybe useless, but if you have something hard to use, you can show example. And when you generate it, so like that, as you can see, we have got now here how to use it. But as you can see, everything is in one line. That's because it's HTML. And if you want to make it pre-formatted, you're gonna use the pre-formatted tag, right? And now, as you can see, it's not in one line, so it's more readable. It's a good idea to also say something about your properties sometimes. So you can say this is salary in, for example, dollars. And now if you had created a method, you could do, you know, this, that, and as you can see, you have got now information about the property here. So it's also very useful. So that's how it works. You can create documentation, and you should do it for at least bigger project, or you should, you know, make a habit of creating documentation, because it will save lots of time for people that will use your classes, and maybe not only for other people. Because really, believe me, when you create something, when you program something, you're gonna remember it for maybe 1 week, 1 month. It really depends on your memory. Sometimes maybe 6 months, but after, I don't know, you come back to your code after 1 year, 2 years time, you are gonna be surprised that you were such a genius to create a code like that. And that's the time when the documentation, when examples of usage of your code is gonna be really helpful. That's why you should create documentation, and well, that's all in that lesson. Thank you very much. Hello my friends, today we are going to talk about default methods that are available to use since Java 8. So this is a new feature. Normally when you created an interface like that and you called it formula, for example, and you created the class A and you implemented a formula like that, you would have to implement all possible abstract methods there, right? Because by default they are all public and abstract. That's how interface is working. But since Java 8, you can create something like a default method. So you can type default, then you can type, for example, default double, I don't know, square root. Let's create a method like that. And you have to now implement it here, okay? You have to give the default implementation of it, okay? So if you do something like that, well, you cannot do it. You have to pass the default implementation. So let's return, for example, here a method from the math class that is just gonna count the square root, right? So we just implemented it by default. Of course, somebody can override it now, so he can do it, but he doesn't need to do it, right? So, well, it has to be public because by default it's public, right? And you can add override annotation, and that's okay. That's all. So you can, but you don't need to. And now you might be like, why did they implement it? Doesn't interface look like abstract class now? Well, it's a bit more similar to abstract class now because you can now choose which one is abstract, which is not. But, you know, there is a very big difference still. you can implement more than one formula. And remember that if you extend abstract class, then what? Then it's the end. You cannot extend that class anymore. You just extended that class, that's all. So you can extend only one. And you might be asking yourself, why did they implement something like that? Imagine a situation like that. Well, imagine this is a real life example. Java creators created many interfaces long time ago, many years ago, and they couldn't predict every possible method that should be in that interface. And now imagine that every programmer in the world that used Java, for example, implemented one of that interface, right? Very popular one, right? And now imagine they added one new method there. Every possible programmer would need to implement this method now to their class, so it would just destroy totally every program that has already been written. And this is the solution. They could create a new method and give the default, default behavior for it in the same time, and they wouldn't destroy all programs that have already been written. So, programmers that do not care about new features, they can still use their code, and programmers who cares and who wants to upgrade their code, who wants to use new features, they can now do it. So this was the solution for something like that. So this is really great solution for upgrading interface. The truth is that you should create interfaces the way so they will never be upgraded. But hey, this is a hack solution, right? If you did something wrong, you can create a default method and then it's gonna work. And well, it's also good to say that interface that has got one public abstract method is called functional interface, because it is used for the creating actions. So for example, when we did something like that, this is called an action, right? The behavior that we are storing somewhere. So when we are you have to remind yourself about the lambda expression lesson now here. And we could use the lambda expression if only one method was inside interface. But as you can see, it's still working. Why? Because, well, here we have got default method. This is not abstract, right? It's not abstract. You don't have to override it. And because you have got still only one abstract method, lambda will work, because lambda will look for the signature of method that has got something like that, and that is abstract. He doesn't care about this method. So lambda will use this method here to override it, and we can just put here some kind of code that will return 5, for example, whatever. We just implemented the formula, fast formula that can be used later, right? And as you can see, you can use pretty easy the default method too. So this is how it works, right? You can now have more than one method and still use lambda, but only one method can be at the same time abstract. Okay, that's all in the lesson. Thank you very much. Hello, congratulations my friend, you've just finished the video course about Java. So now you know perfectly the syntax of Java, okay? But hey, it's time for training, it's time to create something great. And after this course, I think that you should go ahead and, for example, learn something about creating Android application, because here is the place where is the true cash, right? And well, I will create a course about Java Android, so maybe it's already created, you can check it out in my profile. But if not, you can go, for example, to this website and learn about it. But of course, it will not be as good explained as I will do it. And well, what else? You could learn about Java database, and because, well, this is a good class that will allow you to store some of the data that you're gonna use. That's a very important thing. You could learn about concurrency, which is gonna give you ability to create multi-threaded application, right? So it will improve speed of your application, but this is very advanced topic, so it really depends on situation, what you are writing. Okay, it's also a good idea to know how to create desktop applications, the typical desktop applications, right? For example, IDE, right, like NetBeans. So you can learn, for example, Swing, or you can learn the new Java FX. So this is the things that I think you should do now. Okay, after this course, you should now train, use the classes that have been already provided by other people, and try to learn them, try to create something with them. Okay, so that's the thing that you should do after this course: training, training, and training. And well, I would like to thank you for taking this course. And if you have any questions, really, I love helping other people, so just create a discussion and I will respond you as fast as possible. And when I see it, I will just respond it. That's my way. Of course, I can sleep when you are, for example, asking something, because I'm from Poland. But when I'm online, when I'm not, for example, on weekend or something like that, I will explain you everything the easiest possible way. If I did something wrong, that's my fault, and I should explain you it better way, right? This is my fault, and this is my responsibility to make everything as easy, so it's easy to understand for everybody, right? And well, if you can, well, this is not requirement, I would be really glad if you could leave a feedback for my course, because it's really helpful for me. Okay, and well, that's all in that lesson. I wish you good luck. Thank you very much. Hello my friend, today I will tell you what are generic methods. Generic methods allows you to make the type that is gonna be generic between the curly braces of this method, and when something like that is useful. Well, here I have created 3 arrays. As you can see, all that arrays have different type, right? String, color, integer. I've created the color one, the others one are created by the Java developer. So these 3 classes have got some kind of values, right? This one have got this sequence of characters, this one has got the name of the color, this one has got the values of integers, right? And you can create your own one, like the person will have the name, the surname, and other things like that. So here I created the color, and you have got here, the getter, the constructor, the name of the color that you can set here, and you have got here overridden method that allows you to compare these colors, right? So you can go ahead and create your own one, and almost always you will want to create, for example, a method that is gonna count how many items are inside an array. Okay, so you would like to check if there are like 3 occurrences of the color red, or if there are 2 occurrences of it, or you want to see if there are strings that name is like that, or you want to see how many numbers are equal to, right? So this is very frequent operation. So normally you would need to create something like that. Public method that is gonna be, for example, static. So we can use it without creating the class, right? Because, well, this method is really something that doesn't need a class, right? You can compare whatever you want. So public static, and it's gonna return integers, so the number of occurrences, and the name should be, I think, count item occurrences, right? And now we should take here the array from where we will count how many items are inside that array, looking like we provide in the second argument. So for example, like that, and now string item to count, right? And well, how to count it? Well, it's not gonna be hard. We just need to create a temporary variable that is gonna store how many items are inside, and we'll just use the loop, right? Because we need to go to each of that value in the array, right? So let's use the for enhanced for loop. So we will do something like that. We'll create an item, temporary item string from each element of the argument that is gonna be sent here, right? Like that. And now we can just make a comparison. If item that equals to the item to count, so the one that is gonna be used as the second argument, then we can, for example, increase this, well, count by 1. And at the end, we are just gonna return the count, right? So this is gonna work for that situation. Let's check it out. So int count of strings, and now we're gonna send there something like that. I want to look for the occurrences of A, right? So cout C strings, and now let's just play it. So as you can see, it's 2, and it's true. We have got 2 occurrences of A. If I do something like that, it's not gonna find anything. If I do something like that, it's gonna find this test here. So it's working fine, but our method is not gonna work for the colors, for integer, right? It's not gonna work like that. Why it's not gonna work? It's because we have got here a different type, right? So the truth is that now the only difference that would be if we created another method for counting, you know, colors or integers, the occurrences of values there, right, would be only to change these types here. So it would be like color, and it's not good, right? Because the truth is that if we change something in our algorithm, we would need to change it in every possible place, right? If we had, you know, many types, we would need to create many methods, so it would take lots of time. So the cool thing that comes to rescue us is generic methods, because we can just do something like that. We can create our own type. Okay, so this is our own type, and now we can do something like that, t, and t here. Okay, and with the solution like that, as you can see now, we can do the same to, for example, colors here. So we can do something like we can send here the array of colors, and now we can send there, for example, I want to look for color that will be red. Okay, variable C string is already defined. Oh, sorry, we didn't change the name here. So C colors, like that. And as you can see, it is saying that there are 2 times there are 2 items with the value red, right? And it's true. We can, you know, increase the number of items inside, as you can see, 3 times now. When we change red to something else, it's 0. So it's working fine for another type. You can, as an exercise, use it for integer also. And well, it's also working only because of this method, right? Because this method is gonna be the same for all possible objects, right? For all possible objects, there is gonna be a method called equals. So if somebody wants to use the count item occurrences, he has to, you have to remember, override that method. So you would not have to change anything inside here, right? And you might be now like, but how does our compiler know about, you know, this type here? How does he know that he should put here, you know, in this situation string and in this situation color? How does he know when to replace it? Well, he knows it when we execute our function, when we invoke it. Okay, so in this situation we are sending here s, and this s is an array of strings. So, it's like, it's gonna be sent here, and because here is string, it's also gonna be string here, is also gonna be string here. This thing only says, for the compiler, so he knows that we are gonna use generic method, we are gonna use the generic type somewhere in our method, right? Because right now this t is just for our compiler nothing. What's t? When we do something like that, we are saying, hey, we are gonna use here something what is gonna be called t, and it has got a meaning, and the meaning of it is gonna be sent here in this place where we invoke that method. Okay, so this is very, very cool. You can also use it with the array list. You can use inside the type like that. So you can then have many array lists with different types, and you can take as an argument an array list with many different types, and you can do something with them pretty easy, like for example adding new items and so on and so on. It's also good to know that you can use extends keyword here. So you can say something, hey, you know what, I want to have here only colors. Okay, and because of it, as you can see now, this is not working, but this is working still, right? It's still working here for the colors. So anything that is gonna extend color, it's gonna work, but otherwise, if it's not gonna extend color, it's not gonna work. Okay, thank you very much. That's all in the lesson. Have a good day. Hello, my friend. Today I will tell you about generic types. So far, we've been creating variables specifying the type of variable. For example, we type something like string and then the name of variable, right? So this is something what is called a row type. Okay, this is just something that is a typical type. Okay, and now we will learn about something what is called generic type, because sometimes we want to make a type that is generic. But what does generic word mean in this situation? It means that the type is gonna be universal. Okay, it's gonna be generic. It will change according to what we want in specific situation. We'll be able to create something what is called a placeholder for the type. Okay, and as the name suggests, placeholder holds the place for the type. It's like a parameter for the type. Okay, we can send an argument to the type here. Okay, so when something like that is used, and how to create a variable that can change the type, how to do it? Well, let's first see how the creators of Java use it. There is something what is called an array list. Let's import it, so Ctrl+Shift+I, and when we create it, we have got now ability to add to the array list something what is called elements. We can add here any type of object. Okay, so if I do something like that, new array list, now we can, using this name of variable, use methods from the array list, like for example add, which will allow you, as you can see, well, again, you can send here an object, right? So you can send here whatever you want. You can send here whatever element. So array list is something what is called a collection. Okay, which means that you can collect there many items, many elements. So we can send there, for example, name, right, that we created here. We could create more names, so let's do something like Arik, name2, Viola, and well, we can add one more like that. Okay, so this is working fine, but this also means that you can add here whatever you want, right? You can do new object, you can just insert here whatever you want at the moment, because well, the signature of this method is looking like that, right? It takes objects. And because of it, there is a problem. If you want to get something from array list, you will do something like n dot get. As you can see, now you type the position of the element. So for example, let's take position 0, which is the first position, which is arg at the moment. So if we want to get access to it, we cannot do something like string first name, something like that. As you can see, we have got here an error because we have to do downcasting. Why? Because get is returning the object, right? And object doesn't have access to the methods of the classes that extends object, right? Everything extends object, but in order to get access to the methods, you have to use downcasting. So you have to do something like that. And the problem is that, well, for the first guy, for the second guy, you can do it, but here it could lead to problems, right? You could have here, you know, your own classes put there, like employee and other things like that. And the problem is that this is gonna always compile anyway, right? Because it doesn't know exactly if you are doing things right. So compilation is gonna take place and you will have an error later if you're gonna do so, for example, something like that, and add new employee, right? If you do something like that and then you get the 0, 1, 2, 3 third element, as you can see, we have got here an error, right? Because we tried to invoke something like that. So how to solve it? We have got something what is called a generic type. And when I use the control and click on array list, as you can see, we can go to the description of this class, right? And here you can see that we have got here something like array list. And then we have got here something like that, E, which stands for element, okay? And this thing is a placeholder for the type that will be sent using something like that, okay? You can now use that signs here, this diamond sign, like that, this lower and the greater than sign, and you can send here, for example, string. And it means that it's like, hey, I'm sending as an argument here this string, and it means that I'm going to replace every possible E. As you can see, every possible like that is gonna be replaced in that code by this string. There are some additional things like extends, maybe somewhere you have seen some, you know, weird things. Don't worry, we'll talk about it in next lesson. But so far we know that this is like an parameter, right? And here we are sending an argument to this class, right? And we want to replace all these things. And because of solution like that, when we do, of course, something like that, we need to now invoke the constructor like that. As you can see, we have got an error here. It says, you know what, no suitable method found for add object, because right now it's like, you know, we've just created a special class with every possible method that has got signature with string, okay? It is now not generic. Using something like that, we created a specific new type, because it's like a template, okay? Template for creating classes. So right now, when we do something like n dot, as you can see, we do not see here as the suggestion object, but we have got here string, because the truth is that we created a class using this, right? We created it using this template, and it works, right? You can now only send strings using this method add. So problem like that will not happen, and you will not have to also compile here anymore. The cool thing about template is that it is compatible backwards, okay? Because Java is implementing new things into their libraries, and they implemented something like that, and many people have already used array list with the downcasting, other things like that, right? They could add every possible object to array list and so on. But by default, if you do not specify anything here, okay, so if you do something like that, we created a template. We created using this template a class that will replace this placeholder everywhere with the object, right? Okay, so if you do something like that, it's gonna look like that. And it's also very important to know that, look, you do not need to specify here again the string, okay? Since Java 7, you can use here only this diamond, okay, because it looks like a diamond operator, and as you can see, it's still gonna work fine. But why it's not working? Index 3. Oh, it's because we're trying to get to the third element that I deleted here, right? So as you can see, that's how you get now the value first name, and we can now send it to the output. So we can now use it like if it was a string, right? We do not need to cast it every time. This is just gonna work all the time now as a string. Let's now create a special class that will be just created by us, that will be able to do things like this array list, for example. So let's type a class, then we type the name of the class, so let's for example call it box. Then you use these signs, and inside of it you type the placeholder for the future type that will be used inside when somebody create a box, okay? So you can type here whatever you want, and yes, this is gonna work, okay? As you can see, it's gonna compile, right? It's working. So you can type here whatever you want. They type here E because it stands for element, right? Some people type here T because it stands for type. But you can type here whatever you want and it will work because this is a placeholder for the future type, okay? So whatever you want, and for example name of variable, right? And yeah, it's gonna work, right? Look. So if we do something like that, box new box, as you can see, we created a box with the name of variable. The type is object because we didn't specify anything using this syntax, right? But well, we can do it. Hey, I want to store in my box only strings, so we need to also add here now something like that, because if you do something like that, you are really creating, you are using a constructor that is gonna create methods with wrong signatures, right? This is gonna be row type still, so you should do it that way. It might work sometimes when you do it that way, but sometimes it can lead to problems. So remember about doing it that way, which will guess what's here, or you can type it again, but I think typing it again is just redundant, right? It means that it is additional work that you really didn't have to do. So right now we created a box, and as you can see, now this box is gonna store inside a name of variable a string, okay? And now you can create, for example, getter. So get whatever you want, right? Something like that. And you just need to return this type, okay? Like that. And you need to just return it. So as you can see, now we can type something like box.get whatever you want. And as you can see, it's working, but we don't have anything inside the variable. So let's create a setter. So setter doesn't need to return anything. We can set whatever you want. and set this name of variable, set to name of variable that will be sent here, right? Well, maybe value of variable, and the value will be what type? It has to be that type, right? It has to be the same type, like here, because this is a template for creating this box. And now we need to use it. So assignment to itself. Oh, okay, because I didn't change it here. And now let's do something like box that set whatever you want to Arkadiusz, right? As you can see now, we have got here Arkadiusz because we set it. Of course, it's better to call it a bit different way, right? Like, for example, let's call it everywhere T. And here we should, do set name of variable, and here get name of variable. So it's, looking better. So this is just a placeholder. Do not worry about it, okay? A placeholder for the type that you will want to use, and you will say what you want to exactly use inside here, right? When you are creating a variable or when you are, constructing a variable like that. So the cool thing is that you can create now another box, and in another box you can now store, for example, employees, right? And in that another box that we call box 2, now you can add, as you can see, now you can set name of variable for employee, right? So maybe it's wrong to call it set name of variable, but set element, right? It will be better now. So get element, and now just value of element, and here element. And now this is a self-descriptive class. Of course, I could start from creating it like that way, but it might have been a bit harder to understand for you. So this is good feature because you do not need to check then if the class is instance of something. If yes, then do it that way. You don't need to use the downcasting, right? This is the solution for things like that. That's all in that lesson. Thank you very much. Hello, my friend. Today we are going to talk about the wildcard. Wildcard is this question mark, and it allows you to do something very hard to understand if you do not make some kind of practical example. So let's look at the classes that we have got here. We created in the last lesson a class which is called a box, right? And this is a template class, so it means that you can create a generic type, which means that you can send any type that will be replaced here by these letters, right? So we can send string, and then it's like creating a specific class just with everywhere string, or employees, or objects, right? So it's here we created class with strings, here we created class with employees, here we created class with objects, okay? And well, it's gonna work, right? When you do something like box of strings, now when you click that, as you can see, when we look at this description of get element, it's gonna return string. So yeah, set element, you can send here a string and set it. But what would happen if I wanted, send these boxes somewhere for processing, right? Well, let's imagine you want to, process all possible boxes at once. How to do it? So let's create, for example, class processing boxes, right? Something like that. And well, let's create a static, not returning anything method process, okay? Process box, and here is the good question what we should take here, right? Will it be box of objects, something like that, will it work? So if I do something like processing boxes, that, as you can see, we can use the static method without creating the instance because it's static, right? And we can send their box of objects, right? It's working fine. But I cannot send their box of employees. It's not working. I cannot send their box of strings. Why it's not working? It is not working because the types are wrong. Look, here we have got box of object and we need to send here box of object. The variable, the type is like that, right? And here we are sending really box of strings, right? We are sending as an argument to this class string. So this is totally different class. So if you want to process here more than one generic type, right? With different parameters here, right? But with the same name of class, then you have to use the wildcard. And this wildcard is just, as you can see, this question mark sign. So now, as you can see, we can send a box of strings, we can send a box of employees, we can send a box of objects, right? Everything is gonna work fine. So this is a wildcard because it means it's wild. It's so wild that it can change the type to whatever it wants, right? But it also gives you some problems when you do something like box dot. As you can see, now it returns question mark, and when you set the element, it's also the question mark here, which means that, well, you have to again do something what is called checking for the instance. You have to again, when you return the value, you need to do casting. But it's okay because at least now we are sure that if somebody uses the box of objects object or the box of employees object, he is gonna add only employees or add only objects. Okay, so this is still a very good feature. You can do something like, for example, add a word extends, because now when here is a question mark, it means that this object that is gonna be sent here, right? So box of objects, for example, this box of object is type is box of objects, and does object extends objects? Yes. Does employee extends object? Yes, because any class extends object, right? Does string extend object? Yes, because any class extends object. That's why it works. So by default, here is something like that added, okay? So this equals this, okay? This and this is the same thing, okay? So it's like, when I send here box of objects, right? So it's like something like, let's check it. Does object extends objects? Oh, okay, it does, so it's gonna work. Does employee extends object? Okay, it's gonna work. String? Okay, it's gonna work, right? But this means also that you can change the thing that is gonna extend it here, right? So you can say something, I want to take only things that only objects from boxes that are gonna extend employees, right? So as you can see now, we cannot send here box of objects, right? We can send only box of employees, and now, yeah, it's gonna work. You can send here something like that. But it also means that if you create, I don't know, class super employee and you extend employee, right? And you create a box of super employee, box of super employees. As you can see, I can do it also because super employee is really extending employee, right? Well, we say it here. Super employee extends employee. Super employee extends employee. And that's why you can send it here, right? And then you can work with it. So that's how you use wildcard. You can restrict, you can restrain, right? You can limit what things can be used as a parameter for the generic type, okay? So wildcard is used to restrict what parameter can be used in generic type, okay? Something like that. It's also good to know that you can use it not on this word, it extends. You can also use with, for example, here with the typical generic type. So we can say something, hey, I want to have here only boxes that's gonna extend employee, right? Something like that. And as you can see instantly, we have got here an error and here an error, right? So yeah, we can do something like that because employee extends employee because, well, it's the same object, and super employee extends employee. So that's why you want to use wildcards in your program. Thank you very much. Hello my friend, today I will tell you how to install and how to download Android Studio. In order to do it, you just type Android Studio download and then you go to the first web page. And here we can do it. But before we do it, I would like to tell you what is Android Studio. Android Studio is, as the name suggests, a studio. So the place where you have got lots of tools that are connected to creating Android apps. So you have got there, for example, a compilator for your Java programs, right? You have got there some kind of an editor that is gonna have a code completion for you. You have got some kind of widgets that you can put onto your device and it's gonna create for you lots of code. You have got there, for example, an emulator that you gonna use to, for example, emulate lots of smartphones, because it's not possible for you to have 1,000 of different smartphones with different, versions and different sizes. You can just emulate all these things, right? So Android Studio is really something very important for you. It's gonna help you update the newest, for example, SDK tools, so software development kit tools, so some packages that are used for development software, right? So there is gonna be tons of useful things in Android Studio and it's just needed. It's free, that's very cool. You just need to download it now. So in order to do it, you can click here, but you might not have the Windows, right? So if you do not have Windows, you just go to the bottom of this page and as you can see, you can download it for Macintosh, for the Linux, right? So you can click one of this and it's also gonna download it, okay? But if you have Windows, you can just click here. But before we go into it, I would like to tell you about requirements, because it's really good to know that Android Studio requires 2 GB of RAM, so and is even 4 GB RAM recommended, and you need to have at least, I think, 5 GB of space on your disk, okay? This thing here is, I think, not true. You need to have at least 5 GB, okay? And the next thing is Java Development Kit. I hope you know how to write anything in Java, because, well, if you do not, you should go first to my first course about Java or learning it on the internet. But you should have already installed something like Java Development Kit, right? But you might not have the newest version, and in order to install it again, you just type Java Development Kit download. You just go here and then you just click here and you can download it here and update it, okay? Because if you do not have new version, you are not going to be able to create applications for Android 5 plus applications, okay? So it's not gonna work for you. Okay, so if you have got it, then you just click here, download, right? And when you click on it, as you can see, we have got something like that. We are not gonna download it again because it will take too much time, and you just click on it. As you can see, the setup is loading. Okay, let's wait a second. And we click next. Then it's a good idea to install everything here, okay? We click next. As you can see, we need 4.3 GB, so it's a lot and there are gonna be lots of updates, so it's a good idea to have lots of free space. We click next. I agree. Of course, we read all these license agreement. I agree. And then we should specify when we want to install our Android Studio and where we want to install the software development kit for Android Studio. Okay, then we click next. Here we are being asked that, as you can see, at least for me, maybe you will not see it, but I have got Intel processor, and that's why I can have the accelerated manager for emulating the smartphones, for example, for emulating any device. And because of it, it asks me how much RAM I want to reserve, right? So I'm using the recommended value, for example, 2 gigabytes. If you do not have it, you're not gonna see it, but well, as you can see, it's a good idea to have something like, for example, Intel. Okay, so let's click next. Here we just name our Android Studio, we click install, and now this thing is gonna take about 5 minutes. It really depends on your computer, okay? So I will just click stop for now. Okay, so the installation is complete, and now we're gonna click next. And as you can see, we can start our Android Studio. So let's click finish. And our Android Studio is being open. As you can see, now firewall is being asking me, it's in Polish, but it's just asking me if I want to allow it to access the internet. Okay, I'm allowing it. And as you can see, it's gonna right now update something. It doesn't need to happen to you, okay? But maybe it's gonna happen. It really depends on the situation when you're gonna download this Android Studio and what was inside of it, okay? So for me, as you can see, it's gonna download something, it's gonna take some time again, and I'm gonna pause again. Okay, so after installation process, as you can see, we have got something like that. I click finish, and then as you can see, we can create our first project. As you can see, I have got here a few projects already created by me, but this thing is gonna be done in the next lesson, where I'm gonna tell you how to create your first project. That's all in that lesson. Thank you very much. Hello, today I will tell you how to create your first project, but also I will tell you very important aspects of Android Studio, like for example, what Android version you should choose, what are activities, and so on. So please try to watch this lesson fully, because normally in other courses when creating projects are very easy, you just click next, and that's all. But here this is very crucial what you're gonna choose, because if you choose the wrong version of Android, your application might not even show in the Google Play Store, and you will not earn, for example, money, or you will have problems because your applications will not show almost for anybody, right? So let's start from clicking here, start a new Android project. When I click on it, as you can see, I can choose the name of my application. And this is very crucial. Why? Because this is not only name of of your application that is gonna be visible just for you, because this name here is gonna be visible on the smartphone. So it should be catchy, right? It should be something looking very good. Okay, so you can call it whatever you want, but it should be a nice name. So for example, let's say I will create a calculator. Okay. And as you can see, now we have got here something like company domain. Company domain is something that should be unique to you. Why even somebody created something what is called a company domain? Why do you need here something unique? Because there can be thousands of people who gonna create calculators and they're gonna call it calculator, and there can be thousands of people from around the world that will use the same word with the application name, and this could lead to some problems, right? And company domain must be just unique to you, and because of it, it's gonna identify your applications. Okay, so here is the unique name for my Polish website, but I will use, for example, here the English one, so videocoursesonline.com, and it says that it is in the subdomain of commercial video courses online and here is the name calculator, and this this package name with the application name is gonna show now in the Google Play Store, right? Oh, that's pretty interesting with that name. So in the future, it's gonna sell under this name. Okay, so now when we click next, as you can see here says, here we have got some information like that. Select the form factors your application will run on. It means select the devices your application will run on, okay? Because different platforms may require separate software development kits. Soon I will tell you what is SDK exactly. But before we go into it, let's look at what platforms you can run Android on. So you can run Android on, for example, phone and tablet, and we'll focus in this course on this section. You can also run them on the Wear. Wear is the clocks that you wear on your arms, right? You can use it on the TV. You can use it in Android Auto, in the Google Glass, but we won't focus on this part because it's very similar. And well, I want to focus in this course mostly in how to think in Android Studio, how to create whatever you want in Android Studio. Okay, I want to teach you the skill to be able to do whatever you want. Okay, I don't want to focus on every possible function that has ever been created, because it's not possible. Even I would lie to you if I said something like that. If somebody said something somewhere else, he lied to you, because it's not possible, because there are just thousands of applications, thousands of libraries that are gonna be created each day, and this is not possible to even remember all of them. I don't know all of them. That's not possible. If you want to become a programmer, and I want to teach you in this course, you need to know how to look for the functions, how to look in the application programming interface, so in the API, and choose the functions that you want to use. Okay, so we're gonna choose the phone and tablet only, and here we have got very important thing: minimum software development kit version. Okay, software development kit stands for, as you heard a second ago, for software development kit, and it means that you want to that you have got there a kit, so some kind of package for developing software, right? So there are tools, there are libraries that you're gonna use, and each of that SDK, as you can see, has got a number for programmers, so 15, 16, 17, 18, 19, but for people who uses smartphones, they are called a bit different way, like for example KitKat, Lollipop, Jelly Bean. Well, marketing must must be somehow achieved, right? Because API 17 wouldn't look good, or Android 4.1 it doesn't look good also. But there are many versions of Android, and here we have thousands of problems that we will have to talk about in future lessons also. But let's focus now. Which one should I choose? What will happen if I choose this one? What will happen if I choose this one? Well, if you choose this one, you're gonna be supporting approximately right now 97.2% of devices that are active on the Google Play Store. So it means that these guys can buy your application, right? But if you choose this one, there is below 1% of the devices that are active on the Google Play Store. So well, even if you create an application like that is gonna say, hey, minimum SDK for this application is 6.0 for now, you're not gonna achieve much money, right? So it's not a good idea. But if you are using Android 6.0, you can use the latest API. You do not need to worry about all old Androids, about how it's gonna look there, how it's gonna work there, and other things like that. So it's really cool. But it doesn't mean that if you choose, for example, 4.1, you cannot use totally things from Android 5.0. You cannot use it on Android 4.1, right? But you can use it on Android 5.0, because if you say minimum SDK, right, if you support minimum SDK, it means that you're gonna support also 4.2, 4.3, 4.4, 5.0 and so on, right? But if you use any of the new features that are coming from new versions, right, you have to check if the guy who is gonna use your application has got a new Android. For example, there is something what is called a toolbar in Android, for example 5.0, and it's not supported in, for example, 4.0.3. And if you want to use it, hey, go on, you can use it. It is an additional feature to your program. It's not gonna show on 4.0.3, but it's gonna show on 5.0. But you have to, make lots of code in order to work, to make it work. You can also use some kind of support libraries. So libraries that were created using the application programming interface 15 to, achieve something similar to the toolbar from Android 5.0. But you have to create then lots of more and more code. So you can see there are lots of problems because of it. You can click here, help me choose, and as you can see here, you will see how for now people are using Android versions, platform versions right now. And for example, if you choose for example 4.4, you're gonna support how many? 62% people, right? So we're gonna support 4.4, KitKat, Lollipop, and Lollipop, and the Marshmallow 6.0, right? So and a new one. On the right side here, you can find out about what is new in each version. So for example, in Android 5.0, you have got something like lock screen notification. Oh, that is additional feature, right? You do not need to notificate about everything people. This is additional feature. So yeah, you can use it in, for example, even you can choose the 4.0 Android platform version if you're gonna use lock screen notification anyway. Why? Because, well, you're just not gonna show to people who are using 4.0 Android, 4.1, 4.2, 4.3, 4.4. You're just gonna show it only to people who are using 5.0, right? So it really depends on how much time you have. It really depends if you are doing application for yourself or maybe somebody else, if you want to earn money and other things like that, which version you want to choose. I think that it's best idea, at least for now, to choose 4.4 at least. But for our programs, for our course, we're gonna choose 5.0, okay? In one of the lessons, I will show you how to support older versions, how to use support libraries and other things like that. But if I had to do it in every possible lesson, we would have to focus on that thing. So it would be just lose of time, right? So let's first focus on using the newest features, on old features also, because old features are also available in the newest version, right? So we're gonna choose 5.0 in our situation, okay? And then we just gonna click next, and as you can see, now we have to choose something what is called activity. Activity is just the screen that you see on your smartphone. Why it's called activity? Because we can do only one activity at one screen, right? You cannot do many activities at one screen. You have got always, when you swap on your smartphone, you're gonna go to another screen, right, to another activity, and you're gonna do something else, another activity there. So that's why they call the screen activity. So we can choose, for example, blank activity. Now here we click next. Here we should name our activity, so we're gonna call it, for example, main activity, and we're not gonna change here anything. But when you change here, as you can see, the name here, you're gonna change also the layout name and many resource name. This is the name of files that are connected to this activity, and this activity name is really the class that is gonna be created with this name that is gonna represent the screen, and later in the future lessons we're gonna edit it, right? We're gonna add something to it. Layout name file and menu resource name files are also places that we're gonna talk about in future lessons. As the name suggests, this guy is about the resources that you can add, for example, images to your applications. Layout name is about the layout of your application. Here you can call your activity, because if you called every activity main activity and you had more than, for example, 10 activities in your applications, then it will be hard for you to choose them from drop down menu later in your project. So you can call it whatever you want right here, right? Whatever. And now when we click finish, as you can see, we are creating our first project, and we can wait a second. As you can see here, we have got some preview menu, and we can run this program, emulate it, and other things like that. But all these things we will talk about in the next lesson. Thank you very much. Hello, today I will tell you how to change the theme of the Android Studio. So how to change coloristic of your IDE. In order to do it, you have to go to the file, then to the settings, and as you can see, there are lots of settings you can choose from here, but we're gonna focus in this lesson on the appearance. And you have got here something what is called user interface options. Here you have got something like theme, and as you can see, by default it's set to Dracula. As you can see, this is very dark theme, right? And I really like it, and I really also I would like to invite you to use it. Why? Because it's gonna save your eyes. Okay? Why? Because when you are looking at white color for a very long time, your eyes gonna get hurt, and you have to remember that as a programmer you're gonna spend programming lots of time, and if you want to have your eyes healthy, you should use dark themes. Okay? But you might not like it. Okay, you might be, oh, I don't care about eyes anyway. So then you can choose, for example, the IntelliJ. And now when I click OK, as you can see, everything is so bright. Okay, it's just up to you, right? What do you want to use? Now the code looks different, right? We can go back to the Dracula, and as you can see, it's now dark. Everything is different now, right? I prefer Dracula. We're gonna use Dracula because I think that the health of your eyes is really important, and that's how we're gonna use it in our future lesson. And well, you can of course change here many other things. Just read what you can change here, right? Because it's just up to you if you want to custom your appearance of your IDE. Here you can do it. That's just easy, you can just click tick and just untick it, right? Let's focus on more important things. So I invite you to the next lesson. That's all. Thank you very much. Hello, today I will tell you how to update Android Studio and its software development kit tools. So in order to do it, you just click help and then click here check for update. You click update now and everything is gonna be updated. As you can see, updates are available for Android Studio software development kit and tools, and it ensures you have the latest features and enhancements. So it's very important to download it, right? So you're just gonna click update now and everything is gonna be okay. But unfortunately, it's not enough. Why is that so? Because when you go to, for example, a website like that, as you can see, there are many versions of Android, right? And when you look at this table, here you have Android version, time of release, API level, name, and build version code for programmers like us. As you can see, there are 23 versions since 2008. In 2011, when you look at here 1, 2, 3, 4, 5, 6 versions in 2011. Right now it's a bit slower, like 2 versions per year, but still, as you can see, there are many updates to Android, right? And you need to update to the newest version, but you also need to support the older versions of Android, right? Okay, so how to do it? You need to download the older APA, you need to download older platforms, and in order to do it, you should go here to that guy here, SDK Manager. When you click on it, as you can see, now we have got on Android 6.0 here, right? When you click on show package details, as you can see, Android 6.0 platform need to update this. Here we need to have two updates for something what is called system image and Google APIs. What is Google APIs? Google APIs is needed if you want to create some applications using the Google services, like for example Google Apps, right? The system image is used for emulating the smartphones, because it's not possible to have every possible smartphone, right? Every possible size of smartphone, every possible version of a smartphone in your room and then test everything manually, right? So we have got something what is called system images, and as you can see, we can update it from here, or we can download other system images, for example for Android TV and so on. But we'll talk about system images more in the lesson that will be specific for emulating. And here we have sources for Android. So it's good idea to choose at least, when we look for example to for example 4.1, right? That's all. And when I click apply, everything from here is gonna be installed, but system images. You can choose system images manually because, well, you don't need all of them, and really it takes lots of time to download all these things and install it. So that's enough, right? You click apply, it's gonna install it. It's also a good idea to update your Android Studio, so help, check for update, click here. This is gonna be checked also automatically, so you're gonna see here a very big tooltip saying that, hey, it's a good idea to update your Android Studio. So when you click on it, it's gonna update it. You're gonna see it also here. Most time it's gonna inform you, hey, there is a new version. You can also click here, check, and then update now. So in order to do it, you just click update now and it's gonna update it, okay? So that's nothing hard if you know where it is. So you just click it, you update it, and you need to remember, always keep everything up to. Let's go to SDK Manager again, and let's go to SDK Tools tab. As you can see here, you have got even more options that are connected to tools that are gonna help you, like for example Android Support Library. Android Support Library is needed if you want to support older version of Android newest features, because you can implement many of them, not all of them, right? Because it's not possible, for example, implement Bluetooth in very old Android version, which is not possible at all. But there are many things that you can support, even if it's only available in newest version of Android. The problem is that you're gonna have to work in order to do it. So no, that's not so easy. Okay, so here is also Google USB driver, which is worth installing. This thing is gonna allow you to emulate your application that you're gonna create on your own phone, for example, right? There are many other things, but if they are gonna be needed, I'm gonna show you how to install them in the specific lesson. Okay, so for now we're gonna choose this, click apply, and we just gonna let it install. Okay, I will do it later. I would like to also show you something what is called Launch Standalone SDK Manager. And because this is the standalone application which you can use to update also everything. You can click on update and then it will update everything that is needed that needs updating. And you can also choose here Android Studio versions, right? From here you can also choose here something what is called samples for SDK. This is very cool, because if you choose this guy, then you will see how professional programmers are creating using newest features some apps. Okay, so that's also very nice. and well, everything else is the same, right? But you can click, for example, new here, and everything is gonna be installed for you. And it's a good idea to do something like that, but the problem is that if you have very slow internet, it's gonna take lots of time. It's also gonna take lots of time if there is something, there is an update for even things that you never gonna use. So, you know, select things that I said about. So, and always look at the chart like that, right? So people too, when you're supporting Android Studio 4.1, when there is 9% above 5% of people, then it's good idea to support the Android Studio version, right? I mean Android version. And now it's not about lesson, but it's good idea to listen to it, because you might be now like, hey, is that course out to date? Because, well, maybe it's 2017 now when you're watching it. Yes, it's up to date, because I'm trying to teach in this course something what is more important than newest features, because so many people will never maybe use newest features because they don't need them, or you know, they will just not be supported in older versions, and there will be 10 tons of work and other things like that. There are just some features that are very often used, and they are gonna be shown, right? That's the most important thing. And the thing that you want to learn as a programmer is how to connect all these things here. When you click on the button, you want to know that somebody click on the button and then somehow you know, react to that clicking, right? You want to see where the guy is on the map, Google map or something like that. You want to know how everything is put here in the folders, what is the Gradle, how to use this layout here, what are they, what are differences between them, what are these widgets, text fields, containers, other things like that, right? I think this is more important, and when you know it, when there is just a new feature, you're gonna learn it very, very fast without any problems. So that's only the lesson for right now. Please update your Android Studio. Thank you. Hello, today we are going to talk about Android Virtual Device Manager. As the name suggests, it's gonna allow you to manage virtual devices. But what are virtual devices? Well, you know, it's probably impossible to have every possible smartphone with every possible Android version and with every possible resolution, right? It's not possible. That's why you can do something what is called emulation of Android devices. And in order to emulate an Android device, you have to use something what is called AVD Manager. When I'm here, as you can see, we have got here a tooltip, AVD Manager. When I click on it, I'm gonna open this Android Virtual Device Manager. You can also go to Tools, Android, and then AVD Manager here, okay? And as you can see, we have got here already created a virtual device which is called Nexus 5 with the API 23, which is Android 6 on 86, something like x86 processor. What does it mean? Soon you will know. It has got the resolution, the full HD, and it has got 400 and 200 dpi, which I will talk about later. And well, it has got some kind of other properties. It's like size on the disk, CPU ABI, we will talk about it soon, and it targets Google APIs. What does it mean? We'll talk about it. But this is a virtual device with some kind of properties like that, right? And you can now emulate it. What does it mean that you want to emulate it? It means that you want to imitate every instruction of Android system. So in order to do it, you're just gonna click here, play. And emulation process takes lots of time, because as I said, you have to imitate every single command, okay? So as you can see, it's taking lots of time. As you have probably noticed also, it took a bit too much of my recording space. That's why I will also show you how to create your own hardware, your own device, and we create it a bit smaller so it's gonna be visible in our recording space. And as you can see now, we've just emulated an Android smartphone, and you can do here whatever you want. You have got here a menu, and believe me, at the bottom of the smartphone you have got the typical things like the messages, internet, the camera, and so on, right? You can do whatever you want, almost everything like you can do on your own smartphone. Okay, so you can even log in here or you can even talk here, right? There are many options that you can use like on normal smartphone. That's why it's called emulation, right? You are trying to imitate everything like the real thing. Okay, try to do it on your own, but please be patient, because well, my computer is very good and that emulation process is not so long, right? But for some people it can take even 5-10 minutes. So you have to be patient. The cool thing about this emulator is that when you open it, you do not need to close it. So let's try, for example, run this application here from that is designed by default when we create the project. Let's click here, play, okay, this button here. And now, as you can see, we can choose from the running devices the emulator that we just started. And now when you click OK and we open it, that our emulator that I didn't close, I just minimize it. We're gonna wait a few seconds, and well, it's gonna take a few more seconds. As I said, emulation process takes some time. Unfortunately. Okay, come on, go on. Oh, okay. As you can see, we have got here our emulated application. Okay, hello world, right? The toolbar here, and other things like that. So yeah, it's working fine. You have got here a monitor that is telling you what you are doing. As you can see, you have got here some kind of information about memory, CPU, network, and other things like that. Okay, so if there are any errors, you're gonna see them here, and so on. Okay, something is wrong with, maybe I changed something, that's why I have to click here clear cache. Clear cache is something that you might want to click sometimes when Android Studio has some problems. Okay, and well, it's working, right? Let's go back to our Android virtual device manager, and now let's create our own virtual device, because well, as I said, you want to emulate your application on other Android devices and on other versions of Android, right? Because well, you do not know how it's gonna work on other Android versions. So in order to do it, I click in the left bottom corner a button, create virtual device, right? And now, as you can see, I can choose from many available devices. Well, let's for example choose Nexus 4, right? And let's click now next. As you can see, now we can choose here, for example, a Marshmallow Android, which is Android 6, AP level 26. And we have got here a few weird things like x86, RMIB V7A, x87, x64. So well, what the hell? What's that, right? You might be asking. Well, this thing is application binary interface. But what's that? Why do we have 4 versions of Android 6? When I click here, as you can see, you have got for each Android version, right? And as you can see, we can emulate every possible Android here. 4 versions, at least 4 versions, right? What is that? Well, in order to understand it, you have to know that smartphones have different processors with different architectures. Different architecture means a different structure of processor. It also means that the processors use different instructions, which are commands, and that makes your computer working like it is working. And these commands are written in binary code. And that difference between architectures creates a problem while you want to run a program created for any Android application. You have to emulate a device, which means you have to imitate every instruction from Android processor architecture. This takes lots of computer power, and that's why every time when you want to emulate Android device, it takes so much time, right? And the most widely used architecture is called ARM, and this is that one, ARM AAB or something like that, V78, okay? But smartphones have also processors created by Intel, which are called Intel Atom, and these are these guys, x86 and x86-64, okay? And well, Intel Atom architecture is very similar to the one we use on our personal computer. And that's why if you are using PC to emulate your Android application, it's better to choose Intel architecture, Intel ABI, okay? Because these architectures are very similar and your emulator will run faster. However, you should always, at least when you are ready to publish your Android application, test your app on ARM architecture, so this one, okay? Because Intel processors are rarely used, okay, and very rarely comparing to the ARM, at least for now. And you might have a problem with your application on ARM architecture that won't be present on Intel architecture, right? However, this situation is extremely rare in a way. But well, you know, for emulation, for everyday emulation, you should choose this one, and at the end you should check it if everything is working fine here, okay? And you might be asking also, what is the thing with Google API? If you do not want to use Google API, which is, for example, Google Maps, you do not need to install it, right? If you want to use it, then just download it. And so let's click here, show downloadable system images. Let's sort it by the target, and let's choose, for example, Lollipop, right? Yeah, it's very important to have Lollipop. So for example, this one, and we're gonna download it for the Intel because it's gonna run faster. Of course, you should download every possible Android version you want your Android device to run on, okay? So this is your task to do now. Let's wait a while. I will stop the recording. Okay, so as you can see, we've just installed Intel x86 Atom 64 system image. So we're gonna be able to emulate that image of system. And well, let's click finish. It's finishing the installation process. As you can see, now we can choose the Lollipop, okay? We do not need to show downloadable system images now here. It's on our list. Okay, so I can click next. And now we can choose the name of our Android virtual device. This name is just hint for us, okay? So when we want to choose from here, right? We will know which one we are gonna emulate, which device we are gonna emulate. And well, here we can change again the device, right? How it's gonna look. And again, we can change which version of Android we want to run on. Here we can scale our device, so we can make it a bit smaller, for example, or we can use the auto scale process that will just make it looking good. You can use the landscape view, the portrait view. You can emulate the performance a bit better if you use the GPU, host GPU, and well, you can use both of these guys. Well, you can check which one is gonna work faster for you, this guy or this guy. Maybe it's gonna work faster for you if you choose one of the options when you want to emulate your device. And you have got here also something that's called device frame. So it's just a device frame. That's the thing that is around the smartphone, right? So if you want it, you can choose it. If you don't want it, you can just unchoose it. So, well, let's do something like that here. 3 dp on device, 1 pixel on screen. This thing is gonna scale it to make your device smaller, okay? Because, well, right now 1 pixel on device, well, 4 pixels on device will look like 1 pixel on the screen, so it's gonna be smaller. Soon I will tell you more about the DP things, okay? This is the density independent pixel, but for now it's not important for you. I just click finish and just believe me that it's gonna make the device smaller, okay? So when I click play here, I will stop, and as you can see, this device is really smaller, right? And well, it's even too small for now. For the Nexus 5 it would be like something like that, so it will be better. But the problem about scaling is gonna show up soon. As you can see, everything is very small, right? But at least now we can see that there are buttons like that here, and well, you can see that this emulator of device is really imitating the real device. It's like the real one, right? Okay, so well, let's close it and let's create another virtual device, because I want to show you also that you can create your own hardware profile. Well, if you want to, create your own resolution, your own device that wasn't listed here, right? Because, well, it's not possible to list every possible Android device. You want to create your own one, right? You can call it here. We'll just call it test for our test purposes. Well, we'll make it 4 inches and we'll create here a resolution that will be good for our testing, okay? So 480 by 720. This is how much RAM we want to be used by our test device. And here we can choose if you want to allow hardware and navigation, additional navigation. You can choose it if you want, it doesn't matter really. There are also some supported device states like portrait landscape. If you want to support both of them, if you want to support cameras, sensors, these are cool ones, so you should choose them because you can emulate the GPS and other things like that. We'll talk about it in future lessons. And here is the default skin. I will not use any skin because I want to make this hardware as small as possible. It will not look also as good as the one that we've already seen, but well, I'm gonna use it just because I want to have it on the recording screen looking properly, okay? So I'm gonna click OK, and now I'm gonna click next, and I'm gonna choose Android with the version 5.0, okay? Then I'm gonna click next, and now I'm gonna just click finish. Okay, let's wait a second. As you can see, now we can run our new hardware. And as you can see, this device looks pretty different. As you can see, here are the additional buttons that we did not enable. They are here, but we cannot click them, right? You could enable them if you wanted. I don't need them. And now in every future lesson, we'll start our emulator from this position, okay? I will already have the device running, and we'll just test our applications like that. I will click here, play. I will choose this guy here, and I will stop the recording, so you will not use your precious time in future. And I will just show you the running app with new features that we'll create, right? And also it's good to know if you have got the Intel, that when you go to the SDK manager, you can go here and download something like that, emulator accelerator. Your devices will emulate even faster, okay? That's also a very cool feature if you have the Intel platform. You can also download all the system images from here, but it's gonna be hard for you to choose from very long list. So just download the one that you really need, okay? So that's all in that lesson. If you have any questions, feel free to ask. Hello, today I will tell you about the most important parts of Android Studio. I will quickly go through almost every possible thing in Android Studio, so you will understand what's going on in Android Studio. But I would like to tell you it a few times. Everything from this lesson is gonna be described better in future. This is just a quick look at the things in Android Studio, like for example, the project view, palette, and so on and so on. Okay, let's start. So at the top we have got, as in any big program, menus, and there are lots of tools in there, like for example you can create a new file, open a new file, reopen the project, close the project. This is very self-descriptive, really. If we need something from here, we're gonna use it in future, and at least you will understand when you should use it. So we will not focus on this part. The second thing is the top bar. At the top bar you have got the shortcut to, for example, as we learned, SDK Manager, to for example AVD Manager, but there are also things like you can, for example, play your device, launch the emulator, right? You can, for example, make the project, so you can compile the project without launching your application, right? And well, they are just shortcuts, and if you want to know more about them, you can just choose one of them. And as you can see, we have got a tooltip that says, hey, when you click it, you're gonna paste something, but there is a shortcut Ctrl+V that you should have already knew. Okay, so these are just shortcut buttons. But now let's go into things that are new. So here we have some kind of path to where we are at the moment in our project. So as you can see, right now we are in the content main XML. This is a file from our layout folder that describes the layout, so how things coexist with each other at our application. Okay, you can use this path to quickly go to another place of your project. For example, I want to go to the resource folder and then go to, for example, menu, and then I will choose the menu main XML. And as you can see, now I'm here. Okay, so you can quickly choose something from your project here, but also you can use this Android view of your project to go to, for example, the menu and then go here. As you can see, when I change something here, it also changed it in this place. If you do not see this project view, you can click here, or if you do not see anything, you can click here. And as you can see, when you do something like that, every possible menu like that is hidden, so maybe you click it by mistake. But you can also click on it one more time very slowly, and you can for example click here on project, and then it will reopen your project. As you can see, that's how you can close and open it again. But let's focus on this project menu again. In this project, as you can see, you have got many folders, but all these folders are connected to Android creation for creation of Android application. You can change this view to many others. We'll focus on Android and project one. When we go to the project, as you can see, this is the true structure of your project. You can go to the app, for example, then go to the build, and here are files that you should never change, okay? Because if you change something here, your program might stop working. You can click here with the right mouse and go to the show in Explorer, and here you can see all the things from your app. Okay, right now we didn't generate anything because, well, we didn't run our app, but you can go, for example, to source, main, resources, and as you can see, here is our layout. So we can change everything also here, but IDE is just helping you. And then you can go to the source file, then main, and you have got everything here from the view of Android. Okay, this is the resources, so the things like, for example, drawable things, so images, layout, as I said. This is files that's gonna describe the layout of your app. menu that is the file that is there are gonna be files that are gonna explain the menu. Mipmap is gonna show, as you can see, these are some kind of images that are gonna be shown as an icon for your application. And then you have got the folder that is called values with, for example, colors, XML, dimensions, strings, styles. These are some kind of settings for your applications. Like, for example, you can choose the primary color for your application, and things like that are written in XML file that I will talk about later. As you can see, there are files like XML, and shortly these are files, the text files that are using the extensible markup language. So it's using something like tags and attributes to talk about things in your application, okay? And this is mostly used only for describing your app, okay? If you want to program, you have to go to the folder that is called Java, then go here, and then, for example, choose this file. And here we have lots of code that was generated because we used the wizard setup, and it was generated by it. We'll, of course, talk about that code here in future lesson. So, as you can see, you have got two places. You have got a place where you gonna just talk about your layout, right? You're gonna create the code for your layout, and you have got another place where you're gonna code this layout, where you're gonna create some algorithm, right? This is very important. And as you can see, you can jump from design to text preview. And when you are in the text one, you have to just write things here and, well, hope that everything works fine. But if you choose here the preview thing, as you can see, you can instantly see on the right side the preview of the XML file that is here. So when I click on text view, as you can see, this thing is getting highlighted. Pretty cool. And if I add anything new, so if I go, for example, to design view, and then I add here a new medium text, then as you can see, when I go here, the code like that was generated. And now, of course, also when I choose the other guy on your layout, other things are gonna be highlighted. It's very, very useful for debugging of your applications, okay? So if you do something like that, you're gonna just create another text view, and, well, we can change the attribute here. We have to change the attribute of ID because this attribute describes as an attribute the unique identifier. And as you can see, now we have got two guys like that, right? Please notice that in the design view you can change the place of things, right? In the preview window you can just click and see where things are spotted in the XML file, and that's all. You cannot change the place of it, okay? That's very important. The also important thing is that when you put something or you delete something, it's gonna be also deleted or put onto the component tree here. Component tree that describes how are components related to each other. If you did something in Photoshop, this is very similar to the concept that is called layer, okay? There are just layers, and you can create many layers. You can have many relative layouts next to each other, or they can be in one another. However, let's not focus on this, because after this lesson you should just know where things are placed. So when I click on any of that thing, on any of that component, it's gonna select and highlight it on the design view. And as you can see, we have got here also something what is called properties. So the things that are describing attributes that are describing your button or your text. So you can find any property and change it here. When you click on properties, just to focus on this menu, okay, and when I just start typing, you can try to find something like, for example, color. And well, it's not the shadow color we want to, for example, change, but just the text color. And when I type here something, then this color is gonna be applied. If you do not know how to apply it, you can click these three buttons, three dots here, and so now you can easily choose the color you want, like for example, I know, red, right? Or you can choose one from the static one, from the colors that are, you know, already registered to some kind of hexadecimal values. So let's choose the red one. Okay, let's click OK, and as you can see now it's red. And when you go to the text view and we choose that guy here, and as you can see, we have got now here an attribute that was added automatically. Okay, so that's very cool, right? You can choose easily from the component tree one of the components that have been just added, and then you can change any property of it without going here. Okay, this is cool because, well, it's hard to remember every possible property, right? And well, that's how you use it, right? And there is one more thing you should know about, is that preview place here. You can, for example, enlarge to have, because right now this is scaled, right? It is minimized. You can make it like it would look in real life, for example, your app on a device. You can change the device you want to run it on, right? You can, you know, running on even Android TV, whatever. So you can do something like that. You can also, for example, switch to landscape. So you're gonna see how it looks like in the landscape view. You can also, for example, preview all screen sizes. Hey, I would like to see what's gonna happen with the elements on my type of layout on other devices, and so on, right? Let's click here, none. You can change here. You're gonna be able, for example, change it and translate your app. Here you can check your Android app on other versions of Android, right? How it's gonna look there. And well, as you can see, there are many things to do. We're gonna do them in future. Let's also not forget that we are using the IDE to make our life easier in writing the code. So if you make even a small mistake, it's gonna be shown, as you can see, like that. So also, even if you do not notice something like that, or that mistake is gonna be harder to spot, if you click here on the make project and we wait a second, we're gonna see something like that, error. The semicolon is expected. So when you click on it, we're gonna jump to that place. Okay, so even if you are in another file and you do something like that, you're gonna jump to the place where this error occurred. Okay, very, very, very cool. You have got also something what is called Android Monitor, where you can read the logs of your application. This is used for debugging that we'll talk about in future. And you have got also something what is called a Gradle. Gradle is something what is helping you. It's a build system, so it's gonna have information about how to build your application. Like for example, here you can specify the minimum SDK version. You can choose some dependencies, so the libraries, programs that need to be compiled, so added to your program, otherwise your program will not work, and so on and so on. We'll talk about how to add things like that in future. I think these are the most important things that you should know after this lesson, and as I said, we'll talk about it even more in future. That's all. Thank you very much. Hello, today I will tell you what is XML and how it is related to programming, to creating applications in Android. Let's start from basics. I've just created a text file, so it has got an extension, txt. But you might be thinking now, hey, we should be talking about XML files. But these this is very connected topic, okay? Why? Because the XML is really something what is called extensible markup language, okay? And what does it mean? What does language mean? Language means that somebody is gonna contact with somebody and there are some kind of rules of contacting, right? And these rules are markups. Markups is really tags that can be extended, that can be invented by you. So let's invent something. So let's say something like postcard, okay? Let's do something like that. Let's create more than one postcards. So this thing is called tag, okay? This is a markup. And in order to start tag, you have to use this sign here. And in order to end this tag, you have to use this sign here. And between this tag and the closing tag, you can define now postcards, okay? You can do something like, for example, hey, let's create another postcard. And let's, for example, have data about the postcard. And let's, for example, inside this data have name, for example, my name. Oh, and let's have a surname. So, for example, my surname. And let's copy it. And we could create right here another guy, right? It's up to us what we're gonna create here, because it is called extensible markup language. So you can invent your own markup language here, okay? But you have to use some kind of rules, right? So you have to create opening tags, closing tags, right? And you can give, for example, additional information. So for example, this postcard is gonna have a color, and this is gonna be colored in red. This is gonna be colored in, for example, yellow, right? It really doesn't matter. We just invented an attribute. Attribute is just additional information about a component, about the tag, about element, right? Whatever you want to call it. So we've just invented something like it, and it really doesn't matter what it means in the text file, because now you have to invent, you have to create an algorithm to interpret it, okay? So here we have an XML5 with tag that is called relative layout. It has got many attributes like padding bottom, padding left, like for example text color, which is gonna say what is gonna be the color of the text view, and so on and so on. And all this XML5 is gonna be interpreted by the program, by the algorithm that was created by somebody, right? It's gonna just interpret everything, and it's gonna change this text file into this design. So the cool thing about XML files is that you can define here something using some kind of rules and create your own tags, right, and attributes. Well, in Android, we won't be able to use our own tags or our own attributes. Well, we could create our custom one, but it is advanced topic. But we can use from the one that are already interpreted by the Android program, Android algorithm, right? So if we wanted, for example, change this to XML5, we just need to change the extension, okay? And now we can open it with Notepad, right? And we just need to delete this thing at the top, because, well, this is just a simple text, so it is not gonna be interpreted by the rules of extensible markup language, right? So we have to delete it. We should also do something like that. So we should define what XML version we're gonna use. Where it is here, like that. And we should change the format to coding in UTF-8 like it's here, right? And we just created our own XML file that can be interpreted by others, and well, that other people knows what will postcards mean for them, right? They will know what data will mean for them, name and surname. They will interpret it however they want. Okay, so Android programmers know what is relative layout for them, and they interpret it so that it looks like that here. But still, you don't know probably what is that thing, that XML, NS, and that column here, and Android column layout width. Why do you have to add before each of attributes something what is called Android or app or tools? What is that thing? Well, this thing is called a namespace. What is a namespace? Well, this is a space, this is a space. Let's call this space A. This is gonna be called B. And namespace is just a space with names. So, for example, with the attribute names, right? That's true. We have got layout width, layout height, right? It's a namespace. It is in the namespace that is called Android, right? Let's think that this is an Android namespace, right? For example, and in Android namespace we have got many attributes. Like, for example, when I do something like that, Android, and we have got here, for example, background, right? So we have got there, for example, background. Let's try to write it here with my superpowers. Okay, let's imagine that I just written here something what is called background. And the cool thing about spaces is that when you create your own one, for example, B, you can now also create here something what is called background, like another attribute called background. And because of it, there are not gonna be problems with interpreting later, right? Because this background is inside this namespace, this background is inside this namespace, and if and they can coexist with each other, right? Because we'll know from which one we want to take background, right? This background could be interpreted by one program different way, and this background could be interpreted different way. Because of this namespace, because of this definition, XML, NS, colon, Android, we can create our custom attributes that will be called the same like the one that are used here, like padding top, padding right, and so on, but they will be in our own namespace. That's why they created something like namespaces here. And as you can see, it points to some kind of URL, but well, this is just here, so when you change it here, it's not gonna work at all. This is some kind of just unique identifier, that's all. This website could have potentially some kind of description of the attributes of the tags that you can use, but they didn't create it. But for now, this is just the something like, I know, unique identifier. So they could do something like that, right? And this is unique, but they decided to type here some kind of domain that is unique for them. And now, because of that unique identifier, any program that is gonna interpret this XML5 for creating Android applications, right? It's gonna use it as a reference, right? So you have to add Android and then the colon, because otherwise it's not gonna work, right? Because the interpreter doesn't know the layout width without this the namespace here, okay? So the interpreter, the parser, this is called parser, right? It's gonna go line by line, and if he knows about layout width, it knows only about layout width that is from this namespace. That's why you have to add Android colon. And well, of course, because of it, you have got also very good and easy to use tooltips, right? Like that tooltip panel. Okay, so why somebody bothered to do something like that to create it, the design in the XML5 and the code in another file? That's because of that that's because of the thing that I have just said, to split the XML file and the Java file. They are splitted now, right? So the coder can focus on code, and the person who is responsible for creating design, the person who has got the ability to create a nice design, can just focus on creating design. He doesn't care about coding. So two people can work on one Android applications with different skills, right? And that's why it's also very cool, right? So you can just, Control A, Control C, and copy it, and somebody else can use your layout. That's very, very cool, right? It doesn't matter what code was written behind, because you can create your own one, right? Just for this design. That's really, really, really cool, and that's why it was created like that. So in the future, we're gonna learn tags, we're gonna learn attributes that you can use, and that's all in that lesson. Thank you very much. Hello, my friend. This lesson is very, very important. After this lesson, you will know how to get components, widgets, layouts, whatever you want to call things that are placed in this palette from the view. So from the place where you can see it, right? So when you create in, for example, in the XML or in the preview window, to your code. So you can finally, for example, do something with it, right? Because hey, when you put something here, for example, a button that will, for example, have a name, right? Like next quote, you want to see another activity, right? You want to see another code or something like that, right? It really depends on what you want to do, but you want to react to things that happens, that somebody do with your application. And in order to do it, you have to know how all these things work in background, okay? Before we do it, I want to tell you a few things. Okay, so anything from this palette is really a view, okay? Why do I think so? Well, when I go here, and for example, we have got here a text view, and when I use the control shortcut and then I click on the text view, as you can see, we can see the class of the text view. And as you can see, it extends the view. And when I click on it, it's the last class, which is called view, okay? Well, let's check the relative layout. View group, view, okay? So everything that is put here is really a view. Why it's called view? Why? Because you can view it. Okay, so any element that you can view is placed in the view class. This is very useful information that we're gonna use soon. The next thing is that when you put something here like that, you not only generate it in the XML, but you also generate some kind of reference, okay, inside the R class. When I use the shortcut Ctrl+Shift+N and I type r.java and hit enter, as you can see, we have got a generated class, which we should not change, right? This generated is gonna be changed every time you add something new to your view, for example. And as you can see, do not modify, do not do it, because you can have problems with your application later. It's gonna generate here a reference that you can refer to later from your main activity that we'll talk about soon, okay? So you might be asking yourself, what is that R class? Why it's called R? It's called R because it stands for resources. And as the name suggests, it has got all kind of resources inside properties that you can access from this place here, from the main activity, for example. Okay, and well, you should know that you can access it using, for example, when I double click on, for example, new button on, when I find the ID here, using this name. You can change it. Let's change it, for example, to next quote button, okay? So it will be easier for us to access it. Let's change the text also to, for example, next quote, like that, okay? And as you can see here, also this identifier is shown, right? You can, you do not need to, well, if you do something like that, it's also gonna generate inside the R class your identifier that you can access later, okay? From the XML file, you can do it also. Okay, so now we know these things. We should go and somehow access it, okay? How to do it? Well, we need to know a few things about activities before that. Activity is just a screen, okay? A screen that you can see, that you can use, that you can play with on your, for example, smartphone, okay? That's the activity. And that activity has got something what is called life cycle. And the first cycle is when your activity is being created. And this method onCreate is gonna invoke every possible instruction here when your activity is being created. So when somebody just open your application, okay, before even showing it to your user, it's gonna invoke these instructions that will be placed here, okay? So this is like the main method for the Java, okay? You want to put here the code that should be executed as the first and the most important code to create your application. We'll talk about life cycles later, what you should put in what cycle and other things like that. But this is the basic one. This is when your application is being opened, okay? Let's talk about this onCreate method a bit. It has got one parameter that stores information inside a bundle, inside a package, and this package is called saved instance state. You can use that bundle, that package, to send information between many activities. So here in the first line, this is very important line because if you do not use it, you are invoking the method that was already implemented in the app compact activity. You can go there by, for example, clicking here and then doing something like that. Right click, then go to declaration, or using the shortcut Ctrl+B. And as you can see, this method did something like that. Install view factor, whatever it is, it did something, right? When we go even deeper, because as you can see, they invoke here again onCreate method, it did even more things, right? And when I click on this, it did even more things. And when I do something like that, it did even more and more things, okay? So all these conditions and all these things that were done here has to be invoked. If you do not do it, you would have to, copy all these things, all that code here, and you would need to always check if the creators of the Android apps wouldn't add something new here. You will need to update your onCreate method every time if somebody updated, for example, onCreate method here, right? That's why you just invoke here always the onCreate method that is in the higher place in the hierarchy, okay? That's very important. Then you set the content view using our resources class, and then you use the property layout to activity main. So you set it to this XML file, okay? So this is the first thing that will be shown, and this will be set as our first view. Then we have got some generated things. We could, delete it, or we could just look at it and get some information about how to code in Android. And these methods are also created. You can remove them, or you can, use this to, for example, look, hey, there is a method that is called onCreate options menu. So, so it's gonna be invoked when the options menu is created. So I can add some items there. That's how you should think when you are programming, right? But we don't need these methods. We should focus on onCreate method, and we want to now we want to search for the view, for the component from our content main XML that has got ID that is called next code button. And we can do it very easily. How? We can just type r dot then ID, then access, as you can see, next code button. And now we have got it. The problem is that this is integer, right? When we go to the R class, Ctrl+Shift+N, as you can see, everything here is integer, okay? So we need to somehow translate this integer using the method that was created in order to do it. And this method is called find view by ID. So you send only this ID there, and this method is gonna take care of it. What does it return, this method? When we go into it, as you can see, it returns view, okay? As I said earlier, every button, text view, every layout, whatever is really a view, okay? So it returns a view. So we can do something like that. View next quote button equals find view by ID, like that, right? The problem is that, hey, I don't want to have here view only. I want to have access to every possible method, every possible property that is, created in the button class. Because, hey, I just got here a view, but I want the one that is button. So I'm gonna change the type here to button, but the problem is that, well, we need to first import it, the button. We can do it like, for example, clicking here and then import class when we hover on over that. Hello, my friend. In the last lesson, you learned how to get components from the view into your code, into the activity, using this line of code. Now it's the time to react to interaction with your application. So you want to react when somebody click on the button, you want to do something, right? So you want to catch the event. You want to listen if something did not happen in your application. And that thing that the listens to that, interaction with your application is called listener, okay? So in order to do it, you have to use the component you want to listen at, then use the that and use the method that is called set. And then, as you can see, you can listen for many things, but we will focus on this lesson on the set on click listener. Okay, so you have to set the listener, and as the name suggests, again, this thing listens if something did not happen in your application, and in our situation, it listens if the on-click event did not happen, okay? That's how it works. And now you have to send here the implementation of the method, which is called onClick. How do I know this? Well, I can do something like that. Ctrl+Q, when I double click on it, Ctrl+Q, and I can get documentation of it. As you can see, I need here something what is called view on click listener, okay? Well, what is that view on click listener? Let's try to find out by, for example, do something like that. Let's type it, right? View that on click listener. And let's just Ctrl+B there. And as you can see, view is a class, right? And inside this class, we have got the public interface that is called onClick listener. And inside of it, we have got the method onClick that is required to be implemented, because that's how interfaces work, right? If there is a method inside an interface, you are required to implement it. And everything from the method, right, from the onClick is gonna be invoked when somebody clicks on the, for example, this button, right? So we need to implement it. How to do it? Well, we can implement this interface in the new class, or we can, for example, create an anonymous class. Well, let's do it easier way for a second. Let's do it by, for example, creating a special class that we'll call, for example, next quote button class, like that. And it's gonna implement this view on click listener, right? Like that. So we can now see that we have got here an error because it says that, well, must either be declared abstract or it has to implement abstract method on click. So when I click here at the class name, as you can see, we have got here the error bulb, and we can click implement all methods. And we can choose which one we want to implement. I can click OK, and we have just implemented it, right? So now we just need to do something like that. New and next code button class. So we just inserted here the object that of class that implements the view on click listener, right? And it's gonna work fine. We can now, do some things here, and it's gonna be shown when somebody click on the next button, because the listener, so the guy that listens if something did not happen, has been set, and it's been set to do action later. When something happens, it's gonna do this action. There is also some generated code when we created our activity that looks like that. As you can see, it searches for the view that is called like that, and it is a floating action button. What's that? Well, it is that thing here, and when you click on it, we can see something what is called a snack bar. Snack bar is an object that, as you can see, you can eat. It's like a snack bar, right? You can eat it and do something like that, and it's gonna be removed. You can also wait a second, and it's also gonna disappear, but you can edit, right? That's why it's called snack bar. And this is a class where you can, give some info to your user. We talk about it more in the future, but well, let's use this, right? Let's check if our code is working. So let's do something like that. As you can see, here we have got a red error, and it says cannot resolve symbol view. It's because, well, here is the view is called v, not view. That's why you have to send it here v. If you want to know what you want to send there, you just type the Ctrl plus Q, or I don't know, Command plus Q on Mac, and as you can see, it takes as the first parameter view. Okay, so that's how we do it, and well, we can just run it. So let's do something like that, and then click OK. And now when we click on our next code, as you can see, we have got here replay. It's with your own action, right? So the information from here. Okay, so it's working, but you have probably noticed that these guys did it a bit different way, right? And what the hell is that? That view, that arrow, where this thing is called the lambda expression, and when you click plus, you're gonna see how it's truly looking like, okay? If you do not know what is lambda expression, please go and watch my course about Java. If you don't know what is anonymous classes, you should also go there, because I definitely explain it there better than here. But I will try to again explain what is anonymous class and how it's possible to do something like that here, and why it's even created like that, not like that. Well, the first thing is, imagine that you have got many buttons. You would need to create for every button a class. Whoa, so you would need to create for every possible button, for every possible, click event, you will need to create a special class. That would just take lots of time, right? So in order to, if you do not need that class for anything else but for just implementation of this method, it's just no sense to create a class like that, right? It's enough to just create an anonymous class. An anonymous class is just something that doesn't have name. So like that, you just type the interface you want to implement, then you do something like that. I've just created an anonymous class without implementation of methods from this interface here. So as you can see, when I click here, I have got this red bulb, and I can implement all methods like that. And now it's working fine. Now I can, do something like that again. Like, use that snack bar, bam, and I need to just place here something for my own action. I can just click Now, okay. Wait a second. And now click here, and as you can see, we have got this message now, right? So we've just created an anonymous class with the method here. So it's just faster now. Okay, so that's how listeners work. You are setting on-click listener, and then you set the implementation of the anonymous class with the method that is gonna be invoked when somebody, for example, click, right? You can set many other listeners, you can read about them, or you can watch my future videos, and I will surely talk about some other. Okay, so there is one more thing you should know. Right now, we are accessing the next quote button from this scope, right? But the problem is that what if I wanted to have, for example, many methods here in the main activity, and in the future it will happen. That's because of that, you should always have the button or any other things that are taken from the view created as members. So you should do something like that. Button, next quote button. Okay, so it's now a member, is a property of the main activity. And well, it's a good idea to keep things like that private, because then you are following the principle which is called encapsulation, right? So your code is more close. It's not, the people are not gonna be able to, for example, get this button without the permission, and so on and so on, right? So it's a good idea to keep it private and do something like that. It's also a good convention to have your variables in Android that are private and that are members called with the suffix which is called M. So you should do something like that M next quote button. So from it stands, M is short for member, okay? And well, as you have noticed, when I change here something, I should have also changed it in other places. So in order to change it in many places, you can use in Android something what is called refactoring. You can go here, refactor, rename, and then you can just do something like that, and it's gonna change it in every possible place. So that's how I just done it. And because of this approach, now when I create another method, and in future we will, I will be able to access this button from also other places, right? I will not be stuck to only this method. Okay, this is very important. I think it's good to know it. Okay, that's all in that lesson. Thank you very much. Hello, in the last lesson you learned how to react to the most frequent event that is called click. When you click, you can react to it and show something to the user or do something, right? And you did it the hard way, using the set on click listener and then using the anonymous class and so on, okay? But there is a very simple way to do it without even knowing about anonymous classes. Oh, you might be angry now, but don't worry. Soon I will tell you why you have to use sometimes this approach and why I started from teaching you this way, okay? So let's go to and let's create another button, okay? So let's do something like that, and let's, for example, create a button that will be called previous quote, okay? So we want the previous quote right now, like that. And well, we need to go to the design and set them like that, for example, right? Okay. And well, we've just created a second button, and how to handle the previous quote button. Well, we will do it from the XML. I will type now Android namespace, and then I will just use onClick attribute. And now you just need to think of the name of method that will handle the event. So for example, previous quote button click handle. Okay, so handler is something that is handling the click previous quote button. I think this name is self-descriptive, it's gonna be good. And now you need to create it inside the activity that is connected to this XML file. You can do it manually, or you can just go hit here and click create on click event handler, click OK. And as you can see, we've just created a method where you can put, for example, I don't know, another snack bar, right? And says here something like I am from previous code button. So we know that this is that one. Oh, and here we need to change the name of variable because it's different now. And well, that's all. We just need to run our program. Okay, now let's click previous code. As you can see, it's working. This one is working. And now you might be like, now explain to me why. Why did you talk about set on click listener when it's so easy? Well, there are a few reasons to it. The first one is that, look, Android colon on, as you can see, well, here maybe, Android on, as you can see, we have got only one event that we can handle from here, okay? This is the main reason I told you about the click listeners, because, well, here, as you can see, we have access to many other situations, right? And you have to, you know, be able to handle all these events if you want to handle them, right? So it's good to know how to use it. That's the first thing. Don't worry, there are more to it. The second thing is that, well, it's slower. Why? Because now I will tell you how it works. There is something what is called a Java reflection. Java reflection is some kind of methods from a library that is called reflection. And these methods can analyze a code and create its own code depending on what code it's gonna meet. Okay, so that reflection is gonna read, for example, this XML file, and when it sees something like that on click attribute, it's gonna want to find inside your activity that is connected to this XML file the previous code button click handler method. And this method has to be like that. It has to have the name like that. That's the first thing. The second thing is it has to be public and void, and it has to have a parameter like that, okay? If it's not looking like that, it's not gonna work. And it has to be inside the activity that is connected to this XML file. So this is slow, okay? Because right now there is a code that is gonna write a code depending on the code that was created by you, okay? So it's a bit slower. Well, maybe for creation of one or maybe a few things like the events like that, it's not gonna slow down your program, but it's slower, okay? And the third thing is that, as I said, it has to be inside this main activity that is connected to this XML file. What if your program is gonna be in future bigger, right? You're gonna have something what is called fragments, which is something very similar to activity. It's like a sub activity. We'll talk about it in future. And you want to have, you know, in many places, listeners, they will not be set in you don't want to have method like that inside, you know, this activity, for example, right? Then you have to know how to do it that way. So, you know, if you have a simple applications, why not? You can just go ahead and do it that way, right? Just do it that way and just handle things, and you do not need to worry about you know, creating something like that just for the sake of handling the event, right? It's just taking lots of time to create a private variable, then getting the view, then setting the click listener, and then doing that. When you want to just, you know, do simple thing, I think this is a good solution, but it's not a good solution for every possible situation. So That's why I told you about that solution first, because this is the universal one, okay? That's all in that lesson. Thank you very much. Hello, today I will tell you what are layouts. Layout is a visual container that holds elements. It lay out things inside itself, right? So this is a layout, and each layout can lay things a bit different way. For example, linear layout will lay everything linear way, so one by one, right? You can see here something like that it's one by one, vertically, so it's gonna be from up to bottom. If you use the horizontal one, it's gonna be from left to right. If you use, for example, relative layout, it's gonna be relative to something. Every element is gonna be relative to something. So for example, this previous code might be relative to this next code, or it can be relative to this frame, or it can be relative blah 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 blah, right? You can do whatever you want. And now you might be asking yourself, why did they create something like layouts? Why not to just put the element here, and why it's not just there? Well, because there are many different types of smartphones, right? They can be different size, they also can have different resolutions, and so on. Let's choose from that menu option here, for example, Android TV. And as you can see, these two buttons are still almost in the same place, and that's because we are using relative layout that is, trying to have everything relative to something. That's why things looks very similar in different versions of your smartphones. You see this hello world is in the middle of the screen, and on the TV it's also in the middle, right? So it's very cool because you can put things, lay things inside your inside the layout, right? So there are different types. We will learn about them in the future. Let's go to from the design to text view, and as you can see, when I click on the relative layout and I use the Ctrl+H button, as you can see, we have got here something what is called hierarchy class relative layout. As you can see, we can see how the inheritance works between all these classes. So we have got relative layout, then we have view group, then we have view, and of course object. Object is the superclass of every class in Java, right? So layouts are almost views, but they are used for grouping views, right? View group, that's when you read the name of class, you should know what's gonna happen, right? So inside relative layout, so inside element like that, as you can see here, you have got the opening tag, and here you have got the closing tag. You can put many elements, right? Many views. So views, single views, right? So for example, text view, button, and then many others, right? So you can put them inside the for example, relative layout, and because this is relative layout, they will behave like that. They will be relative to something. If you do not set that they are gonna be relative to something, they are just gonna, when we, I don't know, let's copy this and let's do something like that. And as you can see, it's probably here in the same place, right? When we, for example, do something like that, as you can see, it's under it. When we added a few more things here, it changed a bit. Well, of course, we have got the same ID, we can change it, blah, blah, blah. But, well, we'll talk how this layout works in future. The most important fact for you is now that every layout is really extending the view group, and it can hold many elements, right? And all that elements will behave according to how the rules are set for the specific layout that we'll talk about in future, right? And you might be also wondering now why we have got something like resources and then layout and two files here. Why we have two files here? Maybe you have one like here, and this is the basic layout, relative one. When you do something like create new project, then next, and you click the empty activity, you're gonna have the situation like that. But if you click other one, for example, blank activity or many other, the IDE is gonna generate some code for you. And one of the generated code is called activity main XML file. And here you have got already created some layouts, and inside these layouts you have got also your content. Here we have got something like include tag that includes, as the name suggests, a layout, and you refer here to the content main, so to this one. So activity main is just an XML file that has got some additional information about your activity, well, very important one, like for example toolbar, application bar layout, coordinator layout, right? Floating action button, we'll talk about these things in future, right? But well, it holds the content of your application, right? With just this one line. Okay, so here we have got the content main XML, and inside that content in XML we have got things that are content of your applications. So for example, text view, right, button, and well, a relative layout, which is the parent of that element, right? So this is inside the activity main. Okay, and you might be wondering, why did they separate these two things? Well, because of it, you exactly know where to look for something. Hey, I'm looking for the content. Okay, so the content is here. I just need to add some elements here. Okay, but I want to do something with the toolbar. Okay, the toolbar and things that are, you know, generic. Okay, they should be here. Something like that. Okay, and of course we'll talk about different types in future. For this lesson, this is enough. So go ahead and have fun. Thank you very much. Hello, let's train a bit linear layout, because as you have probably noticed, all these elements are placed next to each other from left to right. But what would happen if I wanted to have more elements, like for example like that? But I would like to have in one row 2 elements. Well, the first thing that you would do probably is change the orientation to vertical. Okay, so it's now from top to bottom. The problem is that I have got what single item in each row. How to change that? Well, normally you wouldn't be able to do it, because linear layout is gonna place every element in each single row, and that's all. That's how the linear layout is working. But you can be a clever person and, for example, group text views inside another linear layout. So for example, you can do something like that, set the width and height to the size of the content, and do something like that. Okay, and well, we can copy it again. So right now, as you can see, we have got what, 2 items inside each row. Why? Because this is like a single item now. Okay, this linear layout and this linear layout is like a single item, and they are what, placed vertically from top to bottom. Okay, we need to also change what the baseline line to false again. Okay, so here, and let's do also something like that. Okay, and now it works fine, right? Okay, let's train a bit more, because this linear layout right now is as big as, you know, the content. Let's change the color of it. So, let's do something like that. Let's change the color to green. As you can see, we cannot see it now. Why? Because it's just as big as the content. But if we change the, for example, width to 200 dp, it's 200 dp because you have 2 elements of 200 dp, so let's change it to 300 dp. Okay, so like that, and let's change also this in height. As you can see, this looks like that. And this gravity here is gonna what? Is gonna center horizontally. So you know, horizontally it's gonna center this element, so this one and this one, because we have got now this and this element, but it's not taking into consideration these elements here, right? So we could go inside this guy and for example change the gravity to center, and it's gonna center this element. Okay, but what if I wanted to do something with this element and this element? Like for example, I like to have the only this one here. I would like to have this guy here and this guy here. What would I do? Well, I would need to probably set the gravity of the text view and or this text view, right? And well, if I set, the problem is that gravity is already set here, right, to center, and this gravity is referring to the items, to the elements that are inside the text view, and these items, these elements is for now for the text view only text. So how to position this box up here? There is another attribute that is called layout gravity, and now I can set it to the top, for example, and this guy I can set to the bottom. Okay, so layout gravity is gonna change the position of the element of the text view relative to the linear layout, okay, to the parent. Okay, so layout gravity is gonna change the position relative to the parent, but at gravity is changing the place of things that are inside the element. Okay, so that's the difference. It's very important to understand it. And of course, if I change this to, for example, wrap content, and here to wrap content, nothing would change because, well, right now the layout gravity bottom means the same as top. It means the same thing all the time, because the size of the layout gravity that it is referring to, so that is relative to, so to the linear layout, is just the same as the size of the text view that are inside, right? So this just is not affecting anything, because it's not possible. But if you change it here to 300 dp, yes, then it's gonna change it to top, or this is gonna change it to bottom, or we can change it to center. It really is all up to us what we're gonna do. Okay, so that's the difference between layout gravity and gravity. You now know that you can, group more than one linear layout inside another linear layout, because you need to just remember that any layout is just used for grouping, okay? And every layout has good rules, and these rules have to be respected by the elements that are inside these layouts. Okay, that's all in that lesson. Thank you very much. Hello, let's train a bit linear layout, because as you have probably noticed, all these elements are placed next to each other from left to right. But what would happen if I wanted to have more elements, like for example like that? But I would like to have in one row 2 elements. Well, the first thing that you would do probably is change the orientation to vertical. Okay, so it's now from top to bottom. The problem is that I have got single item in each row. How to change that? Well, normally you wouldn't be able to do it, because linear layout is gonna place every element in each single row, and that's all. That's how the linear layout is working. But you can be a clever person and, for example, group text views inside another linear layout. So for example, you can do something like that, set the width and height to the size of the content, and do something like that. Okay, and well, we can copy it again. So right now, as you can see, we have got 2 items inside each row. Why? Because this is like a single item now. Okay, this linear layout and this linear layout is like a single item, and they are placed vertically from top to bottom. Okay, we need to also change the baseline line to false again. Okay, so here, and let's do also something like that. Okay, and now it works fine, right? Okay, let's train a bit more. because this linear layout right now is as big as, you know, the content. Let's change the color of it. Let's do something like that. Let's change the color to green. As you can see, we cannot see it now. Why? Because it's just as big as the content. But if we change the, for example, width to 200 dp, it's 200 dp because you have two elements of 200 dp, so let's change it to 300 dp. Okay, so like that, and let's change also this in height. As you can see, this looks like that. And this gravity here is gonna what? Is gonna center horizontally. So, you know, horizontally it's gonna center this element, so this one and this one, because we have got now this and this element. But it's not taking into consideration these elements here, right? So we could go inside this guy and, for example, change the gravity to center, and it's gonna center this element. Okay, but what if I wanted to do something with this element and this element? Like, for example, I like to have the only this one here. I would like to have this guy here and this guy here. What would I do? Well, I would need to probably set the gravity of the text view and or this text view, right? And well, if I set, the problem is that gravity is already set here, right, to center. And this gravity is referring to the items, to the elements that are inside the text view. And these items, these elements, is for now, for the text view, only text. So how to position this box up here? There is another attribute that is called layout gravity, and now I can set it to the top, for example, and this guy I can set to the bottom. Okay, so layout gravity is gonna change the position of the element of the text view relative to the linear layout, okay, to the parent. Okay, so layout gravity is gonna change the position relative to the parent, but at gravity is changing the place of things that are inside the element. Okay, so that's the difference. It's very important to understand it. And of course, if I change this to, for example, wrap content, and here to wrap content, nothing would change, because, well, right now the layout gravity bottom means the same as top. It means the same thing all the time, because the size of the layout gravity that it is referring to, so that is relative to, so to the linear layout, is just the same as the size of the text view that are inside, right? So this just is not affecting anything, because it's not possible. But if you change it here to 300 dp, yes, then it's gonna change it to top, or this is gonna change it to bottom, or we can change it to center. It really is all up to us what we're gonna do. Okay, so that's the difference between layout gravity and gravity. You now know that you can, group more than one linear layout inside another linear layout, because you need to just remember that any layout is just used for grouping, okay? And every layout has good rules, and these rules have to be respected by the elements that are inside these layouts, okay? That's all in that lesson. Thank you very much. Hello, my friend. Today I'm going to tell you about the attribute that is called layout weight. As the name suggests, it's gonna allow you to set importance, the weight, the value in terms of how much space should be reserved by the element added to the layout. So what does it mean? When we have got, for example, three elements like text views here, and I colored them so we can see them clearly where how much space they take. And when I set the layout weight to 1, it means it's gonna take available space, remaining available space. Okay, so it just took everything but the space that was taken by this text view and this text view. Okay, but if you do something like that, when I, for example, add another layout weight and set it to also 1, and for example I add another one here and set it to 1, as you can see, all these three guys are what equal in the width, right? Why in the width? Because we have got the orientation set to horizontal and the layout weight is gonna work on the width. Okay, if I set it to vertical, it's gonna work on the height. Okay, that's how it works. And as you can see, they are where they are equal now, right? But why are they equal? Because we set the importance of each element to 1. As you can see, here is 1, here is 1, here is 1. If we set the importance of each element to the same value, they are gonna be equal, right? But you can say, hey, I want this guy to be more important and these ones to be not so important, right? And as you can see now, this text view inside is 3 times bigger than this one. Well, maybe it's not true, because we should set the value of width to 0 dp when we are using, now it's true, when we are using the layout weight. Okay, because wrap content is gonna take into consideration that it has to wrap the content, blah 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 blah. But when you set it to 0 dp, it's just gonna consider only layout weight. As you can see, now we could put like 3 blue blocks here, right? And so this pink one is 3 times bigger than this one. So how to calculate this, if you want to calculate it, for example. So you can do something like that. 1 plus 3 is 4, 4 plus 1 is 5, right? So this is gonna take 1/5 of the available space. This is gonna take 3.5 of available space. This is gonna take 1/5 of the available space. Okay, so that's how the layout weight is working. And because of that approach, so you can, for example, change the wrap content here to, for example, match parent, right? So it's gonna take all the available space in the vertical way. And as you can see now, it looks like that. And we can remove the padding that was added here because we don't need it now. And now, as you can see, we just divided the space in our application. We can change, for example, to Android TV, and it's gonna look the same, as you can see, right? We can change it to any smartphone, and it's always gonna take the same space. It's gonna take the same proportion: 1/5, 3/5, and 1/5. So it's really very, very useful to create the layout of your application. You can have here menu, here you have content, and here you can description, whatever, or you can have only two things like that, right? Here is menu, and here you have got some content. So it's very useful to use the linear layout with the layout weight, okay, like that. And it's also probably good to know that if we change the text size here to, for example, 50 SP, it's gonna, it's now working pretty fine, but it's only working fine because, I was talking about it. As you can see, it doesn't align properly, so you have to use the baseline align to false. Okay, now it's aligned properly. Okay, now it's like that. Okay, it's now good. And I'm using here text views, but you could use here linear layout. I used the text view just because I wanted to show you some text, sample text that you can we can say, hey, we are talking about sample, here we are talking sample 2, sample 3, so we can refer to things here, right? So you can use here, instead of the text view, some kind of view group. So any layout you can use here, for example, relative layout. Here you can use linear layout. Here you can use, for example, grid layout, whatever. That's all up to you, right? and you can group inside of the big boxes now some content for your app. Okay, that's all in the lesson. Thank you very much.